web app monolith is, and then it's kind of like difficult when we need to switch like the technology stack and try to understand how to run these applications on top of Kubernetes. So during this presentation, my main goal, my main objective is to share pointers about what kind of tools you should be looking at, and what kind of like methodologies and how to make this journey a little bit easier for all of us. So I will be giving pointers. I do not have the time to go in depth on all these things, but feel free to reach out with questions or whatever you think that it's interesting for me to mention as well. So the starting point is a monolith, right? So I've been in my previous experiences, I worked with companies that they had these big Java applications, and Java applications that they tend to grow. We tend to have them in just a single Git repository where all the source code is, and when you try to go deeper into the application, you will see that there are a lot of modules, there are a lot of features that are overlapping, and understanding how that application works is kind of like one of the key points on thinking and redesigning this as a microservice architecture, right? So what we are discussing during this presentation is how to go from having a monolith that have all these things to something more like this. It's just more like a distributed approach where you have different services running. You might end up using containers if you're going towards Kubernetes. So there are a bunch of things that you need to learn. And also the architecture is completely different. The way that you structure the source code, the way that you connect these different services, it's kind of like important. So I did some presentations last year where I show how to, for example, bring CI/CD into your Java monoliths. Even if you have a monolith, having CI/CD, like continuous integration, continuous deployment, and continuous development of this and improvement of this application is kind of important. So I'm running this application inside Kubernetes. I've created a very simple example of a Spring Boot application that you can go there and deploy. I will not be showing this now, but there are I will share some links about those presentations as well. We are now going to talk a little bit about more the things that you are going to find where you're working in something like this. And the first thing that you will notice is that there is no concept of an application here. There are a bunch of services now, so you need to find a way to correlate them and understand how these interactions are going to work. So you might wonder, okay, so how do we start this journey? And again, this journey is not easy and it's not short. So it's not something that I can explain over 50 minutes, but I will be just covering a few things. So this is how the application looks like. I chose to create like an example. I'm a very practical person, so I wanted to code a set of services to represent something like this, right? One of the key lessons learned that I had when I was doing something like this for a different use case is that when you have a big monolith, you will need to choose a set of things to start with, right? Like you need to understand what's the business, objective of the application and what are the core functionalities. For this example, I chose to use like a conference site or like a conference platform to publish different conference sites. In order to start, I decided to create an example of one of these conference sites with a set of modules, right? So the application looks like this. And if I click here in the link, I have that application running in Kubernetes already, in a Kubernetes cluster. So it has like an agenda with 2 days and also a way to submit proposals, right? Like live from Jnation. And that's me, and that's my email, right? And here's an abstract, right? I tend to like writing long abstracts. So I can do that, like as a potential speaker, I can do that. And then there will be like the committee of the conference that can go to the back office and accept or reject proposals, right? That's kind of like how it works. If I accept it, I should be able to see that in the agenda. If I reject it, nothing will happen besides sending an email with the rejection notification to the speaker, right? And if I get accepted, I will get an email with that as well, right? So I approve that, and I should be able to see that somewhere here, right? So that's my proposal. It went live into the agenda. Also, I just want to mention here that I have another button here where I can send emails, random emails to anyone involved in the conference, just because it's another feature that I will need in order to communicate with the potential speakers, right? Just to show that it's live and it's running, and I'm not sending an email, I'm just doing a printout in that service where I can just get that email saying, yeah, I got accepted into Jnation in this case with my proposal, right? And it was approved by the conference. I will get a similar email if I got rejected, right? And that's running inside the cluster. I'm just filling the logs of one of the containers. So that's kind of like what the application is. It's like kind of like the use case that we will be looking at. There are a lot of things, there are a lot of angles for this application to cover. So I will get started with how, right? So how do we go in this journey? How do we start? First of all, something that everybody is mentioning nowadays, that Kubernetes is hard, right? And Kubernetes is particularly hard for Java developers for some reason, because we are not used to working this way. We were used to deploy our applications in, in application servers or in server containers. And when working with containers, it kind of like changes the game, right? So first of all, what you need to understand is how to work with Kubernetes. You need to understand how Kubernetes works. And then most importantly, you need to understand how to take your source code that you have in a Git repository into something that is running inside Kubernetes. And that it's kind of like, again, it's a long journey, but there are tools that will help you around that journey, and they will simplify your life. And I will be showing one of those tools in a bit. And also, like the Kubernetes community and ecosystem, it's continuously evolving. So you need to make sure that you keep an eye on how people is using these tools, how other companies are going through this journey, right? You cannot reinvent everything. And the second thing that I think that it's way more important as well, it's that you need to understand your business, right? You need to understand the reason why you're doing this re-architecture, and you need to make sure that it's completely justified. And domain-driven design is one of the things that people tend to recommend to look into, because they provide like some very practical and theoretical concepts that allows you to understand how to do this split, how you can start splitting services, how can you organize your teams, how can you organize your source code, how can you expose well-defined APIs to do things. But let's start with the technical implications, and I will be just mentioning one of these projects, which is JenkinsX. That's kind of like one of the projects that I loved. I've been involved with this project for the last 2 years when it was created. And JenkinsX is basically that. It's providing CI/CD for Kubernetes, right? And the whole idea is that the project will allow you to register your source code repository into the JenkinsX installation, and that basically will allow JenkinsX to decorate your project, to create a pipeline, and to run that pipeline to build your project, build containers, and create all the YAML files that you need in order to deploy your service into Kubernetes. So I've been using JenkinsX for a long time, and I've created, as I mentioned before, this example that it's a bunch of services that you can find there in my GitHub account. And let me show you one of these services. Let's see if you can see here. So this repository, it's pretty simple. It's just, again, another Spring Boot application with a POM file and a source directory. And what I did here with JenkinsX is that I imported this repository into a JenkinsX installation that I have running on Google Cloud here in a cluster. And basically what JenkinsX did when I first imported the project, and again, it was just a plain Spring Boot application, it created a Docker file. It created a pipeline, a JenkinsX pipeline, where the only thing important here is this line, that it's a Maven project using Java 11, right? So it automatically recognized that it's a Maven project because it has a POM file and some Java classes. It created the pipeline. It's based on conventions, so it kind of knows what to do for building a Maven project and then creating a container for it. And finally, it added like the Helm charts. And Helm is a very, very important tool that allows you to package these YAML files to describe how to make a deployment, right? And it uses templates in order to make sure that you can deploy the services into different environments with different values and different parameters. So JenkinsX at this point did 3 things: created a pipeline, created a Docker file to create a container, and then created a package for making sure that we can deploy this into Kubernetes. But it also relies heavily on conventions on how to deal with changes on this repository. So it created some webhooks in order to understand when the master branch changes, and it will automatically trigger pipelines as you are used with normal Jenkins, right? You make a change, it will trigger a pipeline. You create a pull request, it will trigger a pipeline to validate that the pull request is fine. After we made any change in the master branch, we will get a new release. And I think that it's super important. This is conventions. It's best practices all put together onto a tool that you can use, and you can start working in this way. Remember that one of the key points of working with microservices is that you can evolve these services separately, right? So you have one team making sure that they make improvements into the service, and another team working in a different service. they can continuously improve, and you can continuously deploy these improvements. So just to show this, is that something here, I have version 17, and if I show you here the send email panel, I'm using version 17 in here, right? And that basically means that if I go and change the source code for that service, I will automatically create a new release. Usually, I wouldn't do this by changing the source code here in GitHub. I will do it in my IDE, and I will not do it in the master branch. I will create a PR for that. But for the sake of the demonstration, I will just make a change here quickly, just to trigger the pipeline and see how that changes, right? So let's say that I want to change something here in the string that it's returning the version. And I will do that something here, right? So that's pretty much it. That's my change for now. The pipeline will be triggered because I made a change in master, and at some point I will get like a new release here, version 18, and I should be able to see the change in here. It's important to notice that Jenkins X use this idea of GitOps, and they have different environments. So as you can see here in the URL, maybe it's small, but I'm running on a staging environment, and I have another environment for production. By default, every time that I get a new version of one of my services, my service and the release of that service will be promoted to staging. That's why at some point, the pod that it's running here, the email service, is going to get restarted, and I will get the new version of that service running in here. We should be able to see that later on during the presentation. For now, let's go back to the slides. So that's all about Jenkins X, right? But again, the big question here is, okay, but how do I know how many of these services do I have? How do I make sure that I split them in a way that makes sense and I'm not over-engineering things or going to micro, right? And that's where, again, DDD comes into help. I will not go deeper into these concepts. There are like books about this, and definitely I do not have enough time, but definitely you should check this, right? So bounded context is that idea of we have a well-scoped set of features that we are going to put together. They make sense for the business to be isolated in some way. They will expose a well-defined API. It might be a REST endpoints, it might be messages or events, and there will be a small team with domain experts in it. They will build it with domain experts, so domain experts can understand what that piece of software is doing, right? That's in 5 seconds what the bounded context is, but you definitely need to look into it. And this will make a lot of sense when you understand what the business is, right? When you understand what the application is supposed to do, what those set of features are supposed to do, it will be super clear to you what your bounded contexts are. Jumping to the practical side, right? Like not to the conceptual side of what a bounded context is. As I mentioned before, Jenkins X kind of like relies on these conventions of having one repository, one service. And that allows you to have these separated release cycles. So this will allow these small teams of people to just keep working and improving their things. And then, because they are exposing a well-defined set of APIs, will enable other teams to look into those APIs and plan based on these release cycles. Of course, I'm showing you here just again another repository, one of the services that are there, like this is the agenda service. And again, this will work in the same way with different releases and all that stuff. And also using open APIs. Of course, I'm using open APIs for the service. So I'm just going into the Swagger UI here, and you can see what are the endpoints that are exposed by the application. And again, because this is in GitHub, you can find how I did that, just adding just a simple dependency on the Spring Boot app. You will get that, right? So that's pretty much it. Nothing super important, but I think that it's important to understand that if you're working with bounded context and services that have their own release cycles, you will need to share this with other teams, because this kind of like it's some way of your contract to other teams, and this is kind of like what you will need to maintain over time, define what like backward compatibility means for these endpoints and all that stuff. And that takes us to the next concept inside DDD, which is super important, which is context maps, right? So now we have a set of bounded contexts. How do they relate to each other, right? What's like, do we have an upstream or downstream relationship between these services? How they are going to integrate? Who is going to consume what? How are we going to version our APIs? How can we make sure that we don't break everything when we change a single service, right? And on the practical consideration for that side, I think that consumer-driven contract testing, I find this pretty serious and pretty useful in the sense of that if you are not doing this, you should be thinking of doing this and getting this into your projects. So consumer-driven testing is based on Spring Cloud Contract, right? This is one of the frameworks that already implements this. And it's a tool that allows you to implement, to define contracts for your APIs, which can be automatically translated to tests and executed against your services. So if we go back to the presentation, let me show you what a contract looks like. This is a super simple contract. Forgive me, this is kind of like the example is a work in progress. I will keep adding stuff on top of this. But this defines a contract that basically says, we have, this is the call for proposal service. And every time that we get a new proposal, in order to get a new proposal, we need to send a post to this URL with a body like this, right? That's what I was sending via the forms. And this is what I should expect to get back, right? Like in this case, it's just the ID for that proposal plus all the things that I've already sent. And as you can see, you can define variables here just to create the test and to submit data, and that's to make sure that we get the data back, right? This is defining a contract for the API, right? Like of the fields that we are going to, that we need in order to accept the proposal, the things that are required or not, the kind of data that we are sending and all that stuff. A Spring Cloud Contract allows you to automate this and create a test. So every time that I build my application, my call for proposal application, I will create a test that will start the endpoints, send this data, and expect and assert that this data is back. So we will automatically generate some Java code for the test, and it will run that every time that I build my service, right? Request, which is super interesting and something that you will do anyways. But what it makes it more interesting for me is that just that my applications are creating, right? If you have multiple teams, you will definitely need something like this in order to share your jars if you are into that, right? So what's important here, let me make it bigger, is to see that besides the jar of my application, my Spring Boot jar, I'm also creating something that is called stubs, right? So let me go back to the presentation and show you the test. So, and this is super important because at some point you might want to, you will have this problem of, I'm building this service A that depends on service B, but in order to run the test of service A, I need to have service B up and running, right? And that's definitely not in a scenario where you want to be, because if you depend on those two things, maybe service B depends on the database, it depends on a message broker, and it depends on a bunch of stuff that you don't want to have running in order to run the test for service A, right? So contracts allows you to do this. They allows you to define this stub, this extra jar that you can make a reference via, like a group artifact and version here. And you can then, when you're running your test for service A, in this case, you can execute a post request against this stub server that it's been automatically started by Spring Boot in this case, right? So this is super, super useful because now in order to test A, you don't really need B. The only thing that you need is the B stub that it's already automatically generated when you define a contract. So that's super interesting. Also, it allows you to understand how versions relate to each other, right? Because the stubs will have the same version of the service, and because tests on other services will start failing with the new contracts, right? And at that point, on service A, which is the one depending on service B, you can start defining on to move to the next version of the contract or to stay with the old version. And in that way, you can start defining the dependencies between these services and these versions. There are some other things around that, around versions, but I guess that will give you kind of like a good idea of that's important. This is something that you should have. And contract testing and Spring Cloud Contract in general, it makes it really easy to use and to consume. So definitely think about looking into these technologies because they will save you a lot of time down the road. But going back to domain-driven design, right? Bounded context and context maps are super useful. But again, as I mentioned before, I'm a very practical guy, so I tend to really like to work with flows, with use cases, right? And this is basically, this diagram here is representing the use case that I showed before, in the sense that we are just representing the steps for submitting a proposal. And then what happens that it's like the committee or the board will approve that. And depending if it's approved or not, what's going to happen. If it's approved, I'm going to send it to the agenda. If it's not approved or approved, I will send a notification to the potential speaker about the decision, right? And this is something that we can all relate. Like I can see this diagram and I can understand it. We can also look at the code for that, which is not the best code ever, but I wanted to highlight a couple of things, right? Like this is not, don't take my coding standards as the best, but just as an example, right? So I wanted to show here that there are two things in this controller, which is taking the requests, right? So in this case, the new proposal one, pretty simple. I have, let's say, a database or a storage where I'm just getting the proposal from the browser and just storing it in the database, maybe emitting an event for any other system that it's interested in this happening. So I received a new proposal, maybe there is another system interested in reacting on that. You can do that. And the other important one that I think it's where the key logic lives here is the decision, right? Like this is the board decision and what happens after the decision is made, right? So whenever I went to the back office and click accept or reject, I'm just sending to this endpoint. And this endpoint, basically, it's picking up that decision, it's approved or rejected. It's picking up the proposal from the database, let's say, and if the proposal is there, I will just apply the decision, the Boolean, whatever it is, if it's approved or not. I will change the status of the proposal. This is pretty typical. I'm changing the state between these things. The proposal was pending before, now it's decided, so there is not much more to do. And I'm updating that proposal to the database if I need to. But then here, look at this. So in this case, I'm checking if the decision, if the proposal was approved or not. If it was approved, I will need to call another service, the agenda service, to create an agenda item. And no matter what, I will need to use the email service to notify the speaker via email, right? These two are services that are defined here. And at the end of the day, they are just encapsulating some REST requests. Let me show you that. I think that nothing too important, but just to show that I'm doing a post request into a URL, and this URL is being loaded as that, right? Like by default is that, which is the Kubernetes service name that I'm using in order to interact with this service or this container. And I'm using service discovery there in the sense that I don't know where these containers are. I don't know which port are they running on. The only thing that I know is that I have this string, and if I send a post request to that string, Kubernetes will make sure to arrive to the right container, right? That it's running that service. And again, I'm doing a REST request here, right? So nothing too important besides noticing that I'm using REST template. You can use, the new reactive web client as well if you want to. So that's the code, right? And believe me, I've done this several times. And the main problem with this is that, as you can see, the code here, it was pretty easy to understand, right? Like we looked into, for example, the decide definition here, where we kind of like define what happens next. Let's say 10 lines. This, if we send the events and all that stuff, it's just 20 lines max. It's not big, right? But we know Java applications. These 20 lines of code in a year, it's going to be 1,000 lines of code, right? So there are a couple of considerations to have in mind, right? Like when you're building this. And again, the idea here is not to over-engineer, but to be aware that things will happen and that the code will grow and that the complexity will, ended up like making this a little bit more obscure and difficult to understand. And we definitely should avoid doing that, right? And that's kind of like one of the main DDD's, premises there. Like if we need to keep it simple. So first thing is that we have dependencies between services, and that's not a bad thing per se, right? But as you might notice, I'm doing post requests to different services that are running in different containers, and I'm not checking if that's working or not, right? And if I'm not checking, right, like if I'm just letting my calls fail, we might end up in very inconsistent states where I accepted someone, but I never notify them, or the other way around, I notify them that they were accepted, but I never created that entry into the agenda item, right? That's pretty bad, and we need to take care of that, right? And there are different routes. Some of the things that you can do is you can use libraries to do retries. You can use something at the Kubernetes level to do retries for you automatically. That's more like on the infrastructure level. You can use messages. You can use messaging in order to make sure that you have retries on the brokers. And any of these decisions will make your application more complicated. An important side for me, it's like the flow. In this case, this flow that I've showed before, it's buried in code, right? So again, as I mentioned, in that decision method, this kind of logic is where it's created, it's where it's encoded, right? And it's hidden in there, right? It's pretty difficult to expose that to people that it's not coming from IT to understand how these flows look like. Edge cases and unhappy paths, it's what makes basically your code sucks. And when you start adding if else or switches and more logic there to cover these edge cases of what happens if a speaker that looked really interesting completely disappeared, right? We need to start adding more code to check all these things to make sure that we keep a consistent state and to make sure that we provide a tool that it's useful for for the people that it's running the conferences. Time-based constraints is more of that. It's like, okay, when you have cron jobs or when you need to have this kind of like alerting mechanisms based on time, right? Like a proposal was created and the board, the committee didn't look into that for the last 3 days. We need to make sure that they are aware that this is sitting there and waiting for a decision, right? And finally, implementing queries and analytics. I've seen this happening a lot of times, right? As I showed you before, every time that we get a proposal, we store that into the database, let's say. And the way that we store that into the database might not be efficient for searching this data or for doing reporting or analytics, right? Maybe for conferences is fine, but if you are going with large amounts of data, it becomes more complicated. What I've seen people doing kind of like a lot of time is sending that to the database and then just storing that, for example, in Elasticsearch to make sure that it's indexed. And if you are trying to do searches like advanced search or full text query searches, you go to Elasticsearch instead of going to the database to get that data. That's kind of like a common pattern that you will find. And of course, in order to solve some of these things, you will maybe try to use one of the existing tools to solve all these problems. And because I've been working on the workflow space for some time, I wanted to just talk a little bit about that. And because I'm also working in one of these projects, it's kind of like good for me to share a little bit about what these tools are doing and how you can quickly use them. So workflows basically allows you to define kind of like the sequence of things to do, and they add some flow control, right? Some kind of like decisions of, okay, if I have this value on this property, I can go that way or the other way, right? Which is pretty relevant for the use case that we have here. And it allows you also to delegate the execution of the business flow to an external component that it's not your service, but your service still defines kind of like what's the flow of things. And by default and for free, they give you like business visibility and continuous improvement, right? You have a quick way to change this flow and these interactions, and automatically data it's going to be exported for people that it's not IT related can see what's going on, right? Like how many proposals are we getting every day, and creating these kind of reports. On the practical side, that's basically service orchestration. And how you do it is you basically have something like a workflow engine that allows you to do this microservice orchestration. That's why I want to talk a little bit about CV, which is a project that was created based on on 10 years of experience on workflows, but with the cloud native architecture. And it's created just to for these like super scalable scenarios. Like in the conference scenario, it's not like that. It's not super big unless you have thousands of conferences happening at the same time. But it's pretty relevant for other use cases like healthcare or Wall Street, like trading, that kind of stuff where you need low latency and high throughput. It's important to know, and this is not specific for CV, but at this point when you start analyzing external tools like third-party tools that you're going to integrate with, that you will find them in different flavors, right? Like as a software as a service or on-prem, right? Like you want to have control of the installation and put it like in your own Kubernetes cluster, so the data is still in your control, or you can use a managed service where you just delegate running that thing, that third-party component, to a different company, right? And both have like their advantages. In general, dealing and installing components in your own prem cluster will push you to maintain that and to understand how to, if there are upgrades, how do you do upgrades, and if you need to do data migration, or if you need to move to a different cluster, how you take all the data and move it to a different cluster. So it puts the burden on you, but you have full control of it, right? So you can do both. And in CV, it's both, right? I will be showing a demo of like the SaaS approach, but I could be doing the same thing on-prem on my Kubernetes cluster where I'm running my services. So this is how it looks like when you have like a workflow engine and you try to use one of these tools. And again, this is valid for any other third-party tool that you want to use. But in this case, if you're using a workflow inside the call for proposal service, you will kind of like define what the flow is in a graphical way, right? In this case, we are saying we get a new proposal, we need to wait for a decision to be made, and then we need to choose if it was approved or rejected. If it's approved, I will publish it to the agenda and send, an email to the speaker that it was approved for the conference, or I will send a rejection email here, right? And each of these, blocks at the end of the day will interact with the service, with the real service that is running inside Kubernetes, right? And there is not much to do for that, right? By using a workflow engine like this, again, you define this belongs to this service because it's part of the logic that the service needs to execute, but it's executed outside. It's executed in a different component, which is basically running this thing and also extracting data to Elasticsearch. As I mentioned before, we want to make sure that we have data where we can just run reports and we can understand what's going on from, not from the application perspective, but from, more like a business perspective. So I can use this tool that it comes with CV, and it's called Operate, which basically allows me to see, these flows in a graphical way. And it allows me to see the execution of these flows. As you can see here, I've submitted, 5 presentations before that were accepted and 1 that was rejected. And if I go back to the application, which I have somewhere here, let me see, let me go back. Where is it? Like too many tabs. Probably here, and it's pretty much that. I have like 5 that were approved and 1 that was rejected here, right? And of course, that I can see here, like all the timestamps on each of the instances. I can see the data that it was used and the path that it was taken, right? I can see that it was approved, the status is decided at the end, and I can see in every node when did that happen. And there are some scenarios, let's say healthcare is when you're dealing with the patients and doctors' interactions, you definitely want to have all these for auditing purposes, right? There are some regulations in different industries that requires you to have these kind of things. So that's how it looks when you use a workflow engine. And again, I've done some presentations where I show how to move from the Java implementation to use something like CV in this case. We can take a quick look on the source code for that thing. The application, the master branch is running with that. That basically means that I'm running with the workflow engine here. And you will see that it's not much, just add a client to interact with this service, which is somewhere there. It should be somewhere there. I'm not even sure where I am. I am in the no workflow thing. That's why it's not there. So it here in the master branch, it should be there. So we have a client which will connect to this workflow engine that it's distributed. It's running in Kubernetes. In this case, it's running in Camunda's managed service. It's not even running in my Kubernetes cluster. I can see and I can just connect to it by just sending some environmental variables with my credentials. Pretty much it. And then inside the source code, you will see that it's a big change because now I do not call the services directly. So I removed all the services references here because now the workflow orchestrator is going to decide how to do that, right? So this is pretty much what I was showing before. When I receive a new proposal, I store it in the database. But then what I do is I kick a new instance of this workflow, which is what I was showing here in Operate, right? Every time that I receive a proposal, I will have a new instance of this diagram that will go through different paths. Going back there, where was it? Yeah, and then when I want to make a decision, again, I do not make the decision here. I just publish a message saying, yeah, this was decided by the board member, workflow engine, just decide what to do next based on the diagram, right? It's important to mention here that we can have different versions of the diagrams, right? So for one of these workflows definitions, I can create a different version to change the interaction, right? Let's say that this is not the right order. I want to send the approval first before publishing to the agenda. Or even more importantly, I want to make a big change, right? I don't want to publish to the agenda unless I have a confirmation from the speaker that he or she is willing to speak in our conference, right? And when they approve that, we want to move forward, right? So I can do that. I can open, this diagram in a modeler, what we call a modeler, where you can easily drag and drop things and move things around, right? So what I will try to do here is I will try to do this live. It might fail as usual, but let's give it a try. So what I'm doing here is I'm adding a new wait for speaker confirmation, right? So I have wait for speaker confirmation. I don't want this. I want to make sure that I only do this if the speaker gets approved. And I will just connect that there. So basically now I've introduced a new step that is basically waiting for the speaker to confirm that he or she wants to speak at our conference. I need to define what kind of message and some kind of like correlation, right? Like I need to receive a message saying, yeah, I'm talking about this specific proposal. And I think that proposal ID. This is key in order to work. So basically, I will need to send kind of like the proposal ID in order to say, yeah, I'm confirming that I want to talk about this specific proposal, right? So I made that change. I will save this change. In theory, as I mentioned before, this will belong to the call for proposal service. In this case, I will go here, and I can do, so I'm there. Yeah, so I can do that. In reality, I will just create a pull request to validate these changes. But in here, because I'm doing a live demo, I will just deploy that to the cluster just to get a new version of the diagram up and running, right? And I got version 9 with the changes that I made. So if I refresh this tool, I can see that now I have version 9. And the application by default is configured to use latest version. So that basically means that if I go back to the application here, first of all, we can refresh the application and I can check that I have the new version of the email service. Again, that service is evolving automatically. It's not changing its APIs. That basically means that I can just do an upgrade and I can use the new version, right? I just changed that, so I know for sure that it's working. Again, I'm in a staging environment. This is where you are supposed to find issues if they appear. Also, you are supposed to find issues in the tests, in contract testing. If that's not good, you should be checking into this environment that no APIs are broken. But now, if I submit a proposal, live with speaker confirmation, yeah, I will do that. Test, right? So I will send that. I will get a new proposal in, right? So I should be able to get that here in the backend. I get that in, and I can see here in my executions, at some point I have that, right? So I'm waiting for a decision, right? Again, if you have thousands of these proposals coming, you will see how many of them are stuck here in the decision point, right? I can go back to the application. I will accept this because it's just a test. And before, I should have seen this here. I'm not seeing it there now because, of course, I'm waiting for the speaker confirmation, right? So this is pretty much what I'm showing. At that point, if you are creating these kind of changes, you will have another service, probably like another form in the website or another section for a speaker to check, or maybe you want to send an email with a link to allow the speaker to click there and say, yes, I'm confirming that I want to participate with this conference. So in this case, I've created like a very, very small service where I'm simulating that link creation, right? So I have a service already running, and here is where I show a little bit of Jenkins X. And how I have Jenkins X command line tool here, the one that I'm using for the pipelines. For some reason, I cannot type in this window. That's the screen sharing magic. Oh, damn it. Let me see if something is reacting or if I need to open a new terminal here. New window. Let's see. No, interesting. My terminal is not typing, so it's not allowing me to, there you go, the focus, right? So what I can do now is I can do something like this. I have a service, applications, and Jenkins X, they are called applications. They are like the services that I have running, and you will see that I have the agenda service that I can go and access. When I access and show the open API endpoints, but it's because I was accessing these URLs directly. And I have the speaker service that I have here, which is basically that. It's basically creating a link or having an endpoint where it will receive the proposal ID. And if it receives the right proposal ID, it will just confirm that the speaker wants to speak at this conference, right? So I can do a curl. That's a post. And you can see here the long ID at the end. But because I just created this proposal, I need to go and grab the ID, which is basically, if you're going to send an email with that, you will have it already, right? So what I'm doing here, I'm just copying this ID, and at some point, this should just notify that the speaker is confirming the participation on the event. So it's confirmed. If everything is working as expected, at some point it should move. Believe me, if it doesn't move, well, something failed. But yes, it moved and it sent an email, right? So that's how quick and easy it is to make a change. And again, going back to things that you can do with this is more advanced stuff, right? Like that's a pretty basic change, but you can do stuff like, for example, adding a timer here. So we can add a timer, and that timer can say after 2 days, if I didn't hear back from the speaker, I would send another email, right? Email reminder. right? And if this gets completed, this timer is canceled, of course. But if not, I will send a reminder every 2 days or something like that. I can create another timer to say after 10 days, if they are not answering, I will just send a rejection because I need a timeout, right? Like I cannot wait any longer for you. I will just reject your proposal because you're not answering my emails. That kind of stuff. And that's pretty powerful because in order to create that timer, you don't really need to do anything. At that point, you are delegating everything to this external component that it's dealing with these timers, and also reporting everything back to this, to Elasticsearch, which can be, graphically seen in this operate tool. So that's kind of like the demo that I have for today's session. There are a bunch of takeaways. In general, Kubernetes is hard, right? And again, I'm not trying to say that with this, you will solve all the problems that you have. But what I'm trying to say here is that you will find different tools, and you will need to optimize your decision-making process around what to build yourself. Like in the case of this, you don't want to build a workflow engine for sure. You want to use something that's already existing, and then you need to understand how to integrate with it, right? In these very polyglot environments like Kubernetes, where you can just run containers that are written in any way, you will heavily rely on their APIs and on their version streams. And on the other hand, I want to again make it clear that you need to make sure that you focus on business value, right? So again, why are you doing all these changes? Why are you making this big re-architecture? It definitely needs to make some sense for your business. And feel free to reach out to me via Twitter if you want to follow me on Twitter. And I'm also working on this workshop, kind of like guide, that it's called From Monolith to K8s, where I show you how to run all these examples in your infrastructure, because I believe that by running things and by looking at projects that are already working, you will have a way much easier life on deciding which tools to use, or which frameworks to use, and how to apply contract testing, for example, for your projects. It's super open for contributions, so feel free to reach out, and that's pretty much it, my presentation. If you have any questions, please feel free to reach out.
Thank you very much, Mauricio. Great talk. We have a couple of questions here on Slack from the guys. Jonathan Villa, I'm gonna read like 2 questions at a time and go over them.
I think that I know Jonathan. Let's see.
So yes, the first one is, Mauricio, you have talked about DDD and link it to microservices. So everything must start from that DDD approach and see if our bounded context team's definition leads us to microservices or to monoliths. And the second one from Jonathan as well is, Mauricio, could we agree that monoliths have the complexity of the code, and moving to microservices, we move that complexity to orchestration, traceability, transactions, etc., and we have to take very carefully this decision?
Yes, totally. So we agree on those 2 points. I think that, yeah, we totally agree with that. So if you are heavily on DDD, yes. So you need to make sure that you do that first. Some people, it's a little bit more practical. They just try to see how it goes, and based on their experiences, they make the right decisions to make the projects work. I tend to agree that we are switching the complexity from the monolith to the infrastructure a little bit, but there are some cases where that's completely justified, right? If your application wasn't scaling enough and you needed to re-architect some pieces to make sure that they work, massively in large-scale systems, that's the only way to do it. It's like you cannot escape with a single monolith. Of course, that there are trade-offs, and as I think that I mentioned several times during my presentation that this is kind of like a complicated journey. It can be done. The tools are getting better and better, but you need to be aware of that.
Yeah. So we have another question here from João Rebelo, and he says, I assume ZBs would support compensation actions to support transaction failing in the process.
Yes, so there are a couple of things around that. So there are a couple of things about transactions in there, right? Something that I didn't show is that every time that I'm executing, one of these service interactions, there is like a pub sub mechanism where basically you can interact that with retries. So it's definitely, so you can definitely implement compensation there, not on the diagrams just yet. That's something that is coming along the ways. But not yet like on the diagrams. I guess that's why he's asking. But definitely you can implement compensations on retries. And also like the graphical tool allows you to quickly see when something went wrong. So you can see, okay, that service was down for more than 3 retries. So you can just go and schedule another retry when you know that the service is up and running again. I didn't show in my demo either that if all the services are down, the orchestration engine will know and it will wait until the services gets back up in order to start the execution, which is kind of cool and something that you get out for free there. And if not, you will need to implement that with different things.
Yeah. So we're running out of time, but we still have another question here from Gonzalo Silva. Yep. He asks, does ZB support some form of transaction between multiple services, like distributed Saga?
No, yeah. So you can implement the Saga pattern with ZB, and there is a blog post about that. I will be creating a blog post and sharing that blog post with my presentation and the links to the examples, and I will link the Saga pattern implementation with ZB. When we talk about distributed transaction, it is a pretty complicated discussion about how do you implement that. There is no distributed transactions in ZB, but the orchestration engine is keeping track of what was executed and what not, right? Which is something that if not, you will need to do again with the distributed transaction framework or something like that.
So I guess we are out of questions. We're also out of time. So a big thank you to Mauricio, and we hope to see you back here at Jnation 2021, hopefully on site and not on Zoom. But a big thank you, Mauricio. And guys, grab a quick coffee or a quick snack, and we'll see you back here in about 5 minutes or 6 minutes, actually. See you later, guys.
Thank you very much.
So, welcome back, everyone. Hope you enjoyed the first session and the quick break. We're very sorry for the hiccups we had with the YouTube streams at the start of the conference. It's our first full online conference, so you guys know that we are not that experienced in this area. But we hope everything is fine now and everything will be good to go for the remainder of the conference. For everyone that was not able to see the intro from the previous session, my name is Daniel Pando, and I'll be hosting the first few sessions here at Almedina. And I'd like to start with thanking everyone attending, thanking our speakers and our sponsors as well. And here I'd like to leave a special thank you to Ayosha Kretek. Ilby is the co-founder of Ververica and is going to present a session on the long road towards unified APIs in Apache Flink. So if you're ready, Ayosha, without further ado, I'll leave the stage to you.
Well, thank you for the introduction and thank you for letting me speak here. So I took out the long from the title because the road is not that long, but it's still interesting. So let's dive right in. There's 4 things that I want to tell you about today. The first thing is what is Apache Flink, because that's what you need to know to understand the other 3 points. Then we will talk about why there are different APIs in Apache Flink. And then this leads us naturally to the third question, why do we want to unify these APIs? And what does it mean to have unified APIs? And the 4th point is describing the road. How will we actually get there? And the interesting bit here is that the first part is actually the longest part of the presentation, because once you understand what Apache Flink is and what it does and what the APIs do, then the other 3 parts, or let's say the middle 2 parts, they follow somewhat naturally from that. So before we go into this, I want to quickly talk about Ververica. So Ververica is a company that employs the original creators of Apache Flink, and we do develop an enterprise stream processing platform that makes it easy for companies to use Apache Flink. And somewhat recently, the company was acquired by Alibaba. So before that, it was known as Data Artisans. Now the company is called Ververica, and we're now a subsidiary of the Alibaba Group. Some background information about me. So that's a picture of me 5 years ago, I think, wearing the same T-shirt. It still looks roughly the same. So in 2008, I started studying computer science. Then in 2009, 2010, this is some interesting background information. The first papers on Stratosphere were published. So Stratosphere is the research system, open source system, on which then became Apache Flink later. I started working in the group at the university that developed the Stratosphere project around 2012, and there I also met the founders of the Ververica company, or back then Data Artisans. In 2014, Stratosphere was renamed to Apache Flink, and it moved to the Apache Software Foundation to allow us to develop Apache Flink fully in the open source. Ververica does not own Apache Flink; it's owned by the Apache Foundation, and we are open source contributors to the project. In 2014, Java 8 was released with support for streams and lambdas. You will see in a bit why this is important, because the APIs look somewhat similar or familiar. Also in 2014, we founded Data Artisans with the goal of developing Flink in the open source. You can also see that's my Twitter handle, that's my Apache email, my Ververica email, and my website, which is just pointing at my GitHub profile, basically. So with that out of the way, we can look at what is Apache Flink. We're going to unpack this in several steps. So the first, let me say that Apache Flink is a distributed data parallel processing framework. And let's see what that means. Sequential computation as opposed to data parallel computation, is when you compute a result in sequence. So say you have a sequence of numbers and you want to compute the sum of them, you can sum up the numbers one by one. So you do 1 plus 2, then you do plus 3, then plus 4, and at the end you would get a result which is 45, if I didn't make a mistake. Yeah. So that's sequential computation. Data parallel computation, on the other hand, is a programming model or a paradigm where you split up individual packets of work and you compute results independently, and then you combine those results together. So for example, for computing the sum of numbers, you could first sum up the first 3 numbers, then the next 3, and so on, and then sum up these numbers. In this example, it's obviously not a lot of use to split up this computation, but if those individual computation steps are very processing intensive, for example, if you want to apply a machine learning model on some individual data or compute an aggregation result over some very large data set, that's where the power of this data parallel computation model comes in, where you can where you specify a computation that you can then run in parallel on many different data items, possibly on multiple machines, for example. And that's why I initially mentioned this Java 8 Streams API. The Java 8 Streams API is actually an API that allows you to express data parallel computations in Java. So here in this example, we create a list of strings that has some JSON data in it, in those strings. Then we create a stream from that list, and we say that the stream or that computations on that stream should be computed in parallel. And I think here it depends on the backend, but for Java, for example, it can use multiple threads in parallel to compute these results. And then we specify the different computation steps on this stream. So here we say we first want to apply a map operation, where a map is just saying, given some input, produce some output, and this transforms each element of the stream, possibly in parallel here. And here what we do is we parse the JSON string into a POJO object that has fields and method that allow us to work with that data. Then we apply a filter operation, which would only let through those records or those data items where the age is above 18, and then we apply the count collection on it, and then we get a result which tells us which people in this JSON data were over 18. So that's already a more useful computation that you can express with this data parallel computation model. And the Flink API actually looks very similar to the Java 8 Streams API. But the thing is that this API was developed and released before the Java 8 Streams API was released. It's just some interesting historical tidbit. So with the Flink data stream API, what you can do is express data parallel computations, just like you can with the Java 8 Streams API. And here, what we are doing is we are saying we want to read a text file. Then we want to apply a map operation on it. That's the same operation that we use in the Java 8 Streams API. Then we want to filter it. Then comes an operation that is specific to Flink here. We say we want to partition that data by a region, because partitioning data allows Flink to send these computations or execute these computations on different distributed machines. We'll get to that in a second. The next operation we say is we want to apply a window operation on this stream. So what we're saying here is, instead of computing a result, for example, these counts for all the data, so from beginning to end, we want to split our stream into windows of 1 hour so that we get these results, these counts for each individual window. So for example, then we could say at 12 o'clock in this stream of data that we're reading from this file, there were so and so many people above the age of 18. And then what we do is, in our previous example, we specified the count operation. What we're doing here is we use, in Flink it's called aggregate. and we can give it an object that describes how we want to aggregate that data. And what this does is counts these individual people by region, because before we said we partition our data by the region using this key by. And then as the result, or as the final step, we want to write that result out to some file again, because using the Flink APIs, you wouldn't get the results back as a Java object, but you want to write them out. You want to read that from a file and write that to a file. And the reason why this is so is basically the next step. So once you have, or in Flink, in the APIs, you specify your computation using these APIs. And what these API calls do, or what the code does, is doesn't actually compute a result, but what it does is it builds up a graph of these operations. So for our example, we would have a source, then we would have a filter, then we would have this aggregation, and then we would have a sink. And Flink understands this graph. And what Flink then does, what is the power of Flink, is it can take this graph and split the computation among different execution nodes. So with Flink, so all these boxes here, they would be different machines, for example, in some clouds, or AWS, or in Google Cloud. And what you typically have is you have a Flink master. This is the process that knows the whole graph of the computation that you want to do. And this orchestrates the other machines, which are called Flink task managers, to do this computation. And these Flink task managers, they might have different subparts of this graph, or they might have the same graph. So for example, if one part of the computation, for example, if the JSON parsing is very heavy, then these task managers, they would potentially have more instances of this JSON parsing task than of the other instances. And what Flink does is take care of serializing the data between the different computation steps, sending the data between those steps, and making sure that the overall computation works according to the data flow graph that was created from the specification of the program in the API or in the SDK. So that's what Flink does. It's a distributed data parallel processing system. Let me add some more adjectives to that. So Flink is also fault tolerant, and it is stateful, and it is a stream processing system. So what does that mean? In this computation, or in this graph that we specified earlier, some of the operations are actually stateful operations. So this one we call stateful because the counter in there that counts these different users per region and in these time windows, it needs to keep track of, basically the count is the state. So it would, for example, process one user and it updates the count +1. Then the next user record is processed, it updates the count to 2, and so on. So that's what is a stateful computation. And these other parts of the computation are actually also stateful. So when reading a text file, we have to keep track of the reading position in the file. That is also a state in that computation. And when writing, we need to also keep track of what we have written so far. And there's some of these other operations. So for example, the map is not a stateful operation, because the map just gets some input and it produces some output, but it does not affect any state that it keeps internally that it has to update. Same goes for the filter. The filter is an easy operation. It just passes some data through or doesn't pass it through. And when we say Flink is a stream processing system, what this means, or it's a way of looking at things. So the way we look at all data is that all data is a stream. It's a stream of input. Same way you would, for example, if you use the Java 8 Streams API, you might have a finite list of strings, but you still convert that to a stream and treat it as a stream of data. And there's different systems that you can use, for example, to store streaming data. So there's, for example, RabbitMQ, or there's Kafka, which are really systems that are meant to store streams of data where data is coming in real time and it's stored for a short period. And then other systems process that data. And then sometimes you some part you drop it. But there's other systems, for example, S3, or in general, these file system like object stores, they store files. Same goes, for example, for the local hard disk also stores files, but you can think of those individual files also representing a stream of data. So in Flink, we model everything as a stream, and Flink is a stream processing system. And the other attributes I put there is that it is stateful and that it is fault tolerant. So there's some parts that I left out in the previous picture. So for these stateful operations, for example, the aggregation or reading the file or writing the file, Flink has to keep track of that state. And there's some other state, for example, the Flink master has to keep track of which operation is processing which data, or which of these worker nodes, these task managers, is connected to which other nodes to send the data there. And the difficult thing in a system such as Flink, which is distributed and which has state, is that you must be able to deal with failures. So there might be failures in the program if there's exceptions thrown, if there's some bad data. But the more likely thing is that these machines will just fail. There might be network disconnects, the machines might break, or the processes might fail because of garbage collection, out of memory issues. And the thing that Flink as a distributed fault tolerant stateful processing system provides is that it is resilient to these failures. So it makes sure that if something fails in the computation, it has some backup of that state, we call it a checkpoint, so that it can restore the computation, for example, on some other machine, and continue processing, and can still generate results that look as if the failure didn't happen. That's typically what we call fault tolerance, or high availability in these systems. Of course, Flink is more than just an SDK or a set of APIs, but that's a big part of it. So it is the SDKs, but then a big part is also the distributed fault-tolerant runtime, which can take these computations expressed using the API, which are converted to these data flow graphs, and which can execute them on multiple machines. And another important part is the connectors to external systems. If you just had a system that sits there and cannot interface with the outside world, that would be pretty useless. So we have to be able to read from files. We have to be able to read from message queues, such as Kafka, RabbitMQ. We have to be able to write to key value stores, such as Elasticsearch or Cassandra, or Hive, which is from the Hadoop world. So that's a third important thing. And this is often ignored in a way in what Flink is, but it is an open source project that is developed in the open. The communication happens via mailing list. There's an open issue tracker. There is a mailing list for developers where they coordinate development. There's a mailing list for users of the system where they also ask questions and where they help each other. And I think this is a very important part of Apache Flink, is actually this community and this open development. And this is the open processes. They are shaped, if you will, by the Apache Foundation. There's multiple projects in this space, such as Apache Spark, and Kafka that I mentioned is also an Apache project. So that's really setting the processes for how this open source development should work. Let's look at some example use cases. So if you, for example, want to process your shopping list, or maybe your list of movies that you have seen, then expressing them as a data parallel program and using Flink might be a bit overkill for it. And in those cases, it would be quicker if you just wrote a quick Java or Rust program to process that data. But Flink really is useful when you have very large amounts of data that come in real time. So let's say millions of data events per second that come in, and that you need to process on, say, hundreds of machines. And for example, Alibaba is building real-time search and recommendation models based on events that they see coming in. Netflix is building session profiles of users so that they can improve the recommendations that they give to users. Banks are using this to do real-time settlements, so where they have the different trade positions in the front of house, back of house, and they need to have a complete view of basically the balance sheet, where they have buy transactions, sell transactions, and so on, and they want to unify that. Advertising companies are using this to do revenue accounting of views on the ads that you see in the browser. And some of the more interesting use cases, I think, are, for example, ING Bank, which train in real-time machine learning models on the data that's coming in real time, and then they do fraud detection on that. So the funny thing here is, what I find funny is the magic carpet fraud, where if you use your card in, say, New York, and then an hour later you use it in Berlin, that's pretty much impossible unless you have a magic carpet to fly there. So that's something that they can detect with this. And there's many companies that use Flink to ingest data, to massage it, to cleanse it, and then put it, for example, to read it from some real-time stream and then put it in a storage system such as HFS or Elasticsearch to make it readable, processable. And just to give you an idea of the scale of what you can do with Flink, these are some numbers from the Singles Day. So this is, it's somewhat similar to Black Friday in the US, where there's this big day in China where there's a lot of discounts and people just go crazy shopping. And here, the throughput of the data that was processed with Flink is 2.5 billion events per second, spread across, of course, multiple different data pipelines, multiple different clusters. But the size of the state that was kept in these Flink operations in total was 100 terabyte. And the number of containers that were used to do this processing was 2 million. So this is just, I mean, I couldn't process this on my on my laptop, but 2 million is just, even I have to, yeah, it's hard to believe for me even this scale, but that's the numbers that we have from the Singles Day. So now you know, hopefully, what Flink is. Now we should try and answer the second question, which is, why are there different APIs? So right now I only showed you the data stream API, and let's see why there's other APIs. One of the reasons why there are different APIs is that a stream is not always a stream. There is, or you can think of them as, let's say there's unbounded streams, which are just, you receive data in real time and there's always more data coming in, but you can also chop that stream up into parts, then they would become bounded. So for example, one single file on a file system is one part out of a bigger stream of data, and that would be a bounded stream, a single file. So that's the main thing. There's unbounded streams and there's bounded streams. And when you do computations on them, there's some optimizations that you can do which lead to different API choices and different system choices. And we will just look at them now. If you know that you have only bounded data, then you can do something that is called batch processing, where you know upfront you have your data, you can process it, you produce some result, and then you're done. That's it. So the data is complete when you launch your program. On the other hand, if you have continuous streams of data that you want to process, say you have banking transactions that just keep coming in, or you have user events that are triggered by people watching stuff on Netflix, then that data is never done. It's an unbounded stream. And in this case, there are some trade-offs that you need to consider. Say, for example, as I showed earlier, you have some aggregation that counts certain events happening within given time windows, say 1 hour. The problem now is, when do I know when I have seen all data for that 1 hour? Because there might be delays in how the data is shipped to your processing system. There might be network outages, or there might be inherent latency in the system, so that just data always arrives 5 minutes late because it has to go through some other processing layers. And there the trade-off becomes, do I produce results early in continuous stream processing, which means I get results quickly that are potentially not correct, or do I wait for quite a bit until I produce results? And there's two ends of this spectrum. So on the one side, you can produce a new result of your computation for every record that comes in. For example, whenever you see some event, you update your internal state and you emit a new result. So say count was 3, new event comes in, update count to 4, emit that result downstream. This means that you have always up-to-date results. However, what it also means is that you produce a lot more results than potentially necessary. What you can do on the other hand of this, on the other side of the spectrum, is that you just collect all your data, let it sit there, and then say after 1 year you process a result from the data. With this, you would be pretty sure that there's no late data that you need to process where you need to update the count because the previous count was wrong. However, you get your results very late. And there's effects that happen. So for example, if you always produce up-to-date data, you produce a lot more noise. You write more data to the output. So you would, for example, write to your key value store, you would write for every update, you would write to it. So if there's 10 updates and you update the count 10 times, you would also write 10 times. But in the case where you just produce your result after 1 year, you would only produce one update to the outside system. And these outside systems or these other systems in your data processing landscape, they must be able to deal with this difference, that you either produce, say, incremental results or results that updates over time until they settle down to some result, or that you produce one result. So that's the difference in semantics, so how you produce results. And there's also a difference in how you can compute these results. So if you do batch processing, where you have, where you know all the data that you have before, and there will not be no new data coming in, you can use different algorithms or different data structures from what you would use for stream processing. So for batch processing, for example, to compute these aggregates for these different, say, 1 hour time windows, what you can do is you just sort your data by the timestamp, say, and then you do one pass over that data, update, keep a counter for a given window. Then when the time has passed that window, you emit a result and you continue sweeping through the data. That can be very efficient. However, on the other hand, if you do continuous stream processing, it might be that you receive, for example, a record that should go into one time window, then you receive a record that goes into another time window, then you want to emit results for that time window, but still keep them for later in case some more updates come in for that window and you want to emit more results for that window. So what you need to do is you basically need to keep a point lookup data structure, something like a hash map, where you update the results for a given region, say, or for a given window, and you keep that data there until you decide that you want to drop it. And here the tricky part is, how long do you keep that data? How long do you wait for late data that might update your results? When do you emit the final result? When do you drop it from the data structure? Is the data structure well suited for this kind of access pattern? So there's these different considerations that go into batch processing versus stream processing on the other hand. And that's, in a nutshell, or if you look at it simply, that's the reason why there are different APIs in Flink for stream processing and for batch processing. So what I showed you before is, on the left is this data stream program, and the dataset API, which is the API in Flink for these batch use cases where you have bounded data. So the API looks pretty similar. The difference is you have a data set on the one side, data stream on the other side. But the crucial difference is that the data stream API provides tuning knobs or little points where you can control this trade-off between latency and completeness, and where you can control, for example, I want to have time windows for my aggregation of 1 hour. And the way you do this in the data stream API is there is this thing called triggers, which specify when we want to produce output. So in this example, we have, say, a speculative trigger which says, even when I'm not sure that I have seen all the data from my window, emit some preliminary results beforehand, but maybe not for every record, but let's say every 5 records, because we don't want to hammer the downstream system that much. And the trigger also says for how long to keep the data after we emitted a first final result, and then how or when we want to delete that data finally from this point lookup data structure. It's basically garbage collection, but on a different level, if you will. There's some other differences, or let's say the difference are in the semantics, is that the dataset API produces a result once for an aggregation, and as I said, in the stream API you have triggers to control when results are produced. And there's some operations that are more easy to do on bounded data, such as iterative programs where you basically have a loop in the graph. This is, for example, useful for computing machine learning models or page rank, for example, where you have to repeatedly work on some data. This is hard to express in the data stream API, where data is just coming in real time all the time and flying all over the place. So that's basically the reason why there's different APIs, in a nutshell. It's also interesting, I think, to look at how these different APIs evolved and how they came to be. So arguably what started this big data processing, distributed processing space was the MapReduce paper from Google in 2004, which is a batch processing system, though there's no stream processing. You have all your data beforehand, you can compute the result, and that's it. There's no continuous processing. There's an open source implementation of this called Apache Hadoop, it's the ideas from the paper taken and developed in Apache as an open source system. Then an interesting system is Apache Storm, which is a stream processing system. So this only does continuous processing, so only has an API for continuous processing, no batch processing. Then there's Apache Kafka, which is a log system. So that's a system that can store data for processing by a downstream system. So you would have your events come in from different sources, you put them in the message log in Kafka, in a message queue, and then a system such as Flink can read from that queue in real time and process data. And the queue is basically a buffer between outside producers of data and between a system that processes this queue. And it allows, for example, to have multiple consumers for the data stored in that queue. Then, by the way, these dates I'm giving are when there was the first usable release of these systems. So for Flink, a first release that only had a batch processing API was in 2011. And for Apache Spark, which is another system in that batch and stream processing, distributed processing space, there was the first usable release in 2012. Then there's quite a gap between, for example, for Flink, there's a gap between 2011 and 2014 when we introduced an API for stream processing. And for Spark, there was a paper about discretized streams and these streams, which came out in 2013, which is their work for distributed stream processing. And some of the most recent thing in that space is the Kafka Streams API, which is also an API or a system for doing stream processing when reading from Kafka message logs. This is purely a stream processing system. So you can look at this and then you see that part of why there are different APIs is just that people had different ideas or different use cases and different needs. And initially people only did batch processing. No one thought really about stream processing except in research papers and such. So that's why you have these different APIs, basically. And and in a way, with the power of hindsight, if you could go back in time now to those places, you would maybe design an API or have an API that wouldn't need a differentiation between batch processing and stream processing. You would have a unified API that just allows you to do both. And this is what we are trying to do now, basically, with the efforts to unify the APIs for Apache Flink. The problem with having two APIs is that basically there is two of everything. So if users want to use Apache Flink, they have to see, do I want to do batch processing? Do I want to do stream processing? Maybe do I want to do both? Then you have to learn these two different APIs. So you saw them, they look quite similar, but there's subtle differences in the operations that they support and in the semantics that they support. And it's not easily possible to mix batch and stream processing. So you can't have, for example, one part of your computation be a batch processing thing that produces or processes some data that is just sitting there, and then have another part of the data flow graph, if you will, that does real-time stream processing. Another thing, I mentioned there's these connectors for connecting to outside systems, and the APIs for these connectors and the supported connectors between these systems are different for the two APIs. So there's batch connectors, which can reach from more batchy systems, and there's stream connectors, for example, for Kafka or for PubSub, which connect to more streamy systems. And so if you choose one API, it might mean that you can't use connectors written for the other API and vice versa. And of course, this is more a problem for me as a developer of Flink, but if there is two APIs, it means also that there's code duplication, and we maintain two of everything. Again, there's two APIs, there's two connector APIs, there's two sets of connectors, some of them overlapping. So there's a connector for reading files for the stream API and a connector for reading files from the batch API. So that's quite some overhead for us. And basically, now that you have all this information, now that you know what Apache Flink is, you roughly know what the difference between those APIs is. You really think in hindsight, we don't actually need two different APIs. And that's why our goal is that we want to have one API that can do batch processing and stream processing. And this is not easy. There's some subtle details that you need to figure out, but that is simply said, that's the overarching goal that we want to do. Only one API for both. And if we had this, you would be able to just write your program using this unified API. You don't have to worry about, do I want to do batch processing? Do I want to do stream processing? What if I change my mind later on? And simply put, the idea is that if you write your program using the unified API, and if you have unbounded input, the system recognizes this and does more streamy execution with the trade-off between latency and completeness and so on. If you only have bounded streams as input, so you can do these batch optimizations where you, for example, sort the data, then compute the result in one pass, then you get this batchy execution. And this is useful, for example, when you say you have some pipeline where you're ingesting data in real time, and this is working nicely, and you wrote it using the data stream API, but now you realize you have some older data sitting in files in a distributed file system, and you also want to compute some results from those. If the API is unified, you can just take your program, switch out the sources, and then let it run on that old data. And another important use case that actually quite some people in the Flink community would find quite helpful, and which they talked about at conferences, for example, is that they want to do bootstrapping of a streaming pipeline. So you have some historical data, for example, user interactions sitting in files, and you want to read that in your computation. And then once you have read all that, which fills up some state in your computation, for example, these counters on the windows, then you want to switch over to the real-time source, which is the streaming part of the program. And the system should just deal with this and do the clever thing for batch execution, and then do the clever thing for stream execution. So now we get to the last part. How will we actually get there? And this is, again, often overlooked in developing these systems, but there is actually a process for how such things happen in the community. So what we need to do first is we need to write and publish a flip. This is a Flink improvement proposal. This is a design document that people can propose to the community of developers of the Flink project, which will then be discussed by the developers of the Flink project and the community, the users. There's time for everyone to look at it and see how it will impact the use cases, or if they like it, if they don't like it, if they have other suggestions. Then there will be a vote on the flip, which decides if we accept it or not. And then once that is done, we can start implementing the design and then changing the code in Apache Flink. And I think this is quite an interesting process, and it also forces us, even though we are the original creators of Apache Flink at Verica, we still follow this process and work with the community and are open about what we are trying to do. A quick outline of what we're trying to do is, in my head, it's split into two phases. So what we want to do first is that we want to change, or the rough plan is that the data stream API becomes the unified API and the dataset API will be deprecated. And then for this to happen, we need to change the execution semantics of the data stream API to be useful for batch processing. So if you have a batch processing use case or batch source, a bounded source, then these latency and completeness tuning knobs that you saw in the API, they can just be ignored because they are only there for controlling if you want to emit preliminary results or late results. And if you use the data stream API and have a bounded source, then Flink should use those efficient data structures and algorithms that it currently uses for the dataset API to get this more efficient computation. And once we have that, phase 2 would be that we allow mixing bounded and unbounded parts, and they play nicely together so that you can use the efficient data structures and execution style for bounded part, and then for the streaming part, you use the data structures that are useful for a streaming part. And there's not many more technical details that I can talk about now, but as I said earlier, the important part is understanding what is Apache Flink, understanding the history and the differences, and then it seems very simple and easy, and in hindsight, obvious that this is something that you should do in your APIs. And that's what we're trying to fix now. Again, the devil is in the details, so it's easy to say data stream API supersedes dataset, done. But the tricky parts are, what are the semantics of these operations? And here, some operations are easy. So there's map, filter, flat map, which are these element at the time operations. We just get some input, produce some output. They have no state. They don't need to keep track of anything. These are very easy to support. I mean, they're basically the same between bounded processing and unbounded processing. What is complicated are the sources and the things, where we need to see if we emit differential updates to an outside system, or if we always emit a new result, for example, which plays together with the semantics of the aggregation operations, the windows, and for example, joins, like SQL joins. Here we need to carefully look at the semantics, for stream processing and also for bounded processing, and which makes sense for each of them. So for these aggregations, we need to see, do we only emit a final result after we've seen all the data for batch processing? How do we control it for stream processing using these triggers, and how does it play nicely together? So that's what we need to do. We need to carefully look at the existing operations, the semantics, and find something that makes sense both for bounded processing and unbounded processing. That's basically it for the main part. Now, there's some related bits and pieces that I want to quickly mention, and then we're done. There's one thing that I didn't mention is that Flink already has a unified API. So there's not just 2 APIs currently, there's 3 APIs and some other APIs, but there is a unified relational API. We call it the table API, which allows you to write relational programs. And actually, you can also use SQL in there. So you can use SQL, or you define your sources and your sinks, and then you can write a SQL program that uses a source like a table, and it writes, for example, an insert into to a table. And this SQL is the same for bounded processing and unbounded processing. And Flink under the hood already does the clever thing of seeing, all the data is bounded. I can do this efficient batch style bounded execution and emit a result only once. Or if the input table is an unbounded table, so you have a stream of data coming in real time, Flink will still take the same SQL program, but execute it differently to have these streaming semantics. So that's something we already have, but this is more for relational analytic use cases and not for general data parallel processing pipelines like the data stream API or the data set API would be able to provide. And the last thing I want to mention is that there's this project called Apache Beam, which is a project originally from Google, which also aims to provide a unified API, both across bounded and unbounded processing. So they also have these tuning knobs for controlling latency and completeness trade-off, but also across different systems. So this is an API that you can use to write a program and then execute it on Google Dataflow, which is provided by Google, or you can execute it using Spark underneath, or Hadoop underneath, or Flink underneath. And some of the thinking about the semantics of batch and stream processing and windowing and triggers for controlling latency and completeness comes from the Apache Beam project, comes from papers written by people associated with the project, or by articles written by people associated with that project. That's why I wanted to mention it here, because it informed some of my understanding of bounded and unbounded processing and these trade-offs. So it's an important project in that space, I think. So I hope you learned something about these 4 things that I wanted to talk about. What is Apache Flink? It's a distributed, fault-tolerant stream processing system. And an important part of it is that it has an active community of users and of developers which develop this in the open source. Why are there different APIs? I think it's mostly for historic reasons, because people didn't think far enough and there were different use cases. Back then, when these APIs were first developed, people didn't think about stream processing using these APIs, and that influenced how these APIs were developed and what they support. There were different execution semantics. This one is, in my mind, quite easy. If you have one less API, that's one less thing to worry about. It's less, users need to learn less. If they want to do batch and stream processing, they only need to learn one API. And for Flink developers, such as me, it's easier to develop if you only have one API to maintain. And the last bit, how will we get there? By carefully looking at the existing APIs, what are the semantics, what works and what doesn't, and then working with the community of users and developers to come up with a plan to unify these API semantics under the data stream API and eventually get rid of the dataset API. So thank you, first of all, for listening to this. If you are interested and want to try out Flink or help with it, you can go to the website. You can join the mailing list and discuss. You can join a meetup, for example. This is my Apache email. So this is me with my Apache hat on. And if you're interested in the company, that's my company email, my Twitter handle. And we are also hiring, although it is a bit complicated at this point, I mean, because of the coronavirus situation. But in general, we are hiring if there's interesting people. So if you find any of this stuff I talked about, like thinking about the semantics and the APIs and the SDKs interesting, you can check out our careers page. And there's a there's a position especially for the Apache Flink SDK team, which is my team, where we work on these API SDK related problems in the open source. Thank you. Again, that's it.
Thank you very much, Ayosha, for the great talk. We are a bit over time, but I'll try to relay the questions that we have here from the guys. So we have a couple of questions from Francisco Sejudo, and he's asking, can you tell a little bit on how to manage the save points and checkpoints to recover from an issue? And if it's possible to have a block pre-assure somehow not to try to swallow all in once at the beginning, if that's strategy is selected, for example, from a Kafka stream topic. And also, is there any mechanism on any way to assert that a task manager gets a job manager if this is down and another job manager pops up?
Ooh, that is a long question. I don't.
Okay, so the first part, can you tell me a bit on how to manage the save points and checkpoints to recover from an issue? And if it's possible for a block to pre-assure somehow not to try to swallow all in once from the beginning.
What is that? A block or what? Sorry, I didn't hear that well.
This came after the distributed stateful stream processing slides.
So yeah, I mean, I cannot answer some parts of the question, but I think for more in-depth, maybe shoot me an email and then we can try and figure it out. But what he is referring to is that Flink has this feature called save points, which you can use to periodically snapshot the whole state of a computation to some file system. And then you can recover from that snapshot or from that save point in case of a failure. Also, if you, for example, want to update Flink, or if you want to update your processing pipeline, you could take a save point, shut down the whole cluster, then change the program, and then restart it from that save point. Okay. So that's in general what that feature is. But to figure out the specifics of the question, I think it would be better if they sent me an email and we talk about it.
That's perfect. Ayosha, thank you for being available for that. And one very last question from Vinod. Does Flink store some processed state into persistent state for continuing you later, or is everything on RAM and synchronous?
That's a very good question, which connects to that earlier thing I mentioned about checkpoints. So Flink, it's a mixture. Flink has this concept of state backends, which are it's a data structure that is used for storing the real data on which we are computing. And there's a state backend, for example, that stores data in Java hash maps, but there's also a state backend that stores it in RocksDB, meaning it can go to disk on that computation node. But this is just the live state that we're keeping. And what Flink periodically does is it checkpoints the whole state of the computation to a distributed file system, such as Google Cloud Storage or S3 or HDFS, in case there's a failure. So if one of the task managers goes down, Flink will detect that, and then it can restart the whole computation from this data it wrote to the checkpoints earlier. And an important thing is you want to be clever about writing those checkpoints. So you don't want to write the whole state every time you do checkpoints. So if you do checkpoints every 5 minutes because you don't want to lose too much data, what Flink can do is write only incremental snapshots. So it would only write the new data and not write all the data every time we have to do a checkpoint. So that's basically, it's a mix. Flink keeps it potentially in memory, but it snapshots it to some distributed file system for fault tolerance.
Okay. I hope you guys got the answers to your questions. We are a bit over time. Thank you so much, Ayosha, for the great talk. Hope to see you back again in 2021. Hopefully back to Coimbra.
I would like to see that. Yes, the city.
That's fine. We hope we can see it. You can see it on 2021. So thanks all. Enjoy the quick break. We'll be back in 5 to 10 minutes with Devlin from Microsoft, and we'll see each other soon. Bye.
Have a good day.
Let's start the interview. Use the flute and play a song. Why should we hire you?
You have no idea I want to work this much!
Welcome back, everyone. I hope you enjoyed the previous sessions and you had short relaxation time during our break. For everyone that was not able to see the intro from the previous sessions, my name is Daniel Pando, and I'll be hosting the first few sessions of Almedina Room. I'd like to start by thanking everyone attending, thanking our speakers, and obviously our sponsors for making Jnation possible. And I'd like to leave out a special thanks to Devlin Duldulau from Microsoft. Is a Microsoft MVP and is going to present us a session on automating your infrastructure deployments into Google Cloud, Azure, AWS, with Terraform. So if you have any questions you would like to drop to Devlin during the session, just leave them on Jnation Slack on Almedina channel or YouTube chat, whatever you prefer. And I'll try to relay them to Devlin at Q&A. So Devlin's presentation will be pre-recorded video, but it will be here for the Q&A. So you will be able to answer your questions. So without further ado, let's move to Devlin's session and we'll check back on Q&A.
Hello everyone, I'm Devlin Duldulau. I'm a software developer in Meta, and I'm here to talk about automating your infrastructure deployments in the Google Cloud, Azure, and AWS with Terraform. But first of all, I'd like to thank Jnation for giving me this opportunity here to speak at this conference. Yes, so let's start. So, infrastructure as code, which is sometimes called IAC, uses automation to manage infrastructure. For example, instead of configuring your servers one at a time, you use a tool to configure all of them at once. You express the infrastructure you need for your application as code, such as a configuration file or a script. What infrastructure as code can do? Can eliminate manual error-prone provisioning and changes, bring software best practices to infrastructure management, gain visibility of changes through code reviews and previews. And now, why infrastructure as code? We have this automated and repeatable, decrease time to market for new applications and ongoing maintenance, safe, predictable changes. In short, you have increased speed, reduce risk, reduce cost, and leverage developer best practices. And we have Terraform by HashiCorp here. So Terraform uses infrastructure as code to provision and manage any cloud infrastructure service. You can write declarative configuration files. Define infrastructure as code to manage the full life cycle, create new resources, manage existing ones, and destroy those no longer needed, plan and predict changes. Now, Terraform provides an elegant user experience for operators to safely and predictably make changes to infrastructure. Then create reproducible infrastructure. Terraform makes it easy to reuse configurations for similar infrastructure, helping you avoid mistakes and save time. Terraform in itself is an open source tool by HashiCorp written in the Go language. The Go code is compiled into a single binary. This binary is used to deploy infrastructures or build a server using just a shell. The Terraform binary makes API calls to Google Cloud, AWS, Azure, OpenStack, etc., thanks to the Terraform providers maintained by the community. And yeah, Terraform Cloud, we have their own software automation, and you can get it from Terraform Cloud. This automation and collaboration features to empower individuals and small teams, including VCS integration, remote operations, and state management. You can also create multiple teams and ensure that team members have the right level of access to the appropriate configurations, and leverage the Sentinel policy as code framework for enforcing fine-grained policy against everything that Terraform Cloud provisions. You can also view cost estimation, so you can preview how much configurations will cost before they are deployed. Here's a sample file of Terraform. I name it foo.tf. It's like say YAML, but different. Braces are only written once per block, and then this is variables like a parameter value you can pass. And then resource, for example, this one, Google Compute Network, and you have fields here, boolean, string, or integer. And after defining this, actually you can also write conditional expressions here. For example, if var a is an empty string, then the result is default a, but otherwise it is the actual value of var a. Another one in here, function calls. For example, the min function takes any amount of number arguments and returns the one that is numerically smallest. And another example here, for expressions. If var list is a list of objects that all have an attribute ID, then a list of the IDs could be produced with this expression. And here are the common commands, Terraform commands. You have Terraform init that will download the plugins that you need for provider. And then Terraform validate, it's grayed out because you can run it or not. We'll just validate your code inside the file. This Terraform plan is more important here. Well, it's like a dry run. It shows you what's gonna happen in your own cloud service account, like will it create new resources or update it or delete them, or delete some. And we have here also, by the way, that's a best practice, always run Terraform plan for applying, and then Terraform apply. There's also a Terraform apply flag that you can use, auto approve, because if you don't put auto approve, it will ask you or prompt you if you're sure of this changes, like that. And there's also a Terraform destroy, which destroys all the resources you created. And yeah, by the way, it can also delete resources through just by deleting the code of a resource in your file, and then Terraform plan again, and then it will tell you if these resources will be deleted from, say, an existing resources. Okay. Demo time. Let's show some demo here. So okay, let's try this local or Azure. So here's a sample of Azure code. We have service plan here, resource. No, I think this is there's a better way to show you. This is just a basic one, and I'll just delete this. This is from a previous testing that I did here. Normally it's just like that. It's the original status of that, and then let's run this Terraform init. No, let's go to that directory first. Local, then Terraform init. Checking for available provider plugins. That's fast. Here's the binary. Then Terraform plan. Let's see. Let's move this here. So see. Okay, while waiting for that. Oh yeah, here we are. So as you can see here, there are green cross here icons, meaning they'll be added, and the plan is 5 resources will be added. There'll be no changes, and there'll be nothing to destroy here. Nothing gets destroyed, and yeah, after this you can now run Terraform apply. Then of course gonna ask me yes, Terraform will perform the actions described above. Only yes will be accepted to approve. Yes. Now while waiting for that, let's check this out first. What's inside of this main.tf Terraform file? So we have the required version here, Terraform. This 0.12 version or above, and the provider, which provider? Here is Azure, and these are required here, by the way. Features, resource group. So this is what we're building here, and there's an alias dev. You can write anything you want here, and it requires name field, location. Here's service plan, and there's another dev alias, and the service plan needs name, location, resource group name. So this is how you'd write it, just to get the value of this. So resource, you can see resource group. This is dot dev, and then dot name. Basically, you're also reading this here. Then SQ, standard, S1. What about the app service? Dev. We have name here, location, resource group name. app service plan ID, site config, .NET Framework version, app settings, some secret, connection string, for SQL Server, these are the fields. So this is not advisable. You should put this in environment variable. There are 3 ways to do that. You'll find out later. So SQL database here with some fields and tags, environment production, right? And then the Terraform state file. It's here. It's being used by Terraform apply that we just run. Just leave it there for now. So yeah, it's not that hard. So let's go to another example here. Well, there are outputs here. You can see outputs file. It actually just helps you see, for example, you want to get a value for the name, say the main name, what's the URL. So just a helper in your command line. Example here, if you want to know the SQL server name, it will be shown here, and then the value of it. So that's what outputs are for. Providers here, subscription, client ID, client secret, the variables. Well, actually you can write your variables here in outputs, and you can also put it in a separate files like so. And then you also have versions here. You can separate it. You can see here we didn't do that. So this is just one single file with all the things that you can do. Whereas this one is we separate the outputs, variables, providers, and version. Put in their own file. Okay, I think we're done here. Apply complete, resources 5 added, 0 changed, 0 destroyed, and we can take a look in the Terraform TF state file. Here it is. So you have to keep it this one and put it in a safe place. So this is the history of your resources. You don't want to edit that. Just don't touch it. Now let's go to my Azure account and see if the resources do exist there. Let's refresh. There you go. Local Terraform demo RG. I think I can move this up here. And here's the app service plan, the app service, SQL Server, and the SQL database. So it's very simple. Now next is, let's try Google Cloud. See the Google Cloud, GCP. Also, okay. I'll try to delete this also. So Terraform init. Let's clear this up first. Terraform init. See, no Terraform here. Downloading plugin again for provider Google. Now here it is, binary. Then next is for validate. Let's see, the code is configuration is valid. How does it look like? So here it is. So we're stated provider is Google, and for the credential it's saved in this file, service account.json, where that's being referred here. Then needs a project field, region, zone, using variable here. Let me show it to you, variables. So these are the values, this default, and you have this optional description. So this is just compute instance and firewall, instance group, health checks here, compute backend service, security policy, urban forwarding rule, target HTTP proxy, URL map. Yeah, and here's an output. You don't, no need for putting a separate file. It's just one line here. So yeah, there's an IP. You can see that later. Let's try to run that Terraform. Did I? Terraform, not yet. Plan. Go. So here it is, and it says "11 to add, 0 to change, 0 to destroy." Okay, so before we add this, let's delete the other one first. The Azure resources is created. CD local, and then Terraform. Destroy. Terraform. 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 Yeah. Destroy. Auto proof. Yeah. That's it. And the other one, just Terraform. Apply. Then auto approve. It's just, yeah, I know what I'm doing. Auto approve. Okay, this will take probably 5 minutes, so we have to move to our next slide, I guess, or maybe we can check out this one for the AWS. Yeah, so for the AWS, here it is. We have provider here. Again, we're stating AWS with the provider, and region US is to. Now this is sample of commenting here. I have to use this pound sign or sharp sign, and here we're going to create configuration, launch configuration. This is just T3 micro AMI image, this unique serial number, and then with the security group. There we go. I think we're done here. Let's check this out. So yeah, this is the, remember the output that I told you what it does. It shows you something here. For example, this one. This is GCP. So you want to know the IP, the Google Compute Global Forwarding Rule, default IP address. So here it is. It's just for the developers. Okay, we're able also to delete the resource as a resource. Let's check that out. Okay, you refresh this, it's begun, right? And what about the Google Cloud? Okay, refresh and refresh this first. Just refresh. Here it is, and yep, this is the resource we created from GCE. That's right. Yep. You can delete it here. You can also delete it through Terraform. Okay. So next would be AWS. Here. Let's try that. I think that with here. Then CD AWS Terraform init, then Terraform plan, I don't think we still have enough time for this. AWS, as you can see, here it is, plan, 5 to add, 0 to change, 0 to destroy. And I can move to next slide. So basically that's it. Now you can deploy to Azure. You can create resources. You can also create resources in Google Cloud and AWS. So Terraform state, again, it's JSON format. Do not touch it. Do not try to edit it. So resources, mappings, and metadata, and you can save it locally on your machine, or save it remotely in AWS Azure and or Terraform Cloud, and also in Terraform workspaces. So this is Terraform included in a CI/CD pipeline, and here's a build process. After checking out your code, pushing your code, creates an ASP package here, zip, and the release definition, creates a storage account in AWS, a separate resource group. Save the key, and then it's provision the for example here app service, and then storing the Terraform state here. Eventually here comes the ASP.NET package zip deployment, and now you have this application. So you can include, again, you can include the Terraform file in a monorepo, or you can put it in a separate Git repository. Depends. It's just self-preference. Well, maybe if the project is just a small project, you can put it in a same repository. But if it's a large project, I think it's better to put the Terraform file in a separate repository. So you can save it in a storage account inside a container. So this is actually in Azure, and for AWS, S3 bucket, and for the Google Cloud, it would be Google Storage or the GCS. And demo time. I think I have to show you that CI/CD pipeline and the release pipeline in Azure. So here it is. So let me step back here. I forgot to ask you, why do you have to put it in a separate resource group, the storage, so not be able to accidentally delete the Terraform state. For example, if you run Terraform destroy accidentally, of course you will not be able to recover it. It's lost. So it's a good practice to put in a separate entity. And here's the release pipeline. First task, to use this Azure CLI to deploy required Azure resources, and that would be the for the storage. As you can see here, it's a resource group, a location, and then with the container account name here. Then after that, running a PowerShell script here. So basically this thing here gets the Azure storage account key, so that you can save the Terraform state file in this Azure storage here. And here's the Terraform here, installation, then running the Terraform init, Terraform plan, then Terraform approve, and as you can see here this is auto set to auto approve. Here's a flag here we're using, so to not interrupt the process here. Then finally the service deploy. So let's differentiate Terraform from the other tools out there, like other provisionary tool or configuration management. So anyway, here's Chef. First of all, Chef is a configuration management tool versus the provisioning tool that Terraform is. Chef is concerned with the installation and management of software on existing servers, while Terraform provisions the servers themselves. In this case, when using Docker or Packer, Terraform is a better choice than a configuration management tool. But it's more, Chef defaults to mutable infrastructure paradigm, leading to hard to diagnose configuration bugs, but Terraform treats every change as a deployment of a new service configuration. Chef also represents a procedural style to code everything and requires running a master server for state storing, as well as agent software on each configured server. So what about Puppet? Similarly to Chef, Puppet is also a configuration management tool used to install and manage software on already existing servers. It also requires a master server for storing the infrastructure state, as well as the installation of an agent software for installing the latest configuration management updates. Puppet is also 4 years old than Chef. It was released in 2005. However, Puppet has a more declarative style, just like Terraform. And here's a SaltStack. Although SaltStack is again a configuration management tool, it has a more declarative style like Terraform. And then, like Ansible, Chef, and Puppet, it is mutable infrastructure paradigm. It requires the installation of agent software and to run as a master server. Lately, SaltStack has been gaining an increase in developers' interest. There's even an annual SaltStack user conference. So here's Ansible. Like Chef, represents a procedural style of coding. So it is a configuration management tool and follows a mutable infrastructure paradigm. Here's Ansible here. You can see, and this is how would you use it along with Terraform. So you use Terraform to deploy all the underlying infrastructure, including the network topology. That would mean VPCs, subnets, route tables, then data stores like MySQL, Redis, and you have load balancers and servers. You then use Ansible to deploy your apps on top of those servers. Here's a quick diagram of that. We have Terraform here, then Ansible. So let's go to Packer. Packer automates the creation of any type of machine image. It embraces modern configuration management by encouraging you to use automated scripts to install and configure the software within your Packer-made images. Packer is an automated build system to manage the creation of images for containers and virtual machines. Packer, on the other hand, is a system for building, distributing, and running Docker containers. Containers can be run on Linux and Windows. So basically, that's to differentiate Packer from Docker. So here's Terraform and Packer. You use Packer to package your apps as virtual machine images. You then use Terraform to deploy servers with these virtual machine images. And then the rest of your infrastructure, including the network topology, then data stores, and then load balancers. Give you an example of that. Here's a Packer, Ansible, and then Terraform. Packer sends this Packer image built to create a VM. And then the Ansible install middleware and application. And then the Terraform provision load balancer, VM scale sets using management this image. That's an example of that. So here, both Kubernetes and Terraform can help you with orchestration and scalability. Kubernetes deals with Docker containers. So if your application isn't yet containerized, it will require some preliminary work. Terraform operates on what can be seen as hardware. So it's suited for any kind of workload. So here's a table of Kubernetes and HashiCorp stack. Here's Kubernetes and packaging. This is Docker. deployment and provisioning. It's Helm here. Here's Terraform, and then Packer. Then here's Terraform, Packer, and Docker. Terraform, Packer, Docker, and Kubernetes. You use Packer to create a virtual machine image that has Docker and Kubernetes installed. You then use Terraform to deploy a cluster of servers, each of which runs this virtual machine image and the rest of your infrastructure, including the network topology, data stores, and load balancers. Finally, when the cluster of servers boots up, it forms a Kubernetes cluster that you use to run and manage your Dockerized applications. And here's Pulumi. Pretty much the same as Terraform. The only difference is that Pulumi uses JavaScript, TypeScript, Go, Python, and C#. They both do the same thing. Okay, so yeah, this is just a sample of package managers: JavaScript, TypeScript, Pulumi, and Azure. This is a provider of links. Yeah. So let's move to CloudFormation. So it is also a provisioning tool. However, CloudFormation is non-open source. It's like Terraform. Terraform is open source. This is non-open source. The tool belongs to AWS services, which means it can only be used within AWS scope. And we have here Azure Resource Manager of Azure, same as Terraform, but can only be used in Azure resources. Yeah. And then Cloud Deployment Manager, Google Cloud. Non-open source as well. It uses Jinja of Python. Jinja is a modern and designer-friendly templating language for Python, modeled after Django's templates. So we're almost done here. Summary: IAC, consistent, gives you these things here: consistent configurations, improved scalability, faster deployments, less documentation because the scripts replace it already, right? That is so good. Better traceability. And the Terraform here, you have one tool and one language for describing infrastructure for Google Cloud, AWS, OpenStack, and any other cloud. Switching a provider is not a headache anymore. You can have Amazon instances running Kubernetes containers with your workloads and manage the whole system from one tool. You can go here to learn more about Terraform, terraform.io. And here's a link to Terraform Associate Certification. If you want to add formal industry accepted credentials, digital badge upon passing a certification exam. And yeah, here's a Terraform book. You learn here a lot of stuff, like how to create reusable infrastructure with Terraform modules, some Terraform tips and tricks, like in let's say loops, if statements, and pitfalls in Terraform, and how to use Terraform as a team, which is really important also. So yeah, thank you for listening. Please follow me here, my Twitter. Yeah, that's all. And I'm out.
So thanks a lot, Devin, for the great talk. We do not have many questions, although some of the guys are asking if you can share your GitHub link on the channel and your slides. Although
Yep.
Although, just to let everyone know that these sessions will be available to be viewed after the conference. So if you are interested in the whole session and not just the slides, which I think will be better because you actually have the code, the live coding and the live demo, they will be available after the conference. So I don't know if you want to add anything else, Devlin.
Yeah, just if you have questions, just post it here on this YouTube chat or on Slack, and I'll be happy to answer all of them. And of course,
Yeah.
the link to the slides and the repo.
Yeah, Devlin is also on our Slack channel. So if you want to reach him with any questions, just let him know. I think he will probably be able to answer your questions throughout the day.
Yeah, of course.
So once again, thanks a lot, Devlin. Hope to see you back in a future year to Jnation. And thank you for the great talk.
Oh, thank you. Thank you also. Yep. Thank you, everyone, for listening, for watching. Thank you for Jnation for this successful event again. So yeah.
So we'll have a quick break now, and we'll be back in 13 minutes to a session on how to build an app for the Google Assistant. Tune in after for that. See you in a while.
Stay safe, everyone.
Thanks, Devlin. Welcome back, everyone. Hope you enjoyed the quick break. My name is Daniel Pando, and I'll be hosting the next session here at the Almedina room. I'd like to start by thanking everyone that is following Jnation today, either on YouTube or on Slack. Our speakers, and obviously our sponsors for making Jnation possible. I'd like to leave out a special thanks to our next speaker, Bok Nihao from Sync ICT. He's going to present us a session on how to build an app for the Google Assistant. Sorry if I mispronounced your name, Bok.
Totally fine.
If you have any questions for him during the session, drop them on the Jnation Slack on the Almedina channel or on the YouTube chat, and I'll try to relay them to Bok. So without further ado, and when you're ready, Bok, the stage is yours.
Thank you, Daniel. Welcome, everybody. Today, we're going to talk about how to build apps for the Google Assistant. So I would like to start with a little introduction, why I'm here telling you about creating apps for the Google Assistant. So my first contact with the Google Assistant was about 4 years ago, and I was pretty impressed. Actually, I'm still impressed. I think it's a great technology. And I wanted to know more about it. How does it work? And whenever I really want to know how stuff works, I have to play with it or I have to build something for it. So I decided to create my own app for the Google Assistant. And this became a little game called the Voice Adventure. And a voice adventure is like a text adventure, but instead of text, you use your voice. For people that do not know what a text adventure is, it's a game in which you interact with your environment by using text commands. Also, the game will respond with text. And it looks like this. This is a screenshot of Zork. This was a really popular game in the 80s. And like you can see, it's text all the way. Everything is presented with text. So I created something similar, but instead of text, you use your voice. So the goal for today is pretty simple. I want to show you how easy it is to get started building your own apps for the Google Assistant. At the end of this presentation, everybody should be able to build his own app. And I also hope that everybody is eager to build his or her own app. So hello again. My name is Bouke Nijhuis. I work for a company called Sync ICT. And at this point, I normally tell people, whenever you have a question during the presentation, please raise your hand. That's not going to work with an online conference. So please ask your questions in the chat, the YouTube chat or the Slack channel. And then Daniel will transfer the questions to me. If you're not live, but looking at this later from YouTube, you can ask me questions at Twitter. My Twitter handle is in every slide in the bottom right corner. So the format for today is pretty simple. We're going to start with a demo in a minute. I will show you the game. Then I'm going to explain you how the game works. What are its most important components? How do they interact? What are their responsibilities? And then there will be a live coding part in which you're going to add a feature to the game. Finally, I'm going to wrap up the session. So I'm going to give you a demo of the game. I think that's important because it will give you a better understanding of the capabilities of the game, but also the capabilities of an app for the Google Assistant in general. Also, whenever I need an example, I want to show you something, I will take something from the game. So it's important that you understand the game properly. The demo will take about 2.5 minutes. I created a little movie up front. What you're currently seeing on the screen is the simulation environment. Whenever you create an app, you can test it here. There will be text involved, but that's because it's a simulation environment. You can play the game voice only. The text in here is helpful because then you can also read along. So here we go. Enjoy.
Here's the test version of Voice Adventure. Hi, welcome to Voice Adventure. You play this game like a text adventure, but instead of text, you use your voice. You can directly start with issuing commands or ask for more help.
Help me, please.
You can use verbs to interact with your environment. Use look to get a description of your environment. Use the verb go and a wind direction like north or east to navigate.
I see. Go east.
You are standing in a clearing in the woods. There is a bush on your right-hand side.
Okay. Look at the bush.
Under the bush lies an old iron handle.
Cool. Pick up the handle.
Added the handle to the inventory.
Nice. Go west.
You are at a crossing. In the north you see a castle. In the east is a clearing in the woods. In the south is a cave. In the west is a well.
Let's try the cave. Go south.
You entered the cave and there is a big troll coming your way.
Uh-oh. Go north.
You are at a crossing. In the north you see a castle. In the east is a clearing in the woods. In the south is a cave. In the west is a well.
Let's try west. Go west.
You are standing next to a dry well. The handle of the well is missing.
Handle, handle. What's in my inventory?
You carry a handle.
Aha. Please use the handle on the well.
The handle seems to be part of the well. You use the handle to lift the bucket and you pick up the sword.
So that's the demo. I hope you have a better understanding of the game now and also of the capabilities of apps for the Google Assistant in general. Let's go back to the presentation. So the main components of this game are pretty simple. Actually, it's just a front end and a back end. So it's just like a business application. You have your front end, you have your back end. In this case, the front end is responsible for all the speech stuff. So it has to do speech to text, it has to do text to speech. And the back end is mainly responsible for coming up with a proper answer to your request. So if we put all this in a schema, it looks like this. First, there's me playing the game. I'll speak to the game. So the first arrow is voice. And then there's the front end. And then the front end will translate my voice into text. And then this text goes to the back end. And then the back end will apply some game logic and come up with a proper response. So again, text is going to the front end. Then the front end will translate this into speech. And I have a voice adventure. So this is how it works. Pretty simple in a nutshell. So now I'm going to talk a few minutes about the front end. And then I'm going to talk a few minutes about the back end. So the front end of the game is written in Dialogflow. Dialogflow is the most widely used tool for building apps for the Google Assistant. About 95% of all the apps for Google Assistant are written in Dialogflow. So whenever you want to write an app for Google Assistant, just use Dialogflow. Dialogflow is responsible for the speech recognition and the speech synthesis. It will do all the heavy lifting for you. So you don't have to know anything about those topics. Dialogflow will take care of it for you. What you do have to do in Dialogflow is model your conversations. And to do that, you can use 3 important concepts. And I'm going to dive a little bit deeper into those concepts. The first concept is an intent. In Dialogflow, you can model intents. So an intent tries to capture the intent of the user. So in the game, you saw several intents. You saw pick up handle. You saw use handle on well. Those are all intents. The player intends to do something. Let's have a look at a simplified screenshot of Dialogflow and more specifically of the intent screen. This is the intent screen, and the intent you're seeing here is the help intent. So whenever you say something along the lines of, explain please, how does this work, what can I do, help me, Dialogflow will classify it as an help intent, and then it will come up with an answer which is in the bottom part. So the upper part is the input, and the lower part is the output. In this case, the output is really static. It's just hard-coded text. If you want more dynamic output, you need a backend, and we will talk about that in a few minutes. Also, what's in the training phrases, you don't have to say exactly what's there. I think in the demo I said, help me please. And then it also classified my request as an help intent. So say something along the lines, something similar. So then there are parameters and entities. And the easiest way to explain this is by using an analogy. I think most people watching will be programmers, so I will use programming analogies. So whenever you encounter in Dialogflow an entity, in programming we would call this an enumeration or a type. So an example would be days in a week. Just a list from Monday till Sunday of possible values. Then whenever you see a parameter in Dialogflow, in programming we would talk about variables. And a variable has a name and a value. So in the example, day is Monday, day would be the name of the variable and Monday would be the value of the variable. So Dialogflow has all kinds of default entities. Think about zip codes, days in a week, months, stuff like that. But you can also create your own entities. And for the game, I needed an entity called direction. And it contains all the cardinal directions. So north, south, east, and west. You will see those applied in a minute. So let's apply all those concepts and bring them together. So again, we're looking at a simplified screenshot from Dialogflow. And now we're looking only at the input part of an intent. And what I did, I typed in move north. Then Dialogflow is smart enough to recognize north as being one of the values of the entity direction. So what it does, let me grab my mouse. It creates a parameter, which we in programming would call a variable. It gives it a name, direction. It gives it a type, add direction. So it can contain north, south, east, and west. And it resolves the value. So it looks like this. It says the value will be north. So let's do exactly the same in a programming language like Java. First, there's the type, add direction. Notice the same color coding. Then there's the name of the variable, direction, and then there's the value, north. So by enabling those three concepts, I only have to create one move handler. The screen we're currently looking at, we only need one move intent. This move intent can handle the north, the south, the east, and the west. If I couldn't apply those concepts, I've had to create 4 move intents, which is cumbersome. So by using entities and parameters, I can keep my stuff generic, and that's something we like as programmers. So that's all about front end. Let's continue with the backend. So the backend has 3 responsibilities. The first one is execute game logic. So let's apply an example. If I'm in the game and I say go north, then the backend will check if there is a location to the north. If there is no location to the north, it will come up with an error response, and it will say something like you cannot go there. If there is a location to the north, then the game has to update the state. The location of the player has to change. And furthermore, the last responsibility is it has to come up with a proper dynamic reply. So in case of moving to a new location, it will tell you the description of the new location. So I explicitly said dynamic reply. Remember in the screenshot of the help intent, there was like a hard-coded string. Now we have the dynamic replies. So whenever you want dynamic replies, you have to use a backend. The game is written as a serverless Java function on AWS. You don't have to write your backend in Java. You can write it in any language that you like. And furthermore, you don't have to run it on AWS. You can run it on any cloud provider you like. There are only a few constraints. The first constraint is that your backend should expose a REST endpoint. And this REST endpoint has to be reachable from Dialogflow. This REST endpoint also has to consume Dialogflow requests and has to produce Dialogflow responses. Let's have a look at those messages. So first, the Dialogflow request. I'm going to show you a partial JSON. It's not a proper JSON, and I'm only going to show you the most important fields. So it starts with a query text. In this case, it's go west. So the players that go west to the game, and Dialogflow used speech-to-text algorithms to translate it into the string go west. Then there are optionally parameters, and here we have a direction. Its value is capital W, which signifies west, of course. And finally, there's the intent. Dialogflow will capture the intent of the user and will present it to the backend. So this is, in a nutshell, a Dialogflow request. This is all the data that goes from the front end to the backend. Then the backend has to produce a Dialogflow response. So it will read the request, do its magic, which I will explain in a minute, and then has to produce a response. And again, I'm going to show you partial Jnation, but only the most important fields. So first, there's the fulfillment text. This is the text, this is the answer of the game. So whenever you did a go north, it will come up with a description of location. You are standing, blah, blah, blah. But there is another important thing, and that is called the output context. This object is used to keep track of context. Dialogflow enables you to keep track of context. And this is really helpful because if we want to play a game, we also have to keep state. To be able to play the game, we at least need to know where the player is. So the location of the player is an important state parameter. State is something that happened in the past. Context is something that happened in the past. So we can use this context object to store our state in. And that's really helpful because I prefer to write stateless backends because those are far easier to create, to debug, to test, actually easier in everything. So we're going to put the state in the messages, and I will explain it a little bit more in a minute. So state. Actually, we need 3 state parameters to be able to play the game. I explained the first one already, location, and you need to know where the player is. If you want to pick up the handle, you have to be in the location where the handle is. If you want to use the handle on the well, you have to be in the location where the well is. So location is important. Then there is inventory and removed items. In the demo, we picked up the handle. So at that moment, we added the handle to the inventory. So this parameter would have 1 item. Then we went to the well and we used the handle on the well. At that moment, the handle went from the inventory to removed items. So the inventory is the stuff that you're carrying around and can use. And the removed items is the stuff that you used in the past and cannot use anymore. So only those 3 parameters is enough to play the voice adventure. A little bit more about the state and putting the state in the messages. I want to show you graphically how it works because I think that helps. So whenever the first request goes from the front end to the back end, there is no state. Nothing has happened yet. So then the back end gonna put a context object on the response. And as a consequence, Dialogflow, the front end, will put exactly the same object on the next request. Then the backend can modify this context or this state and put it on a response. And again, Dialogflow will put exactly the same object on the next request. So by using this mechanism of putting everything in the messages, state will be contained. There will be state and it will be in the messages. I hope this is clear. Otherwise, hopefully it will become clear during the live coding session. So last slide for the live coding. How are we doing for time? Excellent. Handlers. I told you the game has a lot of intents. We've seen the help intent, we have seen the pickup intent, we have seen the move intent, the use intent, so a lot of intents. Every intent is a handler, and a handler is a class in the backend that will take care of its corresponding intent. So let me give you an example. Let's do the move handler, but actually all the handlers have the same build-up. But the first thing the move handler will do is check validity. So let's assume we want to go north. The first thing the backend does is checking, is there a location to the north? If there isn't a location to the north, error message, you cannot go there. And if there is a location to the north, it has to update the state. So the location parameter you just saw in the JSON will be updated to the new location. And finally, it has to come up with a reply. And in the case of a move command, the reply will be the description of your new location. So those 3 states can be found in every handler. Okay, a live coding part. Like I said before, it's a Lambda on AWS. It's coded in Java. Why is that important? We're going to make some changes in the Java code in IntelliJ in a minute. And once we're done, we're going to upload it to production. And we're going to test it in our simulation environment to see if it works. What we are going to do is we're going to improve an existing handler. So you've seen me play the game, and I think there's something wrong with the game. I think we can improve the game. What I want to improve is the following. Whenever you go to a location, it will give you a description of that location. And this description can be pretty lengthy. And that's annoying, because if you have a lengthy description, you have to wait for about 10 seconds before you can continue playing the game. I think we can improve that. What I want to do, I want to add a feature. Whenever you go the first time to a location, you get a long description. And whenever you go all the other times, you should get a short description. So let me first show you the problem in the game, and then we're going to start coding. So I'm going to start up the game.
Getting the test version of Voice Adventure. Hi, welcome to Voice Adventure. You play this game like a text adventure, but instead of text, you use your voice. You can directly start with issuing commands or ask for more help.
Okay, I'm going to go north, and then it will give you a description of the location, which will be the long description.
You are standing in front of a big castle. There is a door, but it is locked.
Okay, now this is a long description, that's correct, but it's only like 2 sentences, not that long. Let's go south. Of course, that one is much longer.
You are at a crossing. In the north, you see a castle. In the east is a clearing in the woods. In the south is a cave. In the west is a well.
So this is a pretty lengthy description. It takes about 10 seconds to pronounce this description, so you have to wait as a player, which is annoying. So this is what we're going to fix. The next time when we're going to play the game, I hope it will give you a short description, at least the second, the third, and the etc. times. So the first time, long description, all other times, short description. I hope the problem and the solution is clear. We're going to go to IntelliJ. So before we're going to start coding, I'm going to give you a short overview of all the files in the game. Not all the files, but the most important ones. So the most important directory is the source directory, of course. So let's open that one up. Then there's the main folder and the test folder. And before I'm going to continue, I'm going to run all tests because I want to start from a position where everything is right. I don't want to start if there is something is broken and a test fails. So we're going to wait for the test. If you're wondering why it says Groovy over here instead of Java, that's because I prefer my unit test in Spock over JUnit. I'm also doing presentations about that. If you're interested, you can look me up at YouTube. So 38 passing tests. So our starting point is great. Let's go back to the main folder. So it's written in Java, as told before. And then this is the entry point of our application. So whenever you write a Lambda, you have to specify which method will be the entry point for your application. In my case, the entry point is the handle request. And this handle request has 2 important parameters, an input stream and an output stream. Now we're going to walk through the method because this is the main game loop. This is what happens all the time. First of all, the input stream is read. And all the data in there is translated into a request object. So now we can easily access all data from the request. Then we ask for the intent and we get the corresponding handler. So every intent had a handler. So here's where we get the handler. This handler is then used to call the update state method on it. So this will take care of the request and produce a response. At least it will produce an answer. And so here's the answer. And then we're going to create a reply object, which contains the answer and also the state, as shown before in the diagram with all the arrows. And finally, we write the reply to the output stream. So this is the main game loop. And there's a request coming in, we apply the handler, and then there will be a request. This is how it will work the entire time. So a few more files I would like to show. First of all, there's the item enumeration. So this contains all the items in the game. And then there is the location enumeration. It contains all the locations in the game. There are only 5 locations in the game. So during the demo, you saw a great part of the game. But more importantly, there is a short description and there is a long description. And this is what we're going to use in our new feature. Then there is the message package. And you've seen the request, you've seen the reply. We're going to skip the parameters, but we are interested in the state variable. We're going to do stuff in there in a minute. And finally, there is the handler package, which contains all the handlers I talked about. So back to the feature we want to add. I want to add a feature. Whenever you go for the first time to a location, you get a long description. And whenever you go all the other times you go there, I want to have a short description. Now, to be able to create this, we have to keep track of all the locations where the player has been while playing the game. Keeping track context, state. We have to do something in the state object. So the state object is on the screen. I'm not going to show you everything, but over here, you should recognize this. We needed 3 state parameters to be able to play the game. We need a location, we need an inventory, and we needed removed items. Now we're going to add one. I'm just copy the line. Oh. I call it visited locations. And this will be a set of location, not of item. That's too bad. Location. So what I did is I added the state parameter, but I didn't use the state parameter yet. So what I need to do next is whenever a reply comes in, I have to read the reply and fill the visited locations variable I've just added. And whenever I write a response, I have to put the visited locations in there. So let's start with the first one, the request part. Okay, whenever a request comes in, we have to create a new state. So here is the constructor of state. So we have to fill the visited locations variable. I'm just going to copy a line, just the last one. We want to fill something called visited locations. We will not put items in there. We put locations in there. And finally, we need to know how is it called in the JSON. What is the key in the JSON? So let's call it visited locations. This key doesn't exist. This constant doesn't exist. So IntelliJ, please create it for me. And bam, there it is. So we can give it any name because the front end will just copy it and the back end will use it. So my name would work, but we're going to give it a proper name. Visited locations. Then we put it next to the other state parameters. So now we have 4 state parameters when playing the game. I go back to the previous file, which is the state class. And those letters were red before, and now they are purple. So everything is compiling again. Let me go back here. So that was the request part. Now I have to do the reply part. So whenever this variable is filled, we have to put it in a reply. So I go to the next method, which handles the reply part. And again, I'm copying this line. So removed items should become visited locations because we want to write this key to the JSON. And the contents of the key will be visited locations. So I did 3 things. First, I've added a state parameter. Then I handled the request part, and then I handled the reply part. So our work to the state class is done. Actually, I added the capability of keeping track of state. We don't use it yet, but the capability is there. So because we don't use it yet, all tests should still be green. So let me rerun the tests to see if all tests still are green and I didn't break anything. I expect 38 green tests. Love you, demo gods. So before we're going to continue implementing the feature, because of time constraints, I've already written a test for the new feature. So I just have to enable it. I'm looking for the time. Oh yeah, okay, we're doing great. And I have to go to the test, so which is called move handler test. I don't know why, but IntelliJ keeps making this little window littler, more little, I think. So here's the test, the move handler test. So I'm not going to explain it. I'm just going to enable this line because we need it. Otherwise the test will fail. And here is my new test. The name of the new test is second move short description. Now it's written in Groovy, in Spock, you don't have to understand it. The most important part is here. We're going to check that the reply will have the short description and not the long description. So I'm going to rerun the test and I expect the new test to fail. So now I expect 39 tests and one of them should fail. Hey, 39 tests, 1 failed. Let's double click it. It's exactly the test I just uncommented. So that's awesome. So let's make sure that this test will be green in the next run. So I go back to the move handler. I get rid of this panel. Okay, so this is the move handler. It's a pretty simple class. I'm just going to walk you through it. It only has one method, the update state. We have seen this method already from my explanation from the main game loop. And its only parameter is a request. So the first few lines is about getting data from the request. The only important one currently for us is the current location. So this is where the player currently is. Then there is a default reply, cannot move there, which is specified on top, you cannot move there. So the first thing this method does is trying to move the player to the new location. So assume the player is at go north. Then this move method tries to move the player to the north. If it's not possible, the new location will be equal to the current location. So the move did not take place. If it is possible to move to the north, then the new location will be different from the current location. So, and this mechanism is used in this if. If the new location isn't equal to the current location, so the player has moved, then we're going to do some stuff. So what do? First, we change the state parameter location and we set it to the new location because the player has moved to a new location. Then we have to come up with a reply. And that's what happens here. So the reply will be the long description of the new location. And this is where the problem is. It will always give me the long description. And that just takes so long. So what we're going to do, we're going to do two things to this file. First, there needs to be an if here. Sometimes you want a short description and sometimes you want a long description. But there's another thing we have to do, and that is adding the location to the new state parameter. So we've created a state parameter, which is called visited locations. And now we have to add stuff to it. If we don't keep track of it, the feature will never work. So I'm going to start with the last part because that's the part I always forget when I prepare for this demo. So what we have to do, there's a state. I'm going to add a visited location. And this will be the new location, of course. So IntelliJ says that method doesn't exist. Now IntelliJ can help me there. So it creates the method for me and I just have to do a one-liner. So I have this visited locations parameter and I'm going to add the new location to there. So this simple method, with this simple method, you can add locations to the visited locations set. Let's go back to the move handler. All the red characters are gone, so it compiles again. Neat. And now I have to do the if, my last change. So this one, sometimes I want a long description, sometimes I want a short description. So let me type a little bit. State get visited locations. So let me explain this to you. If the new location is in the set visited locations, we've been somewhere before. So it's not the first time I go there. I want a short description. So reply is new location. Typing is hard, especially when you're doing a demo. So, and in all other cases, I want the long description. So let's first implement the missing method, and then we're going to see if the algorithm is correct. So I'm missing this one. So it proposes to return a collection of objects. I want it to return a set of location. And this one is even simpler than the one before. I just have to return our new variable, the one we've created. So let's see if that solves the compilation problem. The red color is gone, everything compiles again. So let's revisit the if. Let's see if we've done it correctly. So the if says, if the new location is in the visited locations, then I want a short description. So new location and visited locations, yeah, that's correct. Because new location and visited location means we've been there before. And if we've been there before, we want a short. In all other cases, we want the long. I think it's implemented correctly. Let's ask the tests. I expect 39 green tests. Yes, 39 green tests. Okay, according to the test, we implemented our feature correctly. So time for the next step, bring it to production. So bringing to production is actually uploading the Lambda. And I'm using a plugin for that called the AWS Explorer. Really nifty thing. Let me click a little bit and I'll explain everything it does. So I press update function code, and then I have to wait because it has to load this thing. And once it's loaded, I can press update and explain. So before using this plugin, I did all things by hand. So first I had to go to my browser. I had to go to AWS. I had to log in, do multi-factor authentication. So I had to grab my phone, fill in the number. Then I'm in the AWS console, which is really big and has a lot of features. And I have to find the Lambdas. I have to go to my Lambda. I go back to my local machine. I'm going to do a Maven package. This will give me a jar file. And then I have to upload the jar file by hand. So explaining this took longer than using the plugin, because you see down here, it says code updated for function voice adventure. So long story short, use the plugin. It's uploaded, so time to test it in production. So let's go to the simulation environment again. I'm gonna reload the page. And I'm gonna start the game.
Let's get the test version of Voice Adventure. Hi, welcome to Voice Adventure. You play this game like a text adventure, but instead of text, you use your voice. You can directly start with issuing commands or ask for more help.
Direct start by issuing commands. That sounds exactly as we want to do. So what we're going to do is we're going to go north. And this is the first time we're going to go north. So I expect a long description.
You are standing in front of a big castle. There is a door, but it is locked.
2 sentences, not that long, but it is the long description. Now I'm going to go south, and this one is a really long description.
You are at a crossing. In the north, you see a castle. In the east is a clearing in the woods. In the south is a cave. In the west is a well.
So 5 sentences. It took about 10 seconds to pronounce this. So now we're going to test a feature, because now I'm going to go north, and this will be the second time I go north. So now I expect a short description, so 1 sentence. Let's see what happens.
You see a big castle.
Yes, 1 sentence. So let's go to the south, where the difference will be really beneficial.
You see a crossing.
Only 1 sentence instead of 5. So big win. I'm really happy. The live coding part went successfully. Nothing broke. Really happy. So let's go back to the presentation and wrap things up. So the conclusion already. I've shown you in the last 40 minutes, it's pretty simple to build your own app. If you want to, you just use a front end, in which you should use Dialogflow. Almost everybody uses Dialogflow, and it's just a no-brainer. Use Dialogflow. If you want to write a really simple app with static answers, Dialogflow is enough. But if you want to do something a little bit more complex or a lot more complex, then you have to use a backend. Remember, you don't have to write your backend in Java. Any language is fine. You don't have to use AWS. Any cloud provider is fine. So I gave you a simple example. I showed you my little game, the Voice Adventure, but I think it contains concepts that everybody can use. The first concept is every intent should have a handler. So this mechanism works really well, and I think it will work really well for most applications. And finally, put your state in the messages. Use the context outputs object. So you have a stateless backend, and so everything will become easier. So questions. Now I'm looking at my co-companion, presenter, Danielle. Are there any questions?
Yeah, we have one question, but let me thank you for the great presentation. I think we are all expecting a full game now.
Yeah,
we want to go north and south,
and
grab all the items and find all the items. So I have a question here from Thierry Lafayette, and he's asking if you have used module-based Java 11 code to create your jar file, or the good old monolithic jar file.
Yeah, good question. When I started building this game, which was like 2 years ago, I don't think Java 11 was there, so I used Java 8. But recently I've upgraded to Java 11. but I didn't use a module system. It's just one big jar file. And to be honest, it is a small game. I think you saw about 20 files. And there could be a benefit of using the module system, but I think it will be really small.
So on the full game, we can expect a module system.
I feel some kind of obligation here. But let's
no pressure, man.
2021, the full game.
Okay. So I don't see any other questions either on Slack or YouTube.
That's fine. I have 2 slides left, so let me just finish.
Go.
And then,
yeah, of course.
We're done?
Course.
Okay, cool. First of all, I have 2 links. The first one is a link to the source. So it's on GitHub, but you can just see the source if you want to play with it or modify it. It's yours. And the second one is a link to the game. So there you can play the game. Don't play too fast because the game is not that big. Finally, I would like to thank you. I would like to thank everybody who's listening, watching, for being here. I hope you learned a new thing or two. If you have comments, remarks, questions, my Twitter handle is in the bottom right corner of every slide. So please contact me there. Thanks again, and I hope to see you next year. Bye-bye.
Thanks, Mark. Hope to see you back into Jnation in the future, preferably in Coimbra on site instead of online. Let's see how we handle this pandemic. Thanks a lot. And if you need anything from Mark, try to reach him through Twitter, as I said, or just drop questions in the Almedina chat, and we'll try to reach him. Thanks a lot once again, Bob.
Thank you as well. Bye-bye.
See you later, guys.
Mindera, it's first and foremost a tech company, but I would say it's not a very traditional company.
We don't have this pyramid of job descriptions versus one manager that manages another guy and yet so and so and so. To make a quote from the movie Fury, Mindera is to me the best job I ever had.
Hello, and welcome to another session. My name is Leon, and I'll be your host in the upcoming couple of sessions. Thank you for following us today and our sponsor for making this event possible. Also, a huge thanks to the person who you're here to see and hear, Ugo Penedones. Hi, Ugo. How are you doing?
Great, and you, Leon?
I'm really good. Sunny here in Belgium. I heard that you recently moved back to Portugal. How does it feel like to come back?
Exactly. It's great to be back. I spent about 13 years abroad after I finished my studies in Porto. And now I'm back to be part of this exciting machine learning community in Portugal.
Great. So Ugo will do his talk about reinforcement learning and long-term value prediction. Just before we start, feel free to ask questions on our YouTube channel or on the Slack channel. And also feel free to react to any of those questions and comment on anything that pops up on Slack. Ugo, the floor is yours. Good luck.
Thank you. Okay, so the plan for today, given that we have about 50 minutes, it's to split my talk into 3 main sections. The first one, I will give you kind of an introduction about reinforcement learning, a review about the problem setup, the main concepts, and some well-established algorithms. And then I will move on into what was my area of research in the last couple of years, jointly with colleagues from DeepMind in London and Google Brain in Zurich, which is about a sub-problem of reinforcement learning that you will learn about later. And then we'll have some time at the end in which I will give you a few pointers on how to learn more about this, how you can apply RL to some real-world problems, and leave you time to do some questions. So you probably heard about reinforcement learning due to a wave of recent successes in the last 5 or 6 years, and they were mostly applied to games. So the game of Atari, there's a console with 57 different games. The game of Go, which is a board strategy game, and other games that became also quite popular, like StarCraft, Dota, and so on. But given that I'm not assuming that you have a background in reinforcement learning, I want to start by contrasting it to other problems of machine learning that you are more used to, like supervised learning. So in supervised learning, you typically want to learn a complex function from data. So for example, if you want to distinguish images of cats from dogs, you would construct a data set, and then you would have a process of training your function approximator like a neural network by constructing a loss function that you say, oh, is my prediction close to my expected output? And learning is basically the optimization process in which you are minimizing this loss and your output is getting closer and closer to what you expect from your labeled data. But machine learning is a bit broader, right? So it includes what we just said, supervised learning. It also includes unsupervised learning, in which you have data without labels, and you just want to find some hidden structure of the data. It also includes the problem that is not very popular of self-supervised learning, in which originally you have data without labels, a bit like an unsupervised learning, but you are able to derive labels automatically. For example, if you have a sequence like a video and you want to predict, let's say, the next frames from the previous ones, you kind of automatically derive annotations from data that is not originally annotated by humans. And then the field of reinforcement learning, which is the one we'll focus on today, is actually a setup in which your data comes as a sequence of states annotated with scalar rewards, and possibly with also the actions that an agent took. So to understand how this data is generated, the problem setup is normally the following. You have an agent that interacts with an environment. So at each step, it receives an observation. It can take then an action. And then in the next step, it will get another observation and also a reward, which basically will tell the agent how well it is doing in performing a specific task. So this reward can just be a real value, could be 0, could be positive or negative. And normally you want to maximize the rewards you keep getting into the future. So again, to contrast it with the supervised learning, if you had some problem like a navigation task in which you want to go from point A to point B, you could still try to formulate this as supervised learning, but in that case, you would need to know the solution and get it annotated by humans. And for each precise location, you'll have to have a label, say, go forward at this location, then left, and forward, and so on, to get to the goal. In reinforcement learning, this setup is different. You assume you don't know this solution, and the agent has to try out by trial and errors different directions, different actions. And the only feedback you will give to the agent is, well, let's say you're getting colder, warmer, let's say you're getting closer to the target, further away, and so on. And it has to figure out the solution by itself. The way reinforcement learning is more formally specified is by what is called the Markov decision process. So this is a set of 4 main ingredients. So S is the set of states that are allowed in your system. A is the set of actions that you can take as an agent. P here is the probability, is the transitions probability. So it's a function that tells you, given that you are in a given state and you apply a given action, you are in state S, you apply action A, what is the probability you will end up in this other state? So this encodes a bit the environment dynamics. What are the rules of physics of your system? What is going on? And in addition to that, you also have a reward function which tells you, okay, if you are in this state, you receive this reward, or can be even slightly more generic. If you are in this state, take this action and reach that state, you get this reward. Notice that there is, despite the fact that there are only these 4 main ingredients, there's a lot of variability here. So the action space can actually be pretty small. Like in Atari console, you can only do 18 different actions with a joystick. In Go, you can do maybe 361 positions where you can put a stone. But you can have very large action spaces, like in recommender systems, if you want to recommend the next video in YouTube or stuff like that. And in addition, they can be either discrete, if there is a finite set of actions you can take, or continuous, like in the joints of a robot you need to control. So these are different setups. For the state space, the same thing happens. They can also be large, small, discrete, continuous. And further to that, they might be fully observable or only partial observable. If you only see part of the information of the world, like what you see in front of your eyes, rather than the whole world, which also makes things harder. And the environment dynamics, which is a bit encoded by those transition probabilities, could be deterministic. If for each time you are in a given state, you apply the same action, you'll get the same outcome. Or it could be stochastic if the outcomes could have a random component. Likewise, for the reward function, they could be deterministic or stochastic. Sometimes you have situations in which by applying the same action, you get different rewards. This also makes learning harder. And you can have what is called dense or sparse rewards. So in some environments, you get rewards that are different than 0 very often, like at every time step, which allows you to learn relatively fast. In some domains, you spend a lot of time getting 0 rewards, so it's harder to kick off learning. Okay, so given this setup, there are very few concepts you need to learn. So one of them is what is a policy. A policy is just a function that defines our behavior. So this policy pi is a probability distribution over actions that you can take given an input state or observation. And normally in RL, you want to find a good policy that takes actions that maximize your sum of rewards. And the sum of rewards normally is more precisely defined as what we call discounted return, which is summing the rewards you get from time t into the future, possibly with a discount factor gamma that is normally between 0 and 1, should be normally close to 1, to give a little bit more importance to immediate rewards than future rewards. Another concept that is appear very frequently in reinforcement learning, and this we will talk a lot about those in the rest of the talk because it's very related to the research I did. So pay attention if you can, is what is a value function. And there are two kinds of value functions. The most basic one, which is the state value function, just encodes what is the expected return you get for a given policy pi. So for a given, it's already a fixed policy. If you start from state S and you now execute that policy into the future, what is your expected return? And very similarly, what is called the action value function or a Q function is pretty almost the same as here, but now you introduce as an argument also the action. So you say, if I'm in state S and now I take action A, what is the expected return? I take action A, and then from then onwards, I behave according to the policy pi, which is fixed. What is my expected return? So this is often things that reinforcement learning algorithms want to estimate, because once you have this, you are able to estimate your long-term value of executing that policy, and you are also, by just doing one more simple trick, try to get it better and better. So one important distinction between classes of RL algorithms that exist is the following: policy evaluation versus policy improvement. By evaluation, you just mean you have a fixed policy, and you just want to learn these value functions, either the state value function or the action value function, and that's it. You are not attempting to improve the policy. What most often people care about is go beyond that, which is also policy improvement, in which there is an intermediate step often in which you do policy evaluation, but then you start acting greedily according to the value function estimated. So, okay, I realize that if I would take this other action that my policy is not recommending, but if I would take it, it would be even better. So there is often this loop of evaluating the current policy, acting greedily according to it, evaluate it again and repeat. And this leads to better and better policies. So in fact, despite the fact that deep reinforcement learning, which was the merging of reinforcement learning with deep learning, so the field of deep neural networks, has become very popular is only in the last 5 or 6 years, the main algorithms behind reinforcement learning are not new at all. So around in the late 80s, there were 2 algorithms already for each of these class of problems, for policy evaluation and for policy improvement. So TD learning in 88 by Rich Sutton, and Q learning in 89 by Watkins. However, notice here what I said, this only worked very well for tabular functions. So it was not for the case of neural network function approximators. By tabular functions, I mean that what you want to learn is just a table with numbers. You assume that your problem is small enough so that you can enumerate every state. You can store it just in a table, and you have a number like a float double or whatever, just for each of those states that will try to estimate its value. This would be for the value function. For the action value function, you would just have a slightly bigger table in which you would have, for each possible action in that state, you try to estimate the Q value for that state and action pair. So this was working, right? And in fact, the temporal difference learning algorithm, for example, could almost be described with one line update rule, right? If you're just trying to estimate this expected sum of returns into the future, Sutton with this one line update rule, which basically defines a recurrence relation between consecutive states. It's a bit like in the graph algorithms when you do dynamic programming for shortest paths. It's basically updating a guess from a guess. So if you have a guess for the value of the next state, you by almost by definition, by the definition of value function, you can improve your current estimate by just taking a gradient step in that direction. In fact, the algorithm could be described in just a few lines of code in which you iterate over the transitions and just do this update rule. Likewise for Q learning, in which the update rule is slightly longer just now because you take into account actions and it's a Q function. And also because you are acting greedily according to it to generate better functions, there is this hard argmax here over the best action that you can take in the next state. And again, the algorithm is simple. So what was all the fuss about in the last few years? Well, what happened is that at DeepMind, people were able around 2014 to make this work actually with neural networks for much more complex states or observations than just things that you could enumerate, right? So, for example, for the Atari console, you will be getting the pixels of the game. So it's 100 by hundreds of pixels, and you need to take one of out the 18 actions. So now you can no longer encode, you can no longer store a function, a table with for every possible state and action, what would be the value. What you need to do is to have some sort of function approximation. In this case, would be a convolutional neural network to map directly from the inputs to the outputs and learn the best you can this function. And this did not work out of the box just with Q learning because it would be unstable. So the two tricks basically that were introduced were just two. One of them was this experience replay in which transitions, instead of learning with the latest transition that you took, like the next action that you took, you would store things in a buffer, basically some memory, and then you sample uniformly from that. So sometimes you will be learning with things that happened a little bit more in the past. And this would make it more stable. The other thing was a trick called target networks, in which you actually have two copies of the Q function of the neural network you're trying to approximate. And for a given amount of steps, let's say 10,000, you freeze those while you are defining your loss function, and you just update the other copy. And then after a while, you copy back to the target network and you do again. So this also introduces more stability in learning. Since then, a lot of progress happened. Really, just like last month, there was a paper called Agent 57 in the lineage of DQN that already includes literally dozens of more techniques. So beyond the experience replay and target network, now it has things like prioritized experience replay, distributed RL. It has more things for long-term, for short-term memory, like LSTMs, episodic memory. It has a lot of things on how to do exploration properly. I didn't mention this before, but in RL, you need to get the balance between exploration and exploitation right. So you need to do some trial and error. There's a lot of techniques going on here, and a few more things that labeled under meta controller to optimize this whole process better. So a lot of complexity. However, what I want to do for the rest of my talk is actually coming back to the basics, and that was my research in the last couple of years. So it will mostly refer to two papers that are mentioned here. One of the, well, you can find both of them in arXiv. The latest one, this one, Adaptive Temporal Difference Learning, was published in NeoRIPS last year, which is one of the main machine learning conferences. But the goal was really to go back to this very fundamental problem of why is it hard to do reinforcement learning with function approximation, which was the original thing DQN was trying to solve. And so I started wondering, can we get even to a simpler setup than what DQN is trying to solve? And do the problems already exist there? And the answer, as you will see, it will be yes. So rather than trying to do policy optimization or improvement like DQN is doing, like trying to find a good policy, I will restrict myself to doing just policy evaluation. Like we mentioned before, it's just trying to learn the value function of a fixed policy, not try to improve the policy, that's all. Instead of doing online learning like DQN is doing, which is basically learning while acting, I will restrict myself to doing offline learning, or it's called also batch RL, which means you have a pre-collected set of trajectories generated by a policy, and this is your fixed training data set. It's much like in supervised learning. You are given a data set that is already collected, is not going to change, and you can just play with that. This also simplifies the problem. It's more reproducible, and as you will see, it's still problematic in some scenarios. Another thing that it's as sort of a simplification is that we restrict ourselves to the problem of on-policy learning. This means that you are trying to learn the value function for a policy that is the same as the one that connected the data. A harder problem, which is called off-policy learning, is the one in which you are trying to learn the value function of a policy pi, but the data that you are given was collected by a different policy. As you can imagine, this problem is much harder, right? Especially if the two policies, they differ too much. In the limit, they could do things so differently and visit different areas of the state space almost without no overlap. That basically this would be impossible. But we are restricting ourselves to a scenario that is possible, which is on policy data. And our goal will be to make a precise estimation of the value function. By this I mean with low mean square error of your predictions, right? You want your value function that you learn to be precise. Well, I can tell you that actually even simpler than TD learning, there is this method called Monte Carlo reduction, which is basically just converting the policy evaluation problem into a supervised learning problem. So it's a naive thing you would do, and it's actually can be quite good. So basically what this means is that you have these trajectories. Let's say they start from these states, and then you run your policy, it visits this state, and let's assume that you only get some rewards at the end, let's say. If you want to estimate the value of, let's say, state C, let's say A is more interesting. From state A, we have two trajectories that started from state A. In one of them, it ended up in this state, you ended up having a return of -1. In this one, 7. What you would naively do, and this is the correct thing to do, is that you would estimate the value of A by averaging out the returns for different trajectories that started from it. So if you do this for each of these cases, you would end up with this estimate. This is basically what is called Monte Carlo regression. So it's basically just pre-computing the returns and then do the regression. What temporal difference learning, the algorithm that like Sutton introduced in ATA tried to do is like, can you do better than Monte Carlo regression? Well, if you notice, some of the trajectories, some of the states, for example, if you start in state C, you only have one trajectory that started from there, and you only have one measurement, you got a -4. However, this trajectory actually intersected with other trajectories for which you have more data. So because you are assuming that the Markov property holds, which is if you are in a given state, all that matters is that state, the past does not count, you could do better, right? You could reuse partial information from other trajectories to help you estimate this other state. So for example, in this case, your estimate for C would actually now become dependent of your estimate from state X, which in turn was dependent on the estimate for Y and so on. And here you benefited from a lot of intersections from other trajectories. So in fact, you could get an estimate that is more precise because you exploited the Markov property, whereas in the Monte Carlo regression, you did not exploit that property. So it's less sample efficient, and therefore the beauty of TD learning. However, remember that this is great as long as you are dealing with the tabular RL. So you are representing a function in just a big table of numbers. However, and this was our observation, you will see later, with pretty much any kind of function approximation that you might introduce, and some of them really, really simple and very close to tabular approximation, doing temporal difference learning is no longer safe in the sense that it's not guaranteed to converge to the same solution found by Monte Carlo regression, which converges to the right solution when you have more and more data. And to understand why, I will give you another simple example that we derived specifically for that to communicate better what is going on. And it's a simple Markov decision process in which you have a starting state at 0. From there, you can go from 1 to k states, and then some of them, the first branch, like from 1 to p states, go to this b1 state, and in this right side of the branch, they go to b2. Then they all join here, and only at the end, you get a reward, let's say that is sampled from a Gaussian, some mean and sigma. Everywhere else, you get 0 rewards. And then we will study two scenarios, one in which is basically the tabular approximation in which you can learn one parameter for each of these. And the other one, we just introduce a small kind of function approximation mistake in which you are the value for B1 is not learnable. It's fixed to some constant. So you are bound to make a mistake on the evaluation of that state. And this is what happens. So if you, this is Monte Carlo versus deep learning. If you're doing tabular learning, basically TD in this case just dominates Monte Carlo. So the x-axis is the number of trajectories you have available. So the more data you have available, normally the better you do at estimating the value function for both cases. And what you notice, however, is that Monte Carlo in the beginning with very few data will have a lot of noise because you will be estimating the values for these states and only a fraction of the trajectories pass there, right? If you have, let's say, 40 of these states here, only 1 out of 40 trajectories pass there. So you will be, you will need a lot of trajectories to start having evidence for these states. And therefore, in TD, because you are actually updating your guess from successor states, and these B1 and B2, a lot of trajectories pass there, right? Almost everything passes there. You are able, and in Q everyone passes, you are able to bootstrap your estimates for SP from the successor states, which are super precisely estimated. So that's why TD does so much better. However, if we go back and now we say, okay, this the value for this B1 is not learnable. You need to live with the fact that it's fixed to a constant, it's some bias, and that's all. Well, now TD starts to have a big problem, which is even with the infinite amount of data, the more that you get, you will still incur a big penalty, because all the states S1 to SP, which are bootstrapping, are doing this TD update from the value of B1, they will be wrong, because this is set to a wrong value that we cannot move, and you are estimating the value of S1 to SP from there. So all of these estimates will be wrong, no matter how much data you have. Whereas MC will deal with it, right? Because it's not bootstrapping from the erroneous value of state B1. There is, okay, I don't go into details. There is a variant in the literature called TD Lambda in which you can interpolate between these two approaches, but it doesn't really solve the problem because the Lambda, it's not like state dependent. So it's also, it's not a miracle. So what we defined a new algorithm that we called adaptive TD algorithm, in which basically you try to do temporal difference learning to have more sample efficiency, unless you realize that your Monte Carlo estimate is telling you you should not trust TD. So basically for each state, you will also compute the Monte Carlo returns and even try to derive a confidence interval. And the more data you have, the more the confidence interval for the value of that state using Monte Carlo returns will shrink. And at some point, if you have states in which TD is bootstrapping wrong values, you will be able to realize that you should not do temporal difference learning in those states and switch to Monte Carlo. So basically, the illustration for this plot is the following. This is the confidence intervals calculated with Monte Carlo returns in blue for all of these states. And in green, you have the TD estimate, right? So for the first, let's say 10 states that S1 to SP, if there is a bias there, okay, they are wrong. So what, but if you constructed these confidence intervals for Monte Carlo regression, you should be able to detect, oh, this must be wrong with enough data and switch for these stages for Monte Carlo regression. That's exactly what our algorithm does, adaptive TD. So if you see now the same plot as the beginning, now with adaptive TD, when you are doing tabular learning, you do almost as well as TD, a little bit less sample efficient, but still much more efficient than Monte Carlo regression. However, when you have the bias in which the naive TD suffers from independently on how much more data you have, the adaptive TD is now able to correct and pretty much converge to the good solution, and even faster than MC. So, and that was for a very small perturbation to what you would call function approximation, right? It's almost tabular learning, just affecting one state. But can you do also a similar thing if you are dealing with much more complex problems, like with neural networks? Well, we try to study those in a setup in which we have this kind of 2D labyrinth, in which you have some green areas where you get a reward. You have some walls in which the agent cannot cross. And basically, here we use the policy that is is a random policy. It's basically a random walk, takes small steps. And here, with a lot of simulations, we compute what would be the true value function for that random policy. So as you could see, if you are close to one of these green targets, your expected return is much higher because you are likely to go there and bump into rewards. And the further you move away, because there is a discount factor in our setup, maybe 0.9 or 0.99, I don't remember, the expected return will be lower and lower and lower, right? And in the middle corridor, it's pretty low because the expected number of steps you need to take to get to these reward areas are quite big. And we had different layouts for this, different configurations. We computed this ground truth value functions with a lot of simulations, like thousands of runs from each initial starting point. And one thing you can observe with neural networks that is related to that problem of propagating estimation errors is the following. in a room like this, in which in a layout like this, in which you have two rooms, if you do Monte Carlo regression and you try to learn this function from data, let's say from 50 rollouts, and then you compare it to the ground truth that we computed, you can derive this heat map on that encodes the errors, your prediction errors towards the ground truth. So basically, if you would be green, you're estimating pretty well. Blue, you are underestimating. Red, you are overestimating. With Monte Carlo regression, you see you are doing a pretty good job, especially in the upper room where there is zero rewards. You are more or less confident that there should be zeros everywhere. But you will notice that near the wall, there will be this mistake just because neural networks will leak a bit towards the other side of the wall, in the sense that you cannot learn that sharp discontinuity. So just because of your neural network capacity and inherently smoothness, you will overestimate a bit from the other side of the wall, okay? But the Monte Carlo regression is contained there. If you do TD learning, what will happen is what we call this leakage propagation problem, which is described in more detail in this other paper that we have. This will be further propagated to other regions of the state, again, because you are updating a guess from a guess, like nearby states near the wall will have this recurrent update rule in which they use estimates from states that are closer to the wall and are suffering from that approximation error, and this will spread further and further. So this shows you that this fragility, this problem will happen when you have function approximators. And what we did to try to overcome it was use the same adaptive temporal difference learning algorithm, but now we need a way to construct confidence intervals using neural networks. And to achieve so, there's a variety of methods, but the simple one we chose is using ensembles of neural networks. So you train M different neural networks, each of them with slightly different data sets. You can do this bootstrapping of like sampling, let's say 2/3 of the trajectory with repetition, and you train on that, maybe also with different initialization. So each of the M neural networks will do slightly different predictions. And the intuition is that in regions in which all of them agree, you can be pretty confident that the value is correct, right? Because all of them agree. In regions in which the neural network predictions in the ensemble, they differ, you should have less confidence. So your confidence interval is wider. So using that criteria, you can basically apply then the same adaptive TD algorithm in which you can decide per state whether you should do a TD update or a Monte Carlo update. And so we showed that, again, in this simple layout, if you compute the mean square value error of your value function approximation, you get a pretty good trade-off. I mean, it's not, obviously, it's not as clear as in the simple kind of near tabular approximation we showed in the beginning, because computing confidence intervals with neural network ensembles is harder, but it's still a pretty good trade-off, because with adaptive TD, if you don't know if you have enough data and which map layout you are, you'll get a pretty good trade-off compared to picking one of the alternatives, MC or TD, without any prior knowledge. So if you're interested in learning more details about this, I encourage you to read our paper that appeared at NeurIPS. This was done with colleagues from DeepMind, Google Brain in Zurich, and also a colleague from that works in the university in Barcelona. And there you see more results in other environments like Mountain Car and Atari games. So as we are approaching the final 10 minutes or so of our talk, I just want to conclude by giving you a few further pointers to applications and resources where you can learn more about these things. So one thing I want you to keep in mind is that you can apply reinforcement learning concepts progressively in your application if you have one in mind. So first of all, you have to identify if you have a sequential decision-making process. So if there is a series of state and actions you need to take, And if there is a long-term metric you care about, like this sum of rewards, if that is the case, you can consider using RL. You can start by doing what I call batch RL or offline RL, which is try to use some of pre-existing collected data rather than trying to learn online, interacting, let's say, with the users of your recommender system or things which involve problems of safety or degradation of the experience of users. You can still start to do batch reinforcement learning and use techniques like Monte Carlo regression, which is very similar to basically supervised learning. If you just do this step, you are already optimizing for long-term metrics rather than short-sighted metrics, but it's still super stable like supervised learning. Then if your domain allows you and you have more experience with RL, you could try to do the temporal difference learning. Right now you define a temporal difference loss, and you can try to do this bootstrapping. So maybe it would be more sample efficient, right? You could try to go further than that, which is try to learn online, right? If you are very confident that you can interact with the environment without causing safety problems, or if you can tolerate doing some mistakes in the beginning, you could try to train online. And finally, you could also try to do exploration, which is try new actions that you haven't evaluated just to collect more information. But all of this, it's like you don't need to do all of them to start with RL, right? So for example, my previous colleagues at DeepMind, they did a few collaborations with products at Google in which this is basically what was done, right? So you might have heard about this data centers cooling project in which Google has these big data centers. There is a cooling system to extract heat from the servers. And there's things you can control, like pumps to pump water or fans to extract hot air and so on. And your goal is to, keep the data center at a reasonable operating temperature while minimizing the energy you use to operate the cooling system. So what my colleagues did was, if you try to formulate this as a reinforcement learning problem in which basically what you are optimizing for is the energy usage should be low, or well, they have defined an inverse measure, which is like how efficient they are. So they want to be more and more efficient. You can use historical data to just try to learn this Q function, this state action value function, in which you say, okay, given the operating policy that existed by the human operators, what is the expected efficiency or how much energy this will use in the next few hours? And you will do exactly the thing, policy evaluation. And then you have an idea of how this policy will work. And maybe then you can start giving suggestions to the operators to operate it more efficiently. So that's pretty much what was done. And then you can gradually introduce more direct control, more exploration once you have confidence that you can do it. Same thing applies to recommender systems, right? Like we had projects with shopping, play, and so on, in which now the actions, instead of being these industrial controls, is more like things you recommend to the user, like applications to install, or videos to watch, or products to shop, and so on. And you can, again, use historical data to estimate the long-term value of things. And this is very important. I encourage all organizations to do this. Like YouTube had a few years back this problem that if you just optimize to immediate clicks, you are likely to start showing just clickbait videos that are poor quality that maybe will lead the users to click on something. But in the long run, this degrades user experience. So maybe next week they will not use YouTube as much or so on, and they will consider it less useful for their lives. Whereas if you optimize for long-term metrics, like it would be natural to do it in reinforcement learning, you can suggest high-quality things that satisfy the user in the long term. Okay, so, and because this is a conference in which traditionally the audience was interested in Java and JavaScript, I just wanted to point you to some things. Like, so you know that the deep learning community now is totally dominated by two libraries, which are TensorFlow and PyTorch, and they are both implemented in C++, the underlying core of the library, to be super efficient. But they have an interface in Python so that people write programs in Python, and they can use all the other libraries for data visualization and so on that exist. However, maybe some of you are more interested in Java, and I noticed that there are a few libraries now available. There used to be this Weka library that was very popular like 15 years ago. It became less popular, but now they are also doing some deep learning. There's DL4J, and there's also one, I think, more recent one by Amazon, this Deep Java library. And for those of you interested in JavaScript, there's also, this one is very well supported. There's also even TensorFlow JavaScript, in which you can run TensorFlow directly in the browser. For actually learning, reinforcement learning, you can do it in the browser in at least two ways that I recommend. One is using this Google Python Colabs. Again, it will be more Python, and it's a client-server architecture. So the kernel can be running locally or in the cloud, even with the hardware acceleration. And for those of you, again, if you are interested more in languages like JavaScript, there's, for example, this library made by a researcher called Reinforce.js, which natively is implemented in JavaScript, and you can run it in the browser. I had a look at their webpage, and some things we can play with, like things I mentioned, like the tabular temporal difference learning, deep Q learning. There's implementations of these that you can run in the browser, and it's JavaScript. So if you're more familiar with those and you want to learn more, you can just go ahead. All right, so to conclude, reinforcement learning is a framework for sequential decision-making process. It allows you to optimize for long-term metrics. You can even go beyond human performance without human labels. And there are still many interesting fundamental research problems, but you can already apply some of those techniques in real systems. So yeah, go ahead and learn more about it, even inside your browser.
All right.
Thank you.
Thank you so much. So actually, one quick question. So if somebody wants to get his or her hands dirty and do their first small reinforcement learning project, what do you think could be a good starting point, or what should they do as a first step, let's say?
Exactly. So in this links here, for example, you can use one of these reinforced JavaScript libraries that you can run in the browser, or if you are more comfortable with Python, I encourage you to search for some of the examples that you can find with the Colabs or Jupyter notebooks. For example, in simple environments like Cartpole, in which there is a simple cart with a pendulum that you need to control optimally to get rewards. There's examples with DQN, but they will take a little longer to train. So it's better to start with environments that are light, so they have low dimensionality, so that you can iterate faster, right? Otherwise, for example, with the Atari games, maybe you have to wait a few hours to train. But if you start with things like Cartpole, in a few minutes, you'll see the results, right?
All right.
So there's a lot of tutorials like that.
Perfect. Thank you. I think there are already some people who are eager to try it out. And one maybe last question: how do you see? So what do you think are now the main struggles in reinforcement learning and the main blockers for the advancement in the field, so to say?
Yeah. So in this talk, I don't mention too much that, but well, there are different problems, right? So one of them is how do you do this in the real world? So for example, the problem of safety. So if you have to learn directly with robots, or you are trying to, let's say, train a self-driving car or things like that, one of the components that reinforcement learning usually has is doing exploratory moves, trying things out. You need to be aware of safety, right? You cannot just do things that cause damage to your robot or people, or even in recommender systems, you cannot just show poor recommendations. So you need to incorporate some awareness of the safety and the risks. Another challenge is doing it more sample efficiently. So in some of the state-of-the-art algorithms, they require like hundreds of millions of interactions with the environment. to learn properly. But if you are trying to do this more in domains like in the real world, you would need to learn with much fewer data. So for example, there are techniques in which you learn partially in simulation and then you refine with real data, things like that. So I think those are the main challenges. And in the beginning, I also mentioned that depending on your problem setup, like the dimensionality of your action space, your state space, whether it's spatial observable or not, all of this can add complexity. Whether you have sparse rewards or not can cause more problems of exploration. So each domain, even for humans, right? Like if I put you in a new domain, which is you only observe part of the world, you don't get any feedback, it's very complex. Even for humans, it will be hard, right? So this
That's
will
true.
also be exposed to algorithms.
That's true. If you just take a look at how long a baby takes to learn about his environment, it's quite a long time. And talking about that, actually, one last question. We have only 1 minute. How do you see reinforcement learning in long term? Do you think it's a way to a more, let's say, general AI or something like that?
Yeah. So I think reinforcement learning it's a good way of formalizing the general artificial intelligence problem in the sense that you have an agent that needs to make decisions, interacts with the environment and gets feedback from the environment as a reward. So I think it's a pretty generic formulation, and you can represent what is intelligent behavior, I think, pretty well in this framework. But then the way you solve it might change a lot, right? And it might need a lot more components. I showed you this slide with the Agent 57, which is one of the state of the arts now. It already includes like 20 different techniques that were published initially in 20 independent papers, and they all got together very carefully by research engineers at DeepMind to make things work better, right? So, and the more you progress, the more components you'll need to add, right? Like maybe you need to add some Bayesian learning. Maybe you need to incorporate symbolic learning. Maybe, you see, all of these components that in machine learning are treated somehow independently. To make better and better agents, you need to aggregate them into a single algorithm, right? So that will take time.
All right, Ugo, thank you so much for these 15 minutes. I hope that also you guys enjoyed it. We'll be back in 10 minutes in this room of the next talk, and meanwhile, enjoy the break. Thank you, Ugo. Bye, and thank you, everyone. Bye-bye.
Bye.
Hello, and welcome to another session at Jnation 2020. My name is Leon, and I will be hosting the session for you. Thank you for following us today, and also a big thanks to our sponsors for making this event possible, especially in these times. And finally, a big thanks also to the two people who are here for you to see and hear, and that's Kira Wolfert and Andrea Fritoli. Hi, Kira. Hi, Andrea. You're joining us from Cardiff, right?
Yes.
Yes.
Perfect. How are you guys doing?
Great. Yes. Excited to be here.
Great. It's also exciting for us to have you here. So they will be doing their talk about machine learning for continuous integration, which I'm also quite curious about this topic as well. But just right before we start, just a reminder that you can ask your question on our YouTube channel or also on our Slack channel, and feel free to also react to any comments on or comment on any of the questions. Andrea, Kira, the floor is yours. Good luck.
Thank you.
Thank you. Thank you, Leon, for the introduction, and thanks everyone for joining our call here today. Well, we introduced us already, but my name is Andrea Frittoli.
And my name is Kira Wolfert.
Yes, and today we are going to talk about how we applied machine learning to continuous integration. A couple of words about the team. So Matthew and myself, we used to maintain a rather large CI system. And so we worked daily on making sure that the CI system was running smoothly, and we had to triage failures and understand what was going on. A lot of failures, well, not so many failures, but it was a large CI system, so it was more than a small engineering team could handle easily. So we had the idea that maybe AI or specifically machine learning could help us here in dealing with this problem. We did have the domain knowledge for the CI type of environment, but we kind of lacked the expertise in the machine learning area. So we asked Kira whether she wanted to join us, and luckily for us, she joined the team. And so we were able to kick off this project. And we had our machine learning expert on board. Before I dive in, I just wanted to say a couple of words on continuous integration. So nowadays, continuous integration is a good practice, standard good practice for software development, and even more so in open source projects. So continuous integrations has many definitions, but basically it means to continuously test the different components of a software together every time a change is made to the software, or even every time a change is proposed to the software. And if your open source project is successful, you have a lot of contributions. And a lot of contributions then imply a lot of testing, a lot of CI jobs being executed. A CI job is made of several tests which are executed to verify that things are fine in the change that has been proposed. And if you look at the numbers for the open source project we're working on, this is on the ordinate. It's actually tens of millions of tests executed daily. So even though things were normally running smoothly, from these numbers you can imagine every now and then failures happened. And all this testing produced a lot of data and a lot of logs. And the beauty of this is that because it's open source, also the data produced by the testing is open source, so it's open data. And we thought this is actually a great opportunity for us to jump in and do some machine learning in the open. The specific project we were working on is OpenStack. OpenStack is a cloud management tool. So it's a set of APIs that allows you to manage virtual resources of different kinds, like virtual machines, disks, networks, and even other higher level abstractions. Integration testing for OpenStack means in a virtual machine as a test environment, actually deploying a cloud within the virtual machine, and on this cloud, creating nested virtual machines, disks, and networks. All these resources generate a number of different resource utilization on the virtual machine that is being tested. So you can see on the right side, there is the graph moving, show different examples of normalized system average load from virtual machines that were executing tests. So in OpenStack, every time a change is proposed to the system, we run integration tests on it, which means that the software is verified that all the tests are passing. The code is also reviewed by a human being, and once the code is approved, the change is tested again through what we call gate testing. So in gate testing, we already know that the test passed and that the code is good quality because it has been reviewed, but we test it again nonetheless before merging to making sure that perhaps rebasing the code, nothing went wrong. And so we saw some failures, more failures than we expected in gate. And we often suspected that these failures might be related to load on the virtual machines, our test environments. So we started collecting data from the test environments. Because the test environments are ephemeral, during the test, we write logs, system logs, application log, and we started using a tool called dist to write a log that contains key metrics on the operating system, like disk I/O, CPU, network utilization, and so forth. So before the test is, when the test is completed, before the test environment is destroyed, these logs are taken out of the VM and uploaded into an external storage. So we thought we had this distance data, and we thought this would be the ideal point for us to start working with machine learning, because distance data is numerical data. So it's in a shape that is already almost suitable for applying to a machine learning model. And we wanted to verify if load was creating us issues. Also, something that we considered is that this data is not OpenStack specific. So the same methodology that we were going to work on could possibly be applied to other different systems in the future by collecting the same type of distance data. Because of the amount of changes that happen in the CI system and the amount of logs that are generated, it is not possible for the OpenStack community to store so many CI logs over time, so they are rotated quickly. And we soon realized that the amount of logs available on the log server at any point in time was quite not enough for us to run a good training of our machine learning model. So we started collecting logs and storing in our own storage. The way we did it, we wrote a function, which is part of what we call the CML project. So CI, machine learning for CI, CI/ML, which we call CML. And what this function does, we containerize this function and we run it as a periodic action in OpenWhisk, which is a serverless platform. And what this function does, it collects the new logs from the OpenStack CI log servers. It performs an initial validation just to make sure we're not storing data that is not valid. And then it stores the raw data in a object storage in the cloud, so cloud bucket. So that was the raw data stored in a bucket. So even though the data is numeric, there is still some preparation that we had to do. So first of all, we wanted to visualize the data. So we started looking at the data, visualizing the different metrics from the system. So how the graph for the disk I/O or the network I/O or the memory or CPU utilization looked like. Several of these graphs already could be said to be heavily correlated, so they have similar shapes. So we didn't want to use all of them to train our models, because it would just be extra data that provides no value. So we wanted to be able to select and filter the data. For that, because the experiment with the caching worked quite well, so we took a similar approach. We wrote a new CML function, which takes the raw data from the bucket in the cloud, applies filtering and normalization, and stores the resulting data pre-normalized, ready to be fed into the training, into a different bucket in the cloud, so into different object storage. So one thing that was important when defining this function that we realized is that we needed the function to behave in a consistent way and reproducible. It's very important for us that the creation of our data sets was reproducible, so that if we had to recreate the data sets, we could then run the experiment and then have the same results again. Just to give a better understanding of what's going on, here is an example of what the DIStat data looks like. So this is a very small table on the right side. So the DIStat data, in fact, will be much larger, but you can get an idea of what is going on from here. So the columns are the different features or the different metrics on the operating system. USR stands for the user CPU utilization. Used refers to memory, and then we have disk I/O. 1M is the system average load, average over a minute. It's a metric that is exposed by Linux operating systems. And so there are 20 or more of these columns. And rows are samples at different time intervals. So you may be able to read there that we are collecting data every second. But we thought that this was too much resolution. It would be too computationally heavy. So we decided to downsample our data to different time intervals. In creating the data set, there's something else that we had to care for, which is general data cleanup. One may imagine that data is perfect and always clean and as you expect it to be, but in fact, you often find that for some reason, a metric could not be recorded at a certain point in time. So you find holes in the data, so you have to be careful and catch things like not a number and so, which might break your training. So if you look at the crossing of the lines with the columns here, you see there are 6 numbers that we are taking in this specific case. And what we did for these 6 numbers, we unrolled them into a vector, a one-dimensional vector. So on the left side, you see now 3 vectors, starting from USR1 to 1M3. Each of these vector with 6 numbers represent one CI job that was executed. In fact, this is just an example to make it fit on the slides. In reality, because CI jobs run for more than 1 hour, even with a downsampling to 1 minute or so, we usually had a number of features between maybe 150 and 200. And the final step we did was for normalization after the unrolling is the normalization. So you can see on the left side numbers have different values depending on the metric that is being recorded. We wanted all of our numbers to be between -1 and +1. So we applied a standard normalization function there. This just makes computation much less heavy. So it makes it easier to run faster. So to summarize, for a function to build a data set, that filtering normalization, but it also split our data in 3 groups. So training, dev, and test. The training we use for training our models, the test we use for the evaluation phase, and the dev for the fine-tuning. The data set, once it's produced and normalized, also stored on object storage. We use the S3 protocol, but it can be on any cloud. We also defined input functions for training and evaluation. So the input functions takes the data from the data set and it splits it into batches and epochs for the model to training to consume. So we had the data here, but we wanted to bring this data into actually training the models. So the next steps that we had to do was define the hyperparameter for our experiments and then actually run the training. So again, we followed the same type of approach. We wrote 2 functions. the CML setup experiment and the CML train model, which respectively are responsible for defining an experiment and running the training. All these functions have the great advantage that can be easily executed, Dockerized or containerized, executed in a container, which means that because they're also able to work with object storage, they're easy to run in the cloud, which is particularly important for things like caching the data that we want to do on a regular basis, but also for running the training, which is still computationally heavy, and we want to run many of them. So we want to be able to distribute those trainings into different kind of infrastructure. So talking about the training infrastructure, we wrote this wrapper, as I was mentioning, in CML. The wrapper, one of the reason of having this wrapper, apart from easiness of containerizing it and running it, was that we wanted to be able to interchange the machine learning framework behind the scenes. So we wanted to have like a single interface for running a training that behind the scene could work with TensorFlow Estimators API, which we did most cases, but we also used things like Keras or scikit-learn for different type of trainings. So we wanted to have a common interface for that. In terms of training infrastructure, initially we ran our trainings on our local laptops and machines using local storage, the disk. It is possible to run CML from a Jupyter notebook that we did in many cases as well. And then once we were ready to start, we had many data sets and many experiments defined, and we wanted to run all of them across many days. We started using a tool called Fiddle, which works on top of Kubernetes and helps you schedule jobs, which are training of models on top of Kubernetes cluster. After a while, we switched back to a different approach because we wanted to have the minimum possible footprint in terms of training infrastructure. So we wanted to focus the utilization of our resources on the training itself and not consume cloud resources in complex tasks of scheduling or tracking metadata. So we wrote a few tasks and pipelines in Tecton, which is a cloud-native pipeline controller, which allows you to define tasks and pipelines to be executed on top of Kubernetes. So with these tasks and pipelines, we could run our trainings on top of Kubernetes cluster. So initially, we provisioned a few bare metal nodes, and we provisioned our Kubernetes cluster on top of these bare metal nodes with GPU cards in them. We did a few tests, and we realized that, in fact, GPUs were not bringing a significant difference to the table in terms of performance for running our trainings. This has to do probably with the fact that we are running DNN. So we switched back to provisioning our Kubernetes clusters on top of regular VMs, basically. Yeah. So there are other systems that would do similar jobs like Kubeflow pipelines, but again, we wanted to keep the footprint as small as possible for a type of project. We didn't need a large system. So finally, in terms of predictions, so once we had our trained models, how to make predictions from the model, we wrote a small, a simple Flask-based API that exposes prediction for every synchronous response from the trained model and a Helm chart to deploy that. But also we wanted to support a more asynchronous type of workflow because it turns out that the OpenStack CI system is able to generate events every time a CI job is complete or it starts. But interesting for us when it was completed. So through a system called OpenStack Firehose, using a protocol called MQTT, a client may subscribe to events and be notified every time a CI job is complete. So our MQTT client listens for such events And whenever the job is complete, it goes onto the log server, downloads the new data, the stat data, applies the normalization functions on the fly, so it creates, it normalizes the data from it, and then it runs a prediction. So the prediction can be generated this way, can be used to provide more context to the developer who made the change to OpenStack, or to the engineer that is going to triage an eventual failure in the CI system, because it can provide more context or information coming from the prediction that was done from the training. The way this could be implemented, for instance, is to push back a comment onto Garrett on GitHub saying what was the result of the prediction. So yeah. One last thing that we thought it might be possible to do is what we call continuous training, because we consider the CI system as a trusted source of data. So we can take new data from the OpenStack CI system and use it to continuously train the model and decide when we want to switch to new model trained with more data. So next for the experiment.
So, hello everyone. So with the workflow and the infrastructure in place, as Andrea explained, we plan for a series of experiments to find insights using machine learning on this available distant data. The first set of experiments we ran were supervised learning on binary classification. Our aim here was to train a model that could predict accurately if whether a CI job was passed or failed. So for this, we use a classic deep neural network classifier, and our dataset was based on one specific CI job called Tempestful, which is a CI job that is quite popular in the OpenStack integration. And as Andrea explained before, we were using data coming from the gate pipeline only because this data was less noisy. As hyperparameters for our model, we were using a ReLU activation function, sigmoid as an output layer function, which is quite handy for classification problems. We went for the AdaGrad optimizer, which is self-adapting. We started with an initial learning rate of 0.05, and as we can see in the figure, our network topology contained 5 hidden layers, and in each layer we had 100 units. So our primary metric was accuracy. We were also having a look at the loss. And first of all, we wanted to evaluate if there was one feature or a combination of features that could provide the best accuracy for this binary classification problem. And so in our original data set, we had user CPU, use memory, and average system load as features. And we started with a data resolution of 1 minute and found that, as we can see in the figure up above, there we are displaying 1 minus accuracy for visualization purposes. We can see there that the best accuracy was achieved for the feature combination of user CPU and system load. And we got a pretty high accuracy value. Nonetheless, we wanted to see if a better value could be achieved fine-tuning. So we ran the experiment with this good combination of features, but now changing the data sampling, the data resolution, ranging from 10 seconds to 10 minutes. And it was unsurprisingly, but with the data resolution of 10 seconds, the accuracy was better, but the difference was really tiny. So we had a look at the metrics to see if maybe in the precision recall or the F1 score, which is the weighted average of precision and recall, we could find some insights if there was a significant difference to justify having the data resolution of 10 seconds. But the values were very similar, so we decided to keep our model with a data resolution of 1 minute because it was less computationally costly. One important point we wanted to evaluate during this set of experiments was whether the trained model, besides predicting if the CI job was pass or fail, was portable. So what we did is we took the trained model and we evaluated with another data set based on a CI job called TempestFall PI3, which is very similar to the TempestFall CI job, but it uses Python 3 and it has one less component. And we found that the metrics were pretty good, not as good as the ones obtained with the TempestFall dataset, but high enough to say that the model is portable to similar CI jobs. So this one was one of the main findings from this first set of experiments. Another important point we found was that with our estimator, the model was providing the prediction, so whether the CI job was fail or pass, but it was also providing a prediction confidence. And this value might be quite useful, especially for CI operators, because if this prediction confidence starts to degrade or degenerate, it could be used as an early warning system to flag that something is overloading or is starting to fail in the system. So this was a very cool finding from this first set of experiments. Our second set of experiments was using supervised learning again, but now on a multiple classification problem, where our classes are the hosting cloud providers, which are the cloud operators providing the virtual machines to run the CI jobs. In our data set, we had initially 10 classes, and we use again TempestFall as CI job and data coming from the gate pipeline. Initially, we had the model with the same hyperparameters as the model we trained in the previous experiment. And we ran the evaluation and found that the accuracy was not good. So following the same approach we did before, we first tried to find if there was a feature or a combination of features that could provide a better value, but it wasn't the case. So we tried then changing the data resolution, again, ranges from 10 seconds to 10 minutes. And there was a slight improvement, but not significant. So as a third step, we changed the network topology. We tried the test with more complex and less complex network topology, but still no real improvement was achieved. So at this point, we thought there is something in the data that is not good for the classification model to be able to distinguish among classes. So we went back to the data and found that there were some classes that were the same cloud provider, but in different regions. So we decided to reduce those classes to one. So that means one cloud provider in several regions was considered as just one class. And with this reduction, we passed from 10 classes to 6 classes. And then we ran again the process I just described before. And in the first experiment already, the accuracy was significantly better. So that was a trick that helped us start in predicting in a more accurate way. And again, we tried to fine tune, and we found that using a less complex network topology, the accuracy improved. So having a look at the metrics for this trained model, we found that for those cloud providers with more samples in the dataset, the metrics were high and good. And when we ran this experiment, there was a new cloud provider with very little samples in the dataset, and for this, of course, the metrics were very poorly. So this gave us the inspiration to try if a model using unsupervised learning will be able to cluster and group all these cloud providers with a higher support in the dataset, with a higher amount of samples in the dataset. So for running this clustering experiment, we use the basic data set with the combination of features, user CPU and system average load, and the resolution of 1 minute. As algorithm, we used k-means, which is the most popular clustering algorithm. And our expectation was that it will make sense to have a number of clusters that will be the same as the number of cloud providers with the highest number of samples in the dataset. So they were between 3 or 4. But we wanted to validate these assumptions, so we ran the elbow method, and we also calculated the silhouette coefficients. And the recommendation there was to have between 3 to 4 clusters. So those were the 2 experiments we ran. And we found that for the experiment with 3 clusters, the one cluster was containing 2 of the main cloud providers. So it was not significant for our purposes. But in the experiment with the 4 clusters, each cluster had one of the cloud providers with the higher support in the dataset. And there was one cluster that had very little noise. So over 90% of the samples in that cluster were belonging to the same cloud provider. So that means this cloud provider had some features in the distant data that were quite distinguishable for the model to separate and group them. So in summary, from these multi-class experiments, we found that reducing the amount of classes helped to improve accuracy. Our explanation is that cloud providers tend to use similar hardware layout across regions. So from this point of view, it makes sense to reduce the classes, and it helps us to achieve a better accuracy. And we also try to see if this model was portable to similar CI jobs as we did with the binary classification, but unfortunately the results were not good. We found as we saw that clustering has huge potential in this data, and that higher support helps for better clustering. So in general, at the beginning of the project, we had the suspicion that that many of these failures coming on the gate pipeline were due to system load. And with our experiments, we could verify this suspicion, and we could also predict with good accuracy those failures having only system data. For those failures that are outliers that could not be predicted by our model, it's likely that the cause is not system load related, and knowing this alone is very helpful for engineering to triage failures and further investigate. So we saw also that clustering and unsupervised learning has a potential with this data. And this is important because doing classification of single failures could be a lot of effort from the engineering point of view. And if we have a model that could do a first approach with little effort for the engineers, that could be a good and a huge help for the triage of further investigation of these failures. As a project, so we found that it was really important and crucial to start collecting data since the beginning, especially because we had open data, and it was also crucial to have a cloud infrastructure and a workflow that could allow us to work and contribute from remote. We were all working from different regions and time zones, and it was also very helpful to have infrastructure to train on the cloud. So it was, as we could see during the multi-class experiments, it was important to have knowledge domain, and otherwise we could have not moved forward during those experiments. And we were quite open about using machine learning tools. So we didn't stick to a framework. We were using for some of them TensorFlow, and for the others, scikit-learn and so forth. So as future work, we started exploring the interpretability of our binary and multiple classification models. We saw already that for binary models, there are some time frames where there is huge contribution to the prediction. So this is a topic we want to further explore. Another interesting point to expand will be to extend the dataset and include some more information from the system and application logs, and maybe use NLP to further classify the failures. And as mentioned before, exploring the clustering of failures has a huge potential. And another topic we would like to explore more is the CI job portability, which works for the binary classification model, but not for the multiple classification model. Okay, so this talk and all our code are available in GitHub in these links. We will also share them in Slack. And we're here open for questions. And if in the future you have questions or you want to contact us, we are available for you. So thank you very much for being here and listening us in this virtual talk. And thank you to Jnation for inviting us.
All right, thank you very much. So maybe just a couple of quick questions before we finish this session. So actually, I have one question that I really like to ask when people talk to me about experiments that they run, especially that they're so extensive. What do you think are the biggest? What were the biggest difficulties that you would say you would have while running the experiments, and what were the biggest blocker that took really a long time to get through?
So the beginning, the data, deciding what was useful in the data, and for me, this topic was quite new, OpenStack and CI integration. So it was crucial to have Andrea and Matthew giving their insights and their knowledge domain. So I think that was the biggest hurdle to overcome at the beginning. And then when we were training, when the results weren't good, that was again the crucial point that helped to move forward, knowing your data.
Yeah, I think that's the biggest thing. It's either there's a lot of data, but then you don't know how to like it, but it's not labeled, or then you don't have enough data. It's usually how it goes. All right. And how do you what do you see the impact of using this approach? So you've talked a lot about the future work and you have, and let's say that you managed to actually accomplish those things in 2-3 years. What impact do you see from this?
Well, the idea was that we would be able to use this approach in production in OpenStack. I mean, since we started working on this, both Matt and myself and here too, we changed jobs, so we are not focusing on OpenStack anymore. But the idea is really like I showed in the prediction pipeline, to have like near real-time insight from these models. It could be published directly to the developers to give better insight of what is going on. So both as a reviewer or as a developer and as a maintainer of CI system, I've seen people often get frustrated if there is a lot of load on the CI system and your tests are failing, not because you did something wrong in your code, but just because maybe there is too much load in the test node or some transient failure in the CI system. And if you can put there a message saying, look, sorry it failed, but it was not because of your code, so feel free to rerun the test. That would really helpful. So that's kind of the direction we're trying to go towards.
Oh, that sounds really amazing. I think that could improve the lives of a lot of developers. All right, guys. Well, thank you very much for your time, and thank you for taking your time also to coming up and showing your presentation, sharing your knowledge. I think it was useful for everyone. And yeah, this talk will be available later on also online for anyone who just jumped in the middle. And again, big thank you for anyone who joined, and see you in around 15 minutes. Bye, guys.
Thank you, Leon.
Bye.
Bye. Thank you, everyone.
All right, hello and welcome to yet another session here at Jnation 2020 online version. My name is Leon and I will be hosting this session for you. Well, thank you first of all for following us today throughout the whole day, and again to all sponsors who are still sponsoring this online edition, and especially a big thanks to the person who we are here to see and hear, which is Alex Soto. Hi, Alex. You're joining us from Barcelona, is that right?
Yeah, that's right. Hello, and thank you very much for making this great event.
How are you doing today?
Good. I mean that it's adapting to the new life, right?
Yeah.
Doing sessions online, something
going
new.
To conferences online, right? Working online.
But I'm used to do this kind of sessions nowadays.
Yeah. So Alex is going to talk about chaos engineering in Kubernetes. But just before we start, and yet another reminder, you can always ask any question that you want either in the room Slack or on YouTube where you're following us. And yeah, feel free also to react on any of those questions or comments. Alex, the floor is yours, or this virtual floor, I guess. Good luck.
Thank you very much. Okay, so probably if you're a developer, you don't want to wake up at 3 a.m. because of a failure in your application, right? So if you don't want to happens this to you, then this talk is for you. Thank you very much for joining this session about chaos engineering in Kubernetes. It's a pleasure to be here with all of you. And please, as a reminder again, if you have any question, please do it, because I will be very happy to answer it. My name is Alex Soto. I work in Red Hat. I'm author of several books and cheat sheets and so on. And when I do this kind of talks, I do talks about testing in production or chaos engineering. Some people tell me after the sessions that, look, this thing that you're saying, it's right, but it's totally stupid, or it's totally useless, or it's impossible that my manager will allow me to do that things, right? And probably you are right, but when you are starting doing true microservices architecture, and when I say true microservices architecture, I mean like 100 microservices, 150 microservices, not just 3 or 4, then this talk is really useful. So a monolith, everyone knows exactly how it looks like, right? It's a monolith. It contains some kind of modules inside the monolith, because at the end you have a design on your monolith and you have some kind of modules, and each of these modules has some components inside, right? But maybe it was like 3, 4, 5 years ago that we decided that it could be a good idea to break down all these monolith and create some kind of microservices. So we just pick it up all these modules, all these components, and make it a service on their own, right? So we start splitting them out and connecting all of them using the network. So you can say that we are really using into a service mesh. We've got this is we've got a graph. It's not a tree structure. It's a graph structure with several communication between services, and these things makes our architecture more interesting. And of course, everyone here said, yeah, microservices. You need to move to microservices. It's the really best thing you have ever seen. So all industry just pushes up us to move to microservices architecture. But microservice architecture has also some drawbacks. And let me explain you one. This is my microservices architecture. And now what's happened if there is a downtime in the middle of the mesh? There is one service that is failing. Well, basically what is happening is that all the services that are depending on these services specifically, and all the transitive services are failing as well. And this is what it's called temporal coupling, right? Because when we read about microservices, all of us says, yeah, microservices is about isolation. And notice that it's true that each of these microservices are isolated until one fails. When one microservice fails, then there is a cascade of failures. And now think about from the point of view of testing, how you can, if you only have one service, it's predictable what's going to happen when this service fails. But now that we've got a combination of services, a combination of failures, it's almost impossible to know exactly how our system is going to behave. We can think like, okay, one service is failing, right? But I can try to figure out what's happening when this specific service is failing, but then what's happening with all other services? Can I predict how they are going to behave? Probably not. And this is why it's really important, this new concept, which is called testing in production. And basically, if we want to start doing testing in production, it requires a change on the mindset, an appetite of risk, right? Because, you are testing in your production cluster. So you need to, see what's happening if something goes wrong, right? And also you need to start thinking that the way you are coding needs to be changed to this fact. So now when we code, we need to change our way of thinking and start coding, having the failure in mind instead of the success, right? Some people think that testing in production is something that you do on the wild, and it's not like that, right? And we are going to see right now why. But one of the nice concepts that has come with testing in production is that deploy is different than release, right? In the past, in the monolith architecture, doing a deploy or doing a release was more or less the same, right? Where you could say, I'm going to deploy to production or I'm going to release to production. It was pretty much the same concept, the same process. But now with microservices and testing in production, deploy is one thing and release is another thing. Deploy is taking your service and put it on production. So you are effectively deploying the service inside production. But then there is the process of release. And the process of release is start sending public traffic to this new service. So you can deploy to production, test this new service in production, but you are not sending public traffic to this pod. So if there is any failure, then it's not a really big issue. But then when you are pretty sure that the service is behaving as expected, then you start the release process, which is starting sending public traffic to it. So this is it's really important to have into consideration. Then most of you already knows probably that testing pyramid, right? That when we've got unit test, component test, and end-to-end test. But now with microservices and testing in production, this has changed a bit. And maybe I like to call this, if this is the new pyramid, right? Notice that I've got like 4 columns, and the 4 columns, the blue one, it's a pre-production testing, right? It's tests that run before we go to production. For example, unit test, component test, coverage test, benchmark test, contract test, acceptance test, penetration test, smoke test, all this kind of tests happens before we go to production. Usually these tests are tests that are run in your continuous integration, continuous delivery deployment. Probably the developers are able to run all of them from his own computer or in some way. But then we've got the second group of columns, which is the testing in production. That is this orange line, which says that all these columns are for testing in production. And in testing in production, that is that I split into 3 columns. One which is green, and the green part is those tests that you're running when you deploy something in your production cluster, but you are not sending public traffic, right? In this category, we can say that there are integration tests, tab compare, load test, shadowing, or config tests, right? Some people ask me, but why you are putting integration tests in the deploy phase? And the reason is that running integration tests, and we can think like integration tests like service to database communication, are done in pre-production with an empty database, with an in-memory database. So it has not much sense, right? Because there is no network, there is no failures on, for example, the network. The weight of data probably is different, right? The one that you have in production than the one you have on your pre-production or your staging environment. So when it has really sense to run integration tests is with deploy phase against the real database or against the real services. Then when you are really sure about deploy, that deploy has been done correctly and what is deployed, it's correct, it's behaving as expected. Then we move to the release column. This is another test. For example, canary releasing, dark canaries, monitoring, future flagging, exception tracking, future graduation. All these testing methodologies are in the release column. This probably most of you knows exactly what is a canary release, right? Or a blue-green release, right? These are tests that are run during the release phase. But now, with testing in production and microservices, there is another column, which is the post-release. This is other tests that we are running all the time. Notice that if you think about monolith, right, in how we work in the past, we can think that the tests finish when our product goes to production. So when we deploy the service to production, then we said, okay, now testing is over, and I'm going to start testing the next version of the service. But now with microservices and testing in production, testing is also happening after the release. And this is what it's called the post-release phase, where some techniques you can think is like tagging, profiling, logs, chaos testing or chaos engineering. Okay, now we face what we are going to talk today. It's a post-release technique. Monitoring, A/B testing, tracing, auditing, on-call experience, or journey test. All these tests happen when we are already having public traffic reaching our service. Of course, I know that you've seen a lot of probably new words, new test methodologies. I know, and you don't need to start at once doing all of them. Just pick up some and start applying these techniques with the easiest services, for example, stateless services, or for example, services that has a lot of reads but not a lot of writes, things like that, and start step by step moving towards testing in production. But of course, let's talk about chaos engineering and chaos testing, because at the end, this is what we want to talk about, or why you have come here. So what is chaos engineering? Okay, chaos engineering is injecting failures in your system on purpose to see how it behaves under these circumstances. Because at the end, you don't choose the moment when the failure happens. The moment chooses you, right? You only choose how prepared you are when it does. When there are failures, and you need to be prepared for them. So you can say, okay, I'm not going to do anything, and just when it happens, then I will react. And maybe it's 3 a.m. That's fine. If you're fine with this approach, then it's fine. But maybe you could try to anticipate what's going to happen, and if the response of your system under an error is the one that you wanted or you expected or not. So everything will eventually fail over time. I mean, that maybe it's a software network, maybe it's a software bug, maybe it's a problem in the network, or maybe it's a problem on S3, right? Because you remember maybe 2 or 3 years ago that probably most of the people said, yeah, Amazon S3 will never go down. Never. This is not going to happen. And then it happened, and half of the sites were down, right? So this, probably most of you remember these days without kind of the access to most of the sites because of the S3 down. So the ultimate goal of chaos testing, chaos engineering, is to maintain the application running even in case of failures. You can ignore this and say, it doesn't matter. I'm going, to just continue doing in the ways I'm working nowadays. Or you can start thinking about it and provide some fallbacks in case of errors. So the thing is that you need to move your mindset, and instead of assuming that there are no breakdowns, you need to move to a model where breakdowns were considered to be inevitable, right? So you need to build resiliency in your system. You need to think all the time, what's happened if if the cache is behaving incorrectly? What's happened if how your system behaves? Maybe you want to do it at 1 p.m. when all the engineers are on site working on the problem. You choose the moment. The moment doesn't choose you. And of course, that I know that might sound scary, right? Than saying, okay, you're telling me that I need to bring my application, right, on production. How do you want I sell this to my manager? Because, you know, no manager will never allows me to do these kind of things. And that's true. But the problem is that you have not explained it correctly what is about chaos engineering, chaos testing. Because what is important with chaos engineering is that you want to build your application more resilient. So chaos engineering is about resilience. It's not about breaking things, right? Because if you sell to your our application more resilient, no, it's not going to happen. Everyone wants his application be more error prone, more resilient, right? More able to work even in difficult circumstances, right? So think about this. Chaos engineering is about resiliency. It's not about chaos. But even if you test an exam, write a test, a chaos test, and then you run it, and then it causes some problem, see that in reality it's not causing any problem. Then this is the problem that you're going to find it. So it's up to you to fix it or not. So what are the phases of chaos? So because I'm talking about exactly what is chaos engineering, right? Injecting problems on your production cluster and see what's happening. This helps us to develop better programs because, you know, if we run experiments, then we can see where our services are not really when it's not really good, when they are having some problems, and then we can act and fix those problems before it happens in the real time. But to do that, we need to make some order, right? And this order is like these phases. We've got a steady state, we've got the hypothesis phase, the run phase, the validated phase, and the fixed phase. Okay, then a steady state. What is a steady state? Well, at the end, a steady state is just defining some outputs that defines that your system is behaving as expected, right? I mean that sometimes these outputs can be that there are no 500 errors, no 400 errors. All my services are returning 200 HTTP codes, but sometimes there are other. For example, performance, right? You are checking that all the services are performing well. There are no services that, because of some problems, they start outperforming, right? They start working really, really slow. Okay, but also there could be business metrics that are specific to the business. And in this case, let me show you this graph. This is from Netflix. This is the number of plays that that users do on the Netflix app. Notice that there is some kind of oscillation, right? Probably here is like, I don't know, after dinner. Then after dinner you go to sleep. Everyone is going to sleep. Then you wake up, you start working, and then after the work you start watching a bit of Netflix, right? And then after the dinner, everyone watch any series, and again it's repeating, right? This is a real traffic. And then what's happening if when Netflix does some chaos engineering? What's happening is that they are comparing the behavior of this graph between his system with chaos and without chaos. The red one is with chaos, the black one is without chaos. And notice that the form of the graph is the shape of the graph is exactly the same, or more or less the same. So this means that the application is behaving correctly, right? They are introducing cows, and the application from the point of view of business still behaves in the same way. If you see here some changes, then it means that you've introduced the cows and there are something that is not behaving correctly, right? So for this reason, it's really important to define a correct steady phase, right? A steady state. We need to know when the service is working correctly. Then there is the hypothesis. It's when you ask what happened in case of one service started returning error codes. Latency is increased to 500 milliseconds. The database is not available. Time travel. These are really interesting cases. What's happening if someone changes the time clock or the clock of your service? What's happening with your application? Have you ever tried it? I think it's worth to try it and see what's happening, right? Because this could happen. Or what's happening if I partially delete a Kafka topic? It's recovered? Not? Well, this is something that you need to see. Then you need to run the experiments, right? So you've started an hypothesis saying, what's happened if my service, whatever, my service, account service, start behaving incorrectly and returning 500 errors. What's happened with the calls of this service? Okay, then you need to run this experiment. Of course, what is important about an experiment is to containerize the experiment. When I'm saying containerize, I'm not saying putting inside Docker, right? I'm saying to reduce the blast of the chaos. So, for example, you can just use a canary release and saying, I'm going to send the 90% of the traffic to a pod, because we are, for example, in Kubernetes, which is behaving correctly, and then I'm sending 10% of the traffic to a pod, then now it's behaving incorrectly. I mean, it's the same version maybe, but one is starting to send randomly 500 error code. Or you can use it your canaries. So instead of doing it by 90% or 10%, you can say all the traffic goes to the version v1, but if the traffic comes from this range of IPs, or I don't know, a header within a specific flag, then the traffic is rerouted to this new version. What is important to do when you run an experiment is define the expected behavior. And the expected behavior is not that the system is going to work as expected, because obviously, depending on the cows, the system cannot continue running in the same way. The thing is that it should continue working, right? And I always like to show the this example of Netflix. If you have Netflix, you know that at the bottom or at the top of the UI, you see that this something like these movies are recommended for you, or they are special for you, right? So they have some kind of service that they are doing some kind of artificial intelligence thing, trying to figure out what might like you. But what's happening if this service is down? Then in these cases, what it's doing Netflix is just going to the top of the most viewed things. So instead of finding things that are the best for you, they just go to the most played movies and they say, hey, probably you like, or you might find interesting all these movies. So of course, the system is not exactly the same, right? Because in one, they are using the artificial intelligence service, so the results are more accurate. But since the service is down, then they have a fallback, which is like, okay, I'm going to show you all the movies that most of the people likes. And this is the expected behavior that you need to define to make this experiment successful. And of course, make it public within the organization. It's really important that everyone knows exactly when a cow's test is going to be run. Because it's important that the operations guys don't become crazy, because someday, without any reason, they start seeing that some pods are dying randomly. And it's like, okay, what's happening with these pods? They are dying. Why? Right? It's like everything is behaving correctly, but I'm just seeing that some pods are terminating abruptly, and I don't know why, right? So it's important to make it public and communicate to the ops team, saying, be aware, because between this time or this range of hours, you will see some pods that are dying randomly. So be aware. So I think that this is really important. The next thing is that, okay, I've run the experiment, and now it's time to compare the results between the current state and the steady state. So maybe it's time to validate if the experiment has break something or not. Maybe it has not broken anything. Everything is in a steady state, as we've seen before in the case of Netflix. They see that the play frequency is exactly the same as before the cows. Then that's fine. If not, it's time to identify the problems. So I said, okay, it seems that we break something and it's not behaving as we expected. So we need to fix it. Okay, then you identify these problems. And what is more important is recover the system to the steady state, right? So we need to draw back all the cows and make the system work as before the experiment. Then after the validate, it can happen that it's time to fix the problem, right? If it works, if the experiment works as expected, it meets the expectations, then you are good. If not, the first thing is like not to blame anyone, right? Because then if you run an experiment and you've broken all the cluster, probably they will start finding who was the responsible of, or who has the brilliant idea of doing chaos engineering. You, because of you, all these things has been broken. Or maybe we'll find the tester who wrote the test and said, hey, why you wrote this test? This test, it was really a disaster. Or maybe they will find the developer and say, developer, how the hell you've introduced this bug, right? Because of this bug that has been, seen because of this chaos engineering test, now we have lost all these tons of dollars, right? No blame. What you need to do is just check what's happening, why happened, and then escalate, because maybe the problem is really it's a really important problem. So it's like, oh, we never figured out what's happening if the database is down. Now we've tried it, and whoa, we've got a really serious problem. So maybe you need to escalate to prioritize and start developing a fix for that. Or maybe it's a problem that it's unlikely that it happens, or it's not really important. And then you say, okay, we have identified that there is this problem, and let's put it in our backlog and let's fix it when we have time. So why is Kubernetes important in all this chaos engineering and resiliency stuff? And it's important because Kubernetes has some kind of techniques that helps you make your services or your application more resilient. And we're going to see it in the demo sooner. But of course, if you want even more powerful things, more resiliency things, then you should use Kubernetes plus Istio. I don't know if you know what is Istio. Istio is a service mesh, and a service mesh is a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. So if you're wondering how it works, it was in this way. So we've got one pod with one container, okay, and then the service mesh, it just intercepts the traffic and manipulates the traffic. So instead of doing a direct connection between service A and service B, what you are doing is just doing a connection between service A, the service mesh, for example, in this case, an Istio proxy. This Istio proxy then does the request to service B. In fact, it's not service B, it's in case of Istio, the service mesh proxy of service B, and then this service proxy just do the a request to service B, and the same for service C. So basically, you can think like a service mesh is like a interceptor of traffic, so we can manipulate this traffic for implementing some functionalities that helps us to make our services more resilient. For example, what we can do with Istio is do automatic retries. Suppose that you are sending a request and then there is an error. Probably if you do a retry, then it will work as expected. So you can use Istio to make these retries make it occurs automatically. So you do not need to code anything. You just do your request in your code, and then Istio will take care of this for you. And if it detects an error, then a retry is going to happen. The same for bulk ahead pattern, circuit break pattern, pull ejection, or request timeout. All these patterns that comes from resiliency, probably most of you are already using some of them. If you're into the Java system, then probably you're using Strix or resiliency for J to make these things happen. Then all these stuff, all these functionalities, all these features are moved from this library into a Istio proxy. So you do not need to take care of anything. And the other thing that we can do with Istio is inject some failures if you wish, right? But let me introduce you another, for example, if you want to use it with Istio, you want to introduce one fault injection, you can do it with this. You just create a Kubernetes resource, which is of type virtual service. You set which host you want to add the failure. So you said in the rating service, and I want to abort. So it's like, okay, I want to add a 500 return error for all the requests that happens to ratings. So any request that happens to ratings, it will return a 500. But notice that here, what I'm saying is adding a new header, which is called end user, and it said exact Alex. So I'm containerizing the experiment, and I'm saying I just want to return 500 error when someone sends a request to rating service, and this someone has a header with a key end user and a value Alex. So when Alex is doing a request to ratings, then a 500 error code is going to be get back, right? And then you can do just skip cut all apply minus F failure, and then this is going to happen. But of course, notice that you are missing something here, right? Because here you are just injecting the failure, but we are skipping all the phases of chaos engineering, like for example, defining a steady state, run the experiment, define the hypothesis, and so on. And for this reason, I really like Chaos Toolkit. Chaos Toolkit is a toolkit which basically not just works with Kubernetes, but also for Amazon or for Google Cloud or for several drivers. For this reason, I'm just introducing you here Chaos Toolkit. We are going to see in the last slide more specific Chaos engineering tools for Kubernetes, but this one adapts to Kubernetes, but also to other platforms. So you basically do these kind of things, which you define a JSON file where you define the steady state. So you define when my application is working correctly, and I'm just saying, okay, my application is working correctly if all my pods are available and healthy. So if my greetings pod is available and healthy, then my application is behaving correctly. Then I need to define the experiment. What's happened if I stop a pod, if I kill a pod, right? Then this is what I'm doing here. I'm just saying, I want to terminate the pods. You see here that I'm terminating the pod. And I want to terminate all the pods which are with a label called spilo role equal master, and the pattern of the pod is greeting DB, right? So I'm just killing the database pod. And then I can even do a pause of 2. And finally, I want to verify that the experiment, when I kill the DB, it's working as expected. I'm just saying that the proof is that application must respond. This application must respond is a reference to the steady state, right? So I'm just saying that my application is steady. And then, of course, you can, for example, in this case, log all the information. And finally, you need to define a rollback section saying, if the experiment is not working correctly, I need to remember to do a rollback and apply some countermeasures so my cluster I'll get it back to a steady state, and a state which we can serve requests again as expected. And we just run with cows run experiment. And of course, you can, for example, use in case of you're using Amazon and not Kubernetes, you can do things like a stop NAC2 region. You say, I want to stop the US West 1 region, and then you run this, and then this region will just be stopped. And then you can validate what's happening. As I said, there are a lot of other specific chaos engineering tools. There's GlueShot, Powerful Seal, Chaos, Toolkit, Litmus, Pumbaa, Cube Invaders, and Chaos Mesh. And if you are specific to Kubernetes, I recommend Chaos Mesh. I think that it's the most completed, most focused to Kubernetes. Litmus is also really well. And if you're not into Kubernetes, or you are into Kubernetes and other things, like for example, Amazon or Google Cloud and so on, then I recommend you to go to Chaos Toolkit. And let's see it in a quick demo. I've got here my cluster. Let me do, for example, get nodes. Okay, so you can see that in my case, I've got 3 master nodes and 6 worker nodes. Okay, and I've got here my application. Here I do kubectl get pods. You can see my application, which basically is a consumer that calls to a provider. And basically what's happening is that consumer calls provider and provider returns a message. In this case, it returns hello. I can do a call to the service and notice that it returns hello. It returns hello because the request is sent to the consumer. This consumer makes a request to the provider returns hello, and then the hello is sent back from the consumer to the caller, right? So for that reason, you can do a call and I get it hello. Now, if you see my experiment, which is here, you can do a bad chaos with bad experiment pod termination. Oops. Pod termination. Okay, probably you cannot see anything. Let me do it with a cat. Okay, notice that what I'm doing here is just saying my service is in a steady state when the service returns a 200. Okay, then I want to terminate a pod, and this pod, the pod that I'm terminating is the one which is my provider APP. So I'm just killing this pod, and then what I want to check is that my application still responds. So I just do a request to the service, and it still returns a 200. Then, if you see that I do a kubectl get pods, you see that I only have 1 provider instance. So obviously, if I kill this instance, then you will receive no request. So I can do chaos run experiment pod termination. Okay, and notice what's going to happen is like critical steady state proof is not in the given tolerance, so it's failing, right? Notice that this pod, the provider, was started 6 hours ago, and now if I do kubectl get pod, you see that has been started 15 seconds ago. So it effectively killed this pod, then it ran the test to check if the service is behaving correctly or not. And obviously it says no, because there is no provider, so it returns a 500, which is different of 200. So I've detected, right, that my system is going to fail if the provider service is down, right? How could I fix this? Okay, I could do, for example, kubectl scale deployment replica 2. So I'm just creating 2 replicas. And notice how easy it is to create replicas, more instances of my services with Kubernetes. Notice that I'm just doing kubectl, now get pods, and you'll see that I have 2 instances of my provider. This is my provider, and this another my provider, and one my consumer, right? And notice that I've not done anything special. I've just said kubectl scale. And this is the great things about Kubernetes. For this reason, I said that Kubernetes helps you on making your application more resilient, because with just running one command, boom, Kubernetes finds a worker node and deploy this service. And now let's do cows run experiment pod termination, which remember that it kills one of my provider pod. Now I run it, and now it works. There is no failure. Why? Okay, you can imagine that. Notice how this pod is terminating, and here is the new pod that Kubernetes has started for me. But since I was starting this pod before running the test, now I've killed the pod and I make the request. But since there was still one pod there, then everything worked as expected, right? So it returned a 200. Now let's do another experiment, just to think about it. Let me, for example, do a cows run experiment kill deployment. So what's happened if I kill the deployment? Okay, what's happened if instead of removing one pod, I remove all the deployment? This could happen because all the working node was down, or maybe because someone did it by error. And notice that, of course, I'm getting a critical, right? Because it's saying, okay, you've killed all the providers. You have not killed the pod. You've killed everything. But if I do a kubectl get pods, you can see here that I've got a my provider instance of 13 seconds. And you will say, but how this is possible? If you killed the deployment, then there should be no provider, but there is one. And the reason is that if I do this experiment kill deployment, I've defined here a rollback section saying, if there is a failure, then redeploy the provider deployment. And this is why the deployment come to life after this critical error. So as you can see, you can play in an automatic way really easily with Chaos Toolkit and Kubernetes. So we are almost done. We've got 2 minutes before starting the questions. If you want to try all these examples with you, then you can follow this link, and you will check these experiments. So let's wind down. Of course, every adventure requires a first step. So don't start with doing chaos engineering and let's see what's happening if I kill all the clusters. Don't do that. Just start step by step with a small services and see how it goes. Again, start small, as close as possible to production. Maybe you will not be able to do it in production, but then try to find an environment that it's really close to how production looks like. Communicate with everybody. Have a failover plan, because things can happen, and you need to find a really quick way of saying, okay, something went wrong. I push this and see what's happening. And I recommend you that do not automate everything. Just start a manual. Of course, be realistic. The history helps you, because some people ask me, how could I start? How I could do my hypothesis? And it's like the history helps you. Just ask to the operations people, the operations team, and ask them, hey guys, what are the problems that we found in the past? And they will give you a list, and then try to run these problems into your chaos engineering test suite. Again, chaos engineering is not, it's about experimentation. It's about explore to find new knowledge of how your system behaves. So it's really important to do it, to know exactly your microservices architecture, how it works when some failures happens. And yes, of course, maybe you will fail someday, especially the first time. But I think that it's worth to try and worth to use chaos engineering to make your services more resilient. And that's all. Thank you very much. I will check in now the questions. And if not, follow me on Twitter, and you can ask me there. There is my YouTube channel, email. You can send me emails, no problem. Thank you very much. And
thank you so much.
Now it's time for the questions.
Thank you so much for the presentation. It was a really great overview of chaos engineering. So one thing I actually, there is one question that I wanted to ask. It's, you said that there could be also sometimes some things that could go wrong. Could you give some examples of what that could be while doing chaos engineering, and maybe some actually examples like from real life?
Yeah, well, what I see that things can go wrong is like, I remember that some time ago, I mean that maybe 2 years ago, I was talking with one company. Said, hey, have you heard about chaos engineering? And I said, yes. And I said, are you using it? And, yeah, we are using chaos engineering. I said, okay, and how it goes? And they told me, oh, it goes horrible. And I said, yes, why? They told me, yes, because the first test that we tried was to kill our cluster and see how much time we were able to to recover all the cluster, right? And it was like, okay, and what's happening? I said, yeah, that none of our clients could access to our system during 2 hours, right? So yeah, so maybe first of all you need to start with easy hypotheses, like what's happening if this service is down, what's happening if this service returns a 500, what's happening if I kill this pod, what's happening if the database is down, what's happening if my in-memory cache or distributed cache is down. Try these things that probably is not going to, you're not going to suffer a lot if something goes wrong, and then move forward to more heavy things. I mean, that do not start with it. This is the kind of things that as I say, that things can go wrong. So at the very end, it's important to define your hypothesis, but it's also really important to have this red button to say, oh, something is really going really wrong. Push this button and all the cluster is again in the previous state, right? So this is the things that, as I mentioned.
So especially, it's really important to have a failover then, yeah.
Yeah, you've got fallback plan, failover plan, for things. But maybe if you want to try to kill your cluster, that's fine. But then maybe it would be interesting to have a backup cluster. Kill the cluster, see what's happening. If you said, oh shit, everything is going really, with screw something, then redirect all your traffic to this backup cluster and then try to fix your principal cluster, things like that, right? So yeah, it's important.
Okay, that's a really great insight. Thank you. So let's say, imagine that, I don't know, we're just a relatively medium-sized company and we want to start with chaos engineering. Like, what's the first small step would you make for that?
Yeah, I would say that, for example, if you're in Kubernetes, then maybe move from service mesh tool, which is really great. If you are more like Kubernetes and and you're using Kubernetes, but also other deployment platforms, like for example Docker Swarm or just Amazon and so on, then just use Chaos Toolkit, which works pretty well, and then start to identify services that are stateless. For example, services that are stateless are really easy to recover, right? Because you just need to replicate it, and you have more instances, and it just works. Then you could just start with the stateless services and say, okay, let's start to do some chaos on these services that are stateless and see how they behave, right? It's really easy to have a backup plan for these kind of services. Then, when you feel comfortable with this, you can say, okay, let's start and let's move to services that has a database, but they have a lot of reads, but no writes, or almost no writes, right? And then let's see what's happening if we stop the database, right? What's happening if I remove the database, and these kind of things. So always be step by step with really simple services, and then you will start getting confidence. And then you will start, more and more, or having more cows on your cluster, right?
All right.
Just a final note. If your code is, for example, I know that Netflix is killing one region, right? Every 2 weeks. So every 2 weeks, at least one time, they are killing a region on purpose, right? So, okay, this is, the top, and then, you need to, find your way to arrive to this. Yeah.
All right, well, thank you so much. That's finishing perfectly on time. Thank you for sharing the knowledge, and hope you also enjoyed giving this talk. And
Sure.
yeah, thank you. And you
Thank you
guys
very
for
much.
following us. See you in 10 minutes. All right, hello, and welcome back to Jnation 2020 Online. My name is Leon, and I will be hosting this session. So first of all, thank you if you've been following us here today. And also big thanks goes out to our sponsor for making this event possible during these times. And finally, a huge, huge thanks also to the ones who you came here to see at our live event. In this case, it's Mary Grigleski and Oleg Dokukan. Hi, Mary. Hi, Oleg. How are you doing?
Good. How are you, Leon?
Good, good. I know that your guys, one of you is in Chicago, the other one is in Ukraine. So this is like we're having two speakers at the same time, but with 8 hours of difference. That's amazing.
Yeah,
yes.
Correct.
Yes, yes.
So earlier we had an introduction actually to reinforcement learning. And I think your talk now is going to be a great example of how this can be actually applied. So Mary and Oleg are going to explain to us how to teach Pac-Man to play with machine learning and reactive streams. But just before we start, don't forget, you can ask any question on our room Slack or on YouTube, and I will make sure that they will get it by the end of the session. Oleg, Mary, this virtual floor is yours, so good luck.
Thank you for intro.
Thank you, Leon. Thank you, thank you. Okay, so we'll start. And first of all, thank you so much for attending our live session right now. So I'm very happy today too with Oleg Dokuka. We'll be doing this presentation on teach your Pac-Man to play with machine learning and reactive streams. Oops. Bear with me a second. We're sharing screen. Oops. Okay. So what is this talk for? So it's for anybody who's curious about machine learning and artificial intelligence. And if you're curious about doing better coding using a better approach, and also primarily curious about distributed systems. And let me do a quick introduction about myself. I'm a developer advocate at IBM. And by night, I'm a community organizer. I also am the president of the Chicago Java Users Group and also board member there. And I organize also events too for the IBM meetup as well. So, and just a quick thing too is that I met Oleg in Ukraine and Kyiv. And so that's how we came together, and I saw his amazing presentation. So we started talking about doing a talk together. So I'm very honored. So now let's have Oleg introduce himself.
Yeah, thank you for sharing intro for me, Mary. As you said, my name is Oleg. I'm from Kyiv, from Ukraine. If you have never been there, I'm inviting you to visit Ukraine, to visit Kyiv. This is a beautiful city. We have a lot of stuff to look at, like just to some sightseeing and so forth and so on, as well as you can spend your time pretty productively by visiting our conferences, which are pretty interesting. We have dialogues, we have many interesting conferences. So I'm inviting you to join my country and my city. But in the meanwhile, this talk about machine learning, but to be honest, I'm not a machine learning expert. I'm reactive programming expert. I'm a big fan of Project Reactor. I'm a contributor to this project. Right now, I'm leading our socket project. So if you have never heard, I will be quickly explaining what is that in this talk. And in general, I'm a big reactive fan. So I'm so big fan, so I've wrote a book about reactive programming in Spring, but this is a side story. Nevertheless, let's stop talking about us and let me quickly introduce what we are going to talk during this presentation. So first of all, this is talk about Pac-Man. So we will quickly look at why Pac-Man is a good kind of source for machine learning still. Then we will be looking at different machine learning approaches in the context of specific version of Pac-Man that we have today. And finally, we will be figuring out how reactive streams is related to all this stuff at all. So that's what we will be doing during this session. So if you're interested, stay with us. And Mary, so I guess the main question is why Pacman is a good source for machine learning then?
Sure. So yes. So as we all know, Pac-Man is not a new game. It was invented back in the 70s by a Japanese engineer in Tokyo. And it was a video game at that time by Namco. And I'm sure too, all of you or most of you have at least heard of it and have played. In fact, even to this day, it's still very popular because it's actually quite simple, not that complicated. It's undeterministic behavior of ghosts and Pac-Man makes it kind of an ideal platform for doing research, especially for like AI and ML researchers. And as such too, because of the simple way of doing things, it's just the possibility are many. So from a computation perspective, you don't even need like an IBM cluster machine to run it. You can actually set it up and run it on your local machine. You can run it locally and not even like run it over the network, for example. So it's a very good candidate for research in this field. And because of its popularity, even to this day, you'll find that there's still team competition. For example, Ms. Pac-Man versus Ghost Team competition for the CIG organization in 2018, and that's with IEEE. So as you can see, it is a popular game, and even to this day, and it's just simple enough to study about the complexity that's behind, a lot of systems.
This sounds really interesting. However, isn't that solved yet? I mean, humanity have done a lot of research about Pac-Man. The game was developed so far from nowadays. So do we have to solve anything? Why we should perform this talk, basically? Can you tell us, Mary?
Sure. So it is very true. I'm sure that some of you, if you are, have not come to our talk before or kind of thought about it, if you think about it, you probably are wondering, well, Pac-Man is already there. There are so many variations of the game and out there. So why are we still using Pac-Man? Isn't the problem solved? So the thing is, the problem, yes, if you like doing on a local machine, a very simplistic way, single user, single player, and all these, yes, they are kind of soft. And of course, you can still improve upon it, just like any other thing. But say if you take a look at the way the computing world is going, in the recent 10, 12 years, hardware has become so sophisticated. There are multi-core machines and multi-CPUs, and we even bring machines into virtual level, virtualization, containers, and cluster and all that. So basically, the scenario, the environment is ripe for even more challenging situation of designing these games. And so if you think about it, then we're entering this distributed systems phase. And in fact, when you talk about, when we talk about this, and I've actually seen Oleg did a great talk on using a multiplayer Pac-Man. And that's also, it's something very new that I'm sure back in 70s, they would never have thought of a multiplayer game. So as you can see, it's the possibility is many. There are challenges out there to make this game even, bring it up to many levels up. So yeah, and in fact, let's go back. And Oleg, you did this presentation on a multiplayer Pac-Man, and that's how I came to know you. So maybe you can tell us more about this particular work that you've done and how it
Absolutely. So the story was the following. I was thinking how to show the power of RSocket protocol, and I decided to implement multiplayer version of Pac-Man because nowadays there is kind of a trend of playing different games in a distributed environment. So I decided why not to try and why not to implement multiplayer version of Pac-Man using this powerful protocol, and I've done it. So let me quickly introduce what I got. First of all, from how it works perspective, I created browser game because many people have mobile phones where they have browsers. Many of us has computers, so basically everyone can play the game in browser because it's convenient way of doing that. By this, it means that if we have browser, we have to have a server, and the communication is pretty simple. We open our browser, the web page is loaded, server pushes back all the important information that we need to have on the client side, and that's it. In order to start playing, we say start playing, put our name. So we have first interaction between client and server, exchange the important data that we have to exchange. So we got a state, and then in order to start playing, we have to send some information. Basically, we have to move. And once we move, we have to say, here, now we at this point, and so forth. And so basically, the logic is pretty common. Many games that we have nowadays are implemented in this way. So as we move, we send updates from our client to our server about where we are. And the server then makes all the decisions. So it means that in order to see how other players moves, server have to send back all the updates. So we have this stream of updates from our server to our client. So it kind of multiplies all the actions from all the clients back to our computer. And of course, we have the most important part in this game. This is scoreboard. So server makes all the decision about what pills you eat in and how many points you get from that action. As well as if you play for ghost, for example, you should chase the ghost and you got on score for eating or chasing a ghost. So this is how it works. However, it seems a little bit different from what we observed like at the very beginning. So let me shortly introduce the game role. Yeah, in general, it seems pretty common. However, there is some specific cases that I have to say basically. First of all, in general, this is 2-dimension environment, so you can move up, right, left, down. So nothing special in here. Then the main goal of a ghost in this particular case is to collect as many pills as is possible. And of course, another goal of ghost is not to die. So the goal is to survive. And of course, ghosts have to run out from Pac-Man have to run out from ghosts. And of course, there is some specific cases. Of course, the goal of ghost is to chase the Pac-Man or some Pac-Mans. But in general, there is some exclusions from this rule. So you have some options where you can try to chase a ghost. So basically, there is super pills as in the original game. So you can turn the chasing direction in a different way, and you can start chasing ghosts for a few minutes or a few seconds. In general, sounds pretty similar. However, I say that there is some differences from between this game and the original one. First of all, this is multiplayer game. It means that there can be a few Pac-Mans, a few ghosts, and this is real players. So they have to communicate. There is many computers communicating with each other. This is the first thing. Then we have infinite gameplay. Infinite gameplay means that there is no end as in the original game. So there is no levels. There is different maps, of course, but there is no levels. You have to play, you have to get the highest score, and you have to survive as long as possible. So this is the main goal that you have to follow. And for example, if you want to write an agent, we have to take all these specific cases into account. So yeah, that's what I have to tell about the game that I implemented, Mary.
Yes.
And yeah, I want to shortly show that it really works, because this is not just a fake, it's a real game. So I'm welcoming everyone who's watching this stream to scan this link or to just copy paste this short link, and you'll be able to join this online game with us and play simultaneously with us. So if you follow this link, you will be able to access public web page. What you should do, you have to put your name, as I said before. This kind of the first setup, and then you'll be able to start playing. Of course, as you start joining this game, you'll be able to play only for Ghost, because our mission for today is to write an agent for Mrs. Pac-Man, right? Right. So in the meanwhile, while you are joining, let me go back to slides. And my first question to you, Mary, what machine learning approaches do we have today in order to implement this machine learning agent, taking into account everything that I said about the game?
Sure. So yes, so let's take a look at some machine learning approaches for doing like designing and implementing Pac-Man controllers. And so that's the area we're trying to address here. Not that, first of all, not that we're experts in machine learning, but we find it to be so interesting. We started studying about it and also trying to come up with a best way of doing what we're trying to achieve today. So let's take a look at some background information. So these are the different approaches. So if you're familiar with machine learning and some of these approach, you probably can take a look into this, and this is the list of what we have kind of done some study on. First of all, let's take a look as the simplest case is a rule-based kind. So as such, rule-based is actually sort of a brute force way of doing things. Essentially, it comprises of like if-then statements in your in your code. It gets translated to that. But as you can see, if it is like doing if-then, then basically it requires you to have knowledge of your domain very well, and you have to know like every single possible moves, and then basically code it accordingly. So let's take a look. So you'd be wondering, well, what are some of the examples? So here it is. Yeah, with IBM, there was a Deep Blue. That was back in 1997, 96, in that time frame. So if you are a chess enthusiast, you are familiar with Deep Blue because it was a machine that was totally dedicated to serving the purpose of playing a chess game. And that one is basically nothing like fancy AI techniques. It was simply a rule-based machine. But nonetheless, it serves as a very good, as a starting point for the whole, the research get into here, and a good way of studying it. So as it turns out too, if you're familiar with it or if you're not familiar with it, the Deep Blue was designed as a chess machine. And basically the highlight of it was that Kasparov at the time was the chess champion of the world. And so long story short, IBM and Kasparov, like they challenged each other. And initially, it actually was Carnegie Mellon, that team of folks who did this deep thought. And then so they did it so well, even though they lost. So that's how then IBM invited them. So IBM then now says, well, we're going to invite Kasparov, the best chess player. We'll play against it. We can beat it. And so the story goes is that Kasparov got defeated, and of course it got him quite upset. And so he kind of demanded, or in some ways is asking IBM, well, we need a rematch, it's unfair and all that. But IBM decided to retire the machine. So that was the story. But yeah, so the point of bringing this up is to just show you an example of a rule-based machine dealing with handling like artificial intelligence, machine learning algorithms. And again, the thing about it, it's kind of that it wouldn't, be able to take a primary, kind of importance in the field of computing, because it just requires a lot of heavy domain knowledge. And in today's world, when you have complex systems, if you need a rule-based, then it will be simply the machines will run out of memory. So let's then take a look at the next thing. It's a Monte Carlo tree search. As such, Monte Carlo tree search are essentially not like one single approach. Is essentially taking the essence of two, Monte Carlo and then a tree search approach. So let's first take a look into Monte Carlo. Monte Carlo is essentially you want to sample of like a set of decisions, and based on for example, in the Pac-Man game, you need to make a lot of decisions, and the way the routes, the paths you are taking, and the choices you're doing. So it's basically capturing many sets of choices and their results. And so, for example, in here, we're looking at this screen Monte Carlo method. If you use that, basically you look at Pac-Man is right here in the screen here. It has two choices, either turn right or turn left. And in this case, it decides, okay, it's random because there's no nothing in your knowledge base to tell it what it is. So it takes make a random decision, turn right. So now in this case, it gains a point by eating a pill. And as such, in the next point, then it has like three other choices it can do. So at this point too, it keeps going, for example. And so then like you want to probably go from like one point to another, another point, and you build up all of these the matrix of all your decision, your vector, the vector that consists of your moves, for that particular case. And so now then you can then go back and then essentially make another choice. And if in this case too, if you say you go back, you can actually move like, make different moves too and achieve at the same point. And so on and so forth. So you try to sample a lot of moves and the decisions, and you capture those. At the very end, after sampling for a huge sample, because you need a lot in order to determine which particular set of moves actually gives you the best score. So in this case, you look at it, Monte Carlo is essentially requires you to build up a lot of sampling in order to make a decision. So as such, you can tell, right? It's basically maybe not the best decision. So let's take a look into tree search. So in tree search, here is an example of a 4x3 small grid. We just want to illustrate. The idea of all of these is to look for an optimized way of achieving your goal. So in this case, we have Pac-Man in here in the lower left grid, and it has to try to reach a pill that's actually in the center of there. So at this point, it can have two choices of move right or move up. And so let's take a look. In your tree search, you could move right. And so now you can take a look too, and it's building up your tree. And then it basically so on and so forth. At every point, then it makes its next move, and it keeps going. And you kind of basically start building up your tree based on the decision it makes and the action it has. And so then you now build up, and then you can then look into this path that you have taken and determine a score that's essentially measuring how efficient it is, this particular method. So now in this case, the Pac-Man decides to take a right, and it kind of has to go through all of these nodes and many steps in order to reach the next pill. So how about it? Then, of course, then you take a look, and it gives you a score, let's say, of 30 at this point. And so now let's say, how about we experiment with another, a different decision. So in this case, how about we move up? So by moving up, you actually will have a more efficient route, because then let's take a look at this. At this point, you move up, and then you have three more choices, and then you basically say, okay, let me keep going right. And basically at this point, you are already there at your destination. So over here too, then, as you can see, the tree search now will give you a score of 40 in this case. So relatively speaking, it is, a higher score because it is actually a more efficient and requires like less effort to reach your goal. So as you can see, like both methods, they are trying to reach and optimize, a way of reaching your goal and trying to analyze and on the most promising moves. But how about this? You look at both, they will both require a lot of sampling, which means that, the choices are many. So again, it runs into the problem of, performance is going to suffer when you need to like sample such a huge data set. So how about then we combine the Monte Carlo and tree search together? And it's basically, we're trying to expand on the search tree based on this random sampling of the search space. So then let's take a look, some illustration. Monte Carlo tree search is basically has fundamentally like 4 steps. So first, you do a selection. So at your beginning node, you are then presented with your next, set of possibility of making a move. And if you look at the choice you have, what this is doing is that you want to select the next node that actually gives you the best score. And in this case, like a higher score. So if we know ahead of time, then we, in this particular case, you choose 3 because that gives you the highest score. So you take that, and basically then you decide, I'm not going to go through the 1 and 2 because 3 already, it gives me like a head start. I'm already like, have getting more points by going this route. And then based on this, then you go to your next level, you expand on it, and you do the same thing. You're making a decision. And if you reach a point in which you have 3 other choices that are equal kind of score or possibility, you basically like do a random, you say, okay, we don't know which one, but we'll just pick one. In this case, we pick the one on the rightmost. And from here on, we keep like expanding it. You do simulation, you keep going down this tree, you make the decision, and then you keep going, and eventually then you will reach your destination. In this case, then, in order to calculate, then what you need to do, you need to update your score of your parents. You need to do what is called a back propagation. You go back up your tree, and then you calculate and get your points that way. So, and also then let's take a look, right? So you can also like then take a look and say, okay, well, and you basically then have your parent kind of store the score. So in this case, then this is what we are seeing in here. So in this case, then you repeat the same procedure. You go through like the selection again, and you pick the highest score, and then you expand on it, and you do simulation. You traverse all your node, and basically from there, then you kind of back propagate back up and build up. So in this case, you can see too is that we're trying to eliminate the number of sort of like repetitive decision. If you already know that, by following a certain path, the parent, if it has higher score, you want to kind of keep with that route. So that should give you an advantage, in this case. So that's like a Monte Carlo tree search. However, like with this particular tree search too, as you can see, it would still require you a lot of sampling in order to know if your choice is actually the best. So it requires a finite game state, and it will definitely require a lot of memory in order to keep up with how much information you need to store. So what are some of the other kind of choices of mechanisms? So let's take a look. We've looked into evolutionary algorithms, and it is kind of an interesting kind of way of doing things, because as such, evolutionary algorithms is based on genetic programming, and genetic programming as such is it borrows idea from the biology, of evolution, genetic algorithms. So it's basically selection of the fittest and like mutation and as such, like principles of such. So it's interesting to kind of look at sequencing, and then you can then make decisions based on these information. As such too, evolutionary algorithms is possibly not for all cases, but the thing is, for playing Pac-Man game actually has been, or any other game, this kind of decision making is actually popular because it helps. It helps to in making like data classification, and it's real good for solving like optimization type of problem. And in a game such as Pac-Man, because you have a lot of decision to make, at any one point you're having like either you go forward, you gain a point in eating pills, but yet there's a ghost coming, that type of stuff. That kind of scenario makes it kind of a perfect candidate for doing genetic using genetic algorithms. And also too, the good thing about it is that you have incomplete set of information ahead of you. So this actually evolutionary algorithms is supposed to be like a good choice. So as such too, the algorithms has two major different types of algorithmic way of doing things. One is the genetic evolution. The other is a grammatical evolution. Grammatical one is actually interesting. I also have some code to kind of quickly show you is that the grammatical one is basically you are translating your parameters, like using numbers in order to represent all of your sequencing and data too. So to kind of sum it up in a layman's term. So as such too, for genetic operators, I want to bring up too is that there's the concept of genetic operators. So basically it's used in genetic algorithms to basically guide you towards a solution for the problem. And there are three main types. And as such, they are kind of imitate also the biological evolutionary concepts. So they are mutation and also crossover and selection. So these kind of maps to like biological senses. Mutation is diversity. Crossover is like a recombination, is basically like reproduction, and you always combine two and then you come up with the better one. You combine the two and you select the better one, and it's like a crossover. And also then ultimately it's like survival of the fittest. So in a computation terms, it's basically genetic algorithms is trying to find the fitness value of all of your decisions. So over here, just again, a quick explanation. Genetic evolution is you take two sequences of data, and you basically then combine the two. And over here too, then it comes up, what your resulting is you generate a better sequence. It's again by principle of like mutation and crossover, you always will have a better selection with what you have generated from the two. Okay. So again, grammatical evolution, which I mentioned a little bit, you basically is using functions, you're tuning these parameters. And the nice thing about it is that it's basically mapped to the program grammatically. Again, I mean, I'm just simplifying things here, but essentially you are translating all your choices and sort of map it to some numerical representation. So just maybe a quick look too, I mean, rather than just talking and just some code to quickly show you. Let me see if I can, I guess I'll have to, I have to share my screen. Okay. Okay, let me, okay. So this is just a example of a research paper that we have come across too, but just quickly showing you, I was hoping to run it, but there's been some issue, and also we have a bit of a limited time, but you're welcome too. I just want to quickly show you, so if you're interested into somewhat deeper too. And basically this library is an experimental library called JCO. So JCO here has the algorithms, and basically wanted to show you again, I was talking about these genetic operators. So I was highlighting crossover or mutation and selection, all of these things. So of course, if you're interested too, you can kind of take into here. I was hoping to show like a crossover, for example, like LHS, and this is like, you know, one of these computation here. If you kind of take a look into it, it's basically this library will do all of these things for you kind of quite easily. So, but again, this is actually in my GitHub repo. So, and I've also listed at the very end in there. So if you're interested in it too, you can kind of take a look into here. And I basically also wanted to maybe show the Pacman controller too. So basically too, there's also like a nicer tree kind of way of. Okay, let's take a quick look too. The nicer tree will essentially, you know, basically execute and get moves. And so it's just some code sample to show you that this isn't just about talking. So, okay, so I think I do have kind of limited time, so I'll kind of go back to the talk, and maybe Oleg can share. Thank you. Okay, so I'll go back in here now and just quickly talk about, that's the grammatical evolution, and please take a look if you're interested. And the code, and oh, let me, a little too fast. And so, however, I mean, I spent a bit more time on that because it's an interesting algorithms, and also there are actually financial applications too that take advantage of like genetic algorithms. For example, you are like predicting some company, their stocks, you know, their bonds, you know, how it varies over time. And you basically can play around with the numbers. So that's why I wanted to highlight that. It's not just for games, and there are some practical usages using that algorithms. Now, coming back to us talking about gaming, in this case, Pacman, we are still kind of thinking, this is not, you know, as much as it seems like it will be a good approach, but we found out it's probably not the ideal, because it requires you still some domain knowledge and some finite game state, and requires like a long-running evaluation function. Now, if you really go take the code and run it, the evaluation part is actually, you can vary all your parameters, but it does require a long time to evaluate, because you're trying to go through all of your sequencing and basically generate better ones. So as you can see, it's not a very efficient manner. So now, I've spent so much time on it. Let's kind of take a look at the next one. Let's take a look at artificial neural networks. I mean, everybody talks about it now. There are essentially, this one has, well, artificial neural networks, first of all, it's basically you mimic the human brains, you know, the neurons, how they travel through, you know, through your mind, and it's basically translated to doing computation. So you basically can configure it as policy networks. And it's kind of like reinforcement learning, which we'll talk about in a little bit. Some decisions and actions are involved. You're trying to learn like optimal playing strategies. You want to like repeat, you know, this training over time. So in some ways, it's like reinforcement learning, though it isn't quite like that, but it makes use of those principles. And so just to show you too, in picture, this is what it is. And basically you have input signal. It's basically coming in some input, and you have that first layer that takes your input, and basically from there, then it passes through many layers. It takes your input and basically pass through all the layers. And over here, just simplifying, we're showing one hidden layer, but in reality, you can have many layers. And basically, each layer essentially will come out with a better signal that goes out to your output layer. So that's what essentially it is. So you see that the input signal going to right is like feed forward of the input signal. And basically, you can back propagate too of any error signal. And in this case, I'll also go into the next slide and explain a little bit. Again, this is in a nutshell. There are two types of, or primary types of artificial neural networks. They're feed-forward, and an example of such is the convolutional neural networks. And as such, they will be ideal for doing image processing because it's kind of like it goes one way. It just goes from input, hidden layers, and output. And then that's it. So for image processing, 2D processing is a good way of utilizing it. And then there's also recurrent neural networks too. As such, recurrent will take more effort because it goes back, it feeds back, and all the errors, it goes back. And basically, the idea is that you want to eliminate errors. So then you take into having had to calculate what are the errors you want to eliminate by every single forward action to it. So now, oops. I think I did a little too fast. So as such, right, artificial neural network sounds like, kind of amazing. But the thing is, we're just doing Pac-Man in here. So you may ask, do we need something like so complicated? And it's, let's take a look. We talk about reinforcement learning. So this is when we kind of realize, wow, reinforcement learning is the perfect answer to us in Q learning. It's basically an action outcome-based education. You continue the progressive learning. And the nice thing about it, nicest, is that because in every game situation, you don't know what will happen and things can happen, in any ways. So it makes it kind of an ideal candidate because you really don't need to know a lot of domain knowledge. And why? It's because of the concept of, the rewards. So going a bit more into reinforcement learning, there are essentially like 6 kind of areas we want to pay attention to. So there's agent. So in kind of more traditional supervised machine learning where you build up a known model and all that, it has a supervisor that basically supervises what actions to take. But in reinforcement learning, it has the concept of agent. Agent is kind of acting on your behalf, making decision based on some input if it's already there. If it isn't, if you start the game, it will be random. So anyway, so there's the agent trying to make a decision based on some feed, in, and then there's an environment in which you operate, where the agent is operating. And ultimately, you want to see what the reward is. So then based on the reward, you build up your knowledge repository. And then from there, based on the reward, you know what scores you get, on the kind of moves you're taking, given that particular state. So which gets into the state. And state is basically a reflection of that particular point in time, your state, and also to how it is as it execute policy. So without getting all the details, policy are more like, some sort of like moves you make, and so you set up policy based on that. And because of it is affected by what rewards you have to. And then the value essentially is the value function is basically explaining, is it actually give you any kind of value from that particular move.
Yeah, sounds really interesting. So let's take a look a little bit closer at this one. I like it. Sure. Like in contrast to the previous one, it seems pretty straightforward.
Yep.
Like all the components are simple and nothing sophisticated in there. So can you explain a little bit more how it fits to our use case? I mean, at Pac-Man use case as well as distributed Pac-Man use case.
Sure. So so if you look at like Pac-Man at every scenario, it's a great metaphor, in fact, of reinforcement learning because you can actually see the environment as a grid, and so it's a grid of it's making all the movements. So in this case, like agent comes in making a decision, and basically it will look up, if there's a knowledge already built up, it knows what to do. It's basically okay. I don't even need to, so to speak, think, based on what I have, I kind of make the next move based on the knowledge. But if it isn't already there, I'll make a random decision. And so basically, too, in this case, you're Pac-Man making, in this case, making either a right move or a left move. In this case, it decides, okay, let's do a right. And then based on this, you basically have an outcome of, a positive outcome because you ate a pill. And the pill gives you 10 points. So look at the scoreboard, you get 10 points, you get higher points, you get a reward. And so
my question is, we have this kind of action and we have this kind of outcome, but how it's useful for us then.
Sure. Yes. So yeah, for this outcome, we don't just throw it away. So what we do is, again, we go back to here, you make a decision, some outcome, and then the knowledge, you basically take the knowledge and you build up your knowledge repository. Think of it like a repository. Oh, this is good knowledge. Let me store it so it can be referenced for future. So then the future, you come across this particular move at this particular state and scenario, you can kind of basically make the decision. So here, you kind of make the decision, and basically, in this case, we animated, we gain 10 points and all that. So that's what it is. So
yeah, looks interesting. However, I'm seeing a problem here. First of all, what I've seen is that you have to have kind of really similar state or like identical state in order to make the same decision. So it's not that sophisticated, and it may lead to the following. In our case, we have kind of continuously changing environment. For example, if you ate a pill, another pill will appear at a different point. So it will be really, really low chance that the same state will be over time again. I mean, because of the huge map and randomly generated pills at newer positions. At the same time, we have continuously changing number of players. So for example, it was one Pac-Man and one Ghost, and now we have +1 Ghost, so it's totally different state. So how it's useful then? And finally, having this, like, the combination of continuously changing number of all these parameters, we will just blows up our computer because we will have to store everything in order to use it. So it seems a little bit useless. So can we fix that a little bit somehow, Mary?
Sure. Okay, let's take a look. So we kind of look at it more, and we found out a even better way. It's called a case-based reasoning. So as such, it's an improvement over the strictly like a pure reinforcement learning. So let's take a look. Case-based reasoning is basically you're building still. You are based on the knowledge, you reason of things and based on the knowledge, and you still kind of build on your knowledge base. And what it's kind of different is that you try to find similarities in all of your moves, right? So for example, I'm making pancakes. I'm trying to have a recipe of making plain pancakes and recipe of making blueberry pancakes. I mean, the steps are pretty similar until you get to the point of blueberries. You need to add blueberries, maybe some extra steps to that. So why don't we kind of use this kind of same analogy? Let's not, spend our time repeating things that we already know. So if we identify patterns, you basically then say, okay, we already know something, and we'll just find these similarities and kind of apply the differences to each particular scenario. So likewise, that's what it is. And so you're using this keep it simple rule, because you need to make the decision. You want to keep your particular scenario simple, so then it helps to make your decision a lot quicker without kind of complicating the scenario. So that's what essentially case-based reasoning is, to summarize it. And basically, too, it's a form of like reinforcement learning, or an extension, I may say, of expanding on reinforcement learning. So you still like gather your knowledge and you kind of build up onto your knowledge base is what it is. So, and okay. So
yeah,
in summary,
sounds really interesting. In general, what I understood is that like kind of reinforcement learning, first of all, allows us to be continuous. So it's kind of continuous learning, which is good for us because this is kind of online game. So if you run a bot, this bot will be continuously improving its knowledge, which is awesome. I like it. I mean, I can imagine the game which is improving continuously over time. Always. That's amazing. And what I can see that case-based reasoning is a kind of enforcement of reinforcement learning. So it optimizes memory usage. It kind of simplifies the state, so we can look at the most important things like the closest field, the closest ghost, the corners, the general kind of pattern of the maze at this point of stain, for example. So it's kind of improving the general good approach. So I like it. So
yes.
Finally we can start using reactive streams. Yeah.
That's right. Yes. So now we are right at this point. So yeah. So why reactive streams? Oleg, maybe you can give us a more in-depth knowledge into this area. You know, among other choices. So.
Of course, absolutely. Nowadays, everybody is talking about reactive streams, about streaming, but you may wonder why is this so trendy? First of all, I have to say that we have to think about challenges that we have today. And first of all, we have challenges in like not in only in like microservices and distributed system, but in machine learning scenarios. And for example, one of the scenarios is traffic prediction. This is one of the most efficient use cases how you can apply machine learning. And if you think, well, if you build a model and you'll try to apply it again and again and again, you'll figure out that it works. However, everything is changing. Everything is evolves basically. All rules are changing over time, and you have to improve yourself over time continuously. So you have to consume all the data that are coming in over time, and you have to continuously improve your data. So it's kind of stream of data. Right? Another use case is marketing activities. And this is one of the super important use cases where machine learning have to be super fast, especially when the market is changing. So you have continuously consumed data, all this information, like analyze it, build new model on top of this data using the previous knowledge, and then produce new results, new predictions. So it's kind of important here to be evolving and continuously updating like their self and models over time. The same applicable for spam filters, because we like hackers evolves, our software have to evolve as well along with hackers. So we have to analyze all the data over time, almost in real time. So everything that we look at, all the different topics where we can apply machine learning should evolve over time. And basically, if we look like from the high point of view, we will figure out that this case is all related to data streaming, because like all this information is nothing more than stream of data, right? And the same applicable for gaming, because nowadays we have different kind of games. And you may imagine that you are playing with a bot in the same team. For example, you are playing in Counter-Strike, right? So you want to have bot that evolves over time based on for example, on your enemy behaviors, on your behaviors. So this is important that your game is evolving along with you. So this would be cool. So coming back to Pacman, if you look at the Pacman in general, what we are doing, we are supplying a stream, right? So this is kind of a controller that we have. We are saying up, right, down, left, and this is basically a stream of actions in this case. Yeah, nothing more than a stream of actions. And unfortunately, nowadays, all the implementation of this stream of data it looks like pool model. It's pretty imperative. It says, well, let's consume the action of controller. Let's consume the actions of ghost, because everything is local, right? So you may find out such implementations in for example, all these implementations of machine learning approaches for competition. And of course, it can work. Yeah, nothing special here. If this is ran on the same machine in the local hardware where everything kind of happens immediately. However, if you think about distributed case, about our case, our controller is over the network. And the problem with network is that it's first of all unreliable, and then it's slow. So once you've done an action, Pacman start moving, and it moved away from what you wanted to do as the next step. So what we have to do.
Alec, I'm sorry to interrupt you, but just a heads up that you have around 4 or 5 minutes left on the presentation.
Yeah, thank you for letting me know. So in general, what we have to do, we have to apply a different approach. We have to observe and react to actions when they come. So instead of this approach, it's basically observer approach or observer model, and it's well known. So when you do an action, it's a synchronous approach. You have a handler to which you can put your observer, and once an action happened, you can do some results, and it will be much better because this is asynchronous and it doesn't require you to continuously pull and do actions. And of course, this is well-known fact that observer model is not the best approach. So over time, it evolved in something called streams or reactive streams. And reactive streams is a kind of standard approach for doing streaming. First of all, it's a proper streaming abstraction. It allows you to build chain of asynchronous like pipes or actions. And then it provides you with a set of standardized interfaces in many languages like Java, C#, Python, .NET, JS. So you can use the same standard set of interfaces in order to communicate between even different platforms. And finally, it's a perfect API design approach, and it works for monolith case as well as for distributed system. And first of all, yeah, just quickly let you know what it is. It gives you 4 interfaces. Just 3 most important is publisher, subscriber, and subscription. And it brings another approach, call it kind of backpressure, in order to keep your system stable. But yeah, we will be talking about that a little bit later. So let me quickly show you a demo of this approach. So first of all, what we've taken the most standard template for building Pacman, and we rewrote it in some streaming way. So as we said, we have kind of in our machine learning approach, in our reinforcement learning approach, 4 important kind of steps or functions in our pipeline which analyze stream of data. And first of all, we have kind of controller. Controller is kind of decision maker. So if you want to write a bot, yeah, so this is like kind of our application. This is implementation. I'll be sharing links afterwards. We are running out of time, so I don't want to spend much time here. In general, streaming approach allows you to build really straightforward and clean pipeline, which works kind of in local environment. So for example, in this case, I'm using in-memory knowledge repository, but yeah, we will see later what we can do. And then we can build up a pipeline. So I'll be quick. I don't want to write everything myself. So first of all, you should imagine everything as a stream. And first of all, controller is a stream. So it's represented as Flux, for example, or publisher. Flux is from Project Reactor. It's one of the implementation of publisher. So you consume all these actions, and then you apply some transformations, like game engine can accept all the decision you do and provide you with outcome. So it's kind of the next step in your pipeline. Yeah, and it looks pretty kind of imperative, but it's fully asynchronous and allows you to continuously consume stream of data. And then you say, well, we have to apply some machine learning approaches. So we have to consume this outcome, this action, and we have to learn something from it. And learn function, for example, can be like that. So it consumes a stream of outcomes from our game engine, and then it provides a knowledge based on some machine learning implementation. And then, of course, we can store this or educate our knowledge base, and then somehow reuse this knowledge using, for example, search. So it looks pretty straightforward. It looks pretty imperative. However, it's fully asynchronous. So right now it works kind of on the same machine. We are connecting to our remote game right now. So we are running this app, and yeah, just yeah, let me.
Mary,
Yep.
I'm really sorry. We're really running out of time, so we need to wrap up because there's already other speakers waiting to start their talk.
Yeah, sure. So yeah, let's keep it for now. Let's go back to the very end. I believe we are running out of time, so let's do our best.
Okay.
In general, with reactive stream approach, first of all, you can easily distribute your system because streaming is not related to only a single machine. You can split your stream over the wire, over the network. And what you can build in order to improve your machine learning approach is, for example, you can kind of build a distributed set of computers which are connected and listening to a stream of actions and then produce some outcomes to the same single machine which collect and process some outcome later. So you can apply this approach for many cases. Yeah, we are not going to spend much time. Let's summarize what we look at this session. Mary, go ahead.
Oh, sure. Okay, so yeah, we have to like summarize now. So basically, we have concluded reinforcement learning is a good model for and less technique for continuous learning, and it fits very well even for like online Pacman too. And basically, reactive streams, as you can see, Oleg can explain quickly, is really a natural approach for such cases and enables like real-time processing. And I think it's will be like really promising for doing machine learning training. And it works good locally and as well as in distributed environments. So we're like highly advocating for that. And okay, so yeah, we just have to come to this and then show you all the resources. We'll make these slides available to you. These are our Twitter handles. And then these are the different links to the different topics that we've talked about: reactive streams, reactive foundation, the machine learning, reinforcement learning, artificial intelligence, that the book by Russell and Norvik, and that's a good book. Also by Richard Sutton and Andrew Bartle too. That's a great book on reinforcement learning too, if you're interested. Then there's also the paper that we looked at is here, Pac-Man Conquers Academia, that particular one, IEEE paper. And also then the sample code too for the genetic algorithms, as well as our grammatical evolution. So we'll make these available to you. Additional resources is IBM Cloud is free tier if you want to sign up for that, and our newsletter, as well as the code today that I guess Oleg didn't get to it, but it is available in here if you're interested. And we are always open to listening to any questions you have, suggestions, and we're interested in the continuous conversation. So yeah, and Oleg, you have any more to say?
Yep, that's it.
Okay.
Thank you for your attention. And
Thank
unfortunately,
you.
I wasn't able to show everything, but
Yes.
this talk is available online, so you're welcome to finalize your watching at the different link at YouTube.
I'll let Mary. Thank you so much. I'm so sorry that we ran out of time. It was a very interesting presentation. And I would really encourage you to also share these links on the Slack channel for the ones who are interested. And also maybe later on the YouTube channel if we're allowed to do so. Thank you very much for your talk. It was really great. And this was also my last session for today. So thank you guys for joining in. In the next session, we have Roberto as a host. So enjoy it and see you later. Bye.
Thank you. Bye.
Thank you. Okay, have a good day, everyone. Bye-bye.
When we move with purpose towards a safer, more reliable world, striving to protect you, your business, and your assets, finding financial crime immediately before it happens, and assuring that someone truly cares. None of this would be possible without Fields Irons.
Hi, everyone. Thank you again for joining us for another session of Jnation Online 2020. This is our ninth session for today, so we're starting to get a little bit tired, but we're pretty sure that we'll get to the end. And here with us, we have Burr. Hey, Burr, how's it going?
It's going very well.
Yeah, nice to see you. Well, I know. Well, you were supposed to come to Portugal. Well, you came last year, so not sure if you want to come this year, but this is gonna be the way we're gonna do it today.
Well, it'll be a lot more fun if we kind of dive in here and get crazy. Maybe I can energize everybody and we can have a little fun with this process.
Hopefully. So what I'm gonna do is I'm gonna monitor our Slack channel and our YouTube chat. So if the audience have any questions to Burr, feel free to send them over there, and I'll be happy to relay them back to Burr. Burr, I know that you do some very interactive sessions, so I'll hope I can help you with that and our audience.
And I don't have access to the Slack. You'll take care of that for me verbally?
Of course, I'll take care of it for you. So you don't have to worry about that. I'll take care of that for you, and anything that you need me to relay, I'll do it. So no worries.
Okay.
So without any further delay, please, Burr, feel free to start.
Okay. Well, it'll be a lot of fun because even for this session, it'll be very stressful and exciting for me because I've broken a lot of my demonstrations. So we'll have to see what will work for me once we get into this thing. But I'm going to give you a nice, boring set of slides. How about that? Really boring, like the boring one you see right here with our Duke in supersonic subatomic mode. So we're going to talk about Quarkus. We're going to show you a lot of very cool things about Quarkus technology and give you a nice introduction to that technology. So let's get in here and get going. Now, I really love this little image right here. If you're familiar with the Adventures of Mark Twain, when actually Mark Twain was the guy who wrote like Huckleberry Finn and Tom Sawyer and things of that nature, right? The whole river boat down the Mississippi River kind of thing. But he's very famous for this quote that basically says, "The reports of my death are greatly exaggerated." He was a very fun storyteller, and he used to tell stories about people thinking he was dead. Now, the part that's interesting to me about this from a Java standpoint is we've been talking about Java being dead and not relevant and not interesting for a very long time. This is the oldest reference I could find from Computer World from May 22, 2016. But we've been talking about Java being not cool, not the thing you want to use anymore for a very long time. Yet to this moment, Java still represents the best technology that we should be using right now. So Java is still #1 in the TIOBE index, at least the last time I went and looked at it and pulled the screenshot. Also, Java is #2 in the case of the super cool Hacker Rank index, where they actually go out there. JavaScript #1 in that category. But even on the Red Monk index, right, Java is still up there in the top 3. So Java continues to be one of the most exciting places for a developer to be, especially in the modern enterprise, where they're actually trying to create applications for their businesses, for their enterprise end users, for their business partners, and as well as their other employees and consumers. So building applications with Java is still the #1 thing to do, in my opinion, and it's still the great place to be. The challenge has been that Java, okay, while it's been going incredibly strong, is getting a little bit old, if that makes sense, right? I don't know about you, but I can say about me, I'm a little bit older and slower than I was when I first started using Java 20 plus years ago. Once you break that age 50 mark, you start to feel it a little bit. So in this case, the programming language, of course, is 25 years old as of last month. And we've been working with Java for quite some time. Okay, so it's been going strong, but it is showing its age. And here's the real gotcha with the Java world ecosystem. Okay, here's the real gotcha. There's all this amazing goodness of ecosystem, of tools and frameworks and other technologies that you can consume to put into your Java application. There's all these amazing things you can actually take advantage of. And that ecosystem has really been a massive win for the Java community. The trick is with all these good things, all this to consume, it kind of gets a little tricky, a little bit challenging. With all those awesome flavors, it's kind of like having dessert for every meal, right? It tastes good. You could eat cookies and candy and cakes and ice cream for every meal, but over time, it kind of makes you a little bit chubby, all right? So that's really the gotcha that we are seeing in the Java community at this point in time. Now, here's one thing I always like to tell people. We at Red Hat have been working with the Java world for a long, long time. I personally have been with Red Hat for 14 plus years, came as part of that JBoss acquisition. And of course, from the JBoss perspective, we were very much invested in the Java world. However, in 2015, we gave birth to this new Kubernetes-based thing called OpenShift, right? So we gave birth to Kubernetes along with Google. We basically brought that on premise where people start using Kubernetes in their data center. And we've been doing that for 5 solid years. And what we have seen is a trend in those Kubernetes adopters. And that trend was Java's too fat and slow. I need to move to Node.js or I need to move to Go. We kept hearing that again and again and again. And that, of course, was a problem. So when you put Java in a container, a Linux container, and hopefully you guys are familiar with the concept of a Linux container, you might have heard of the word Docker, and you might have thought about Docker build and Docker run. The concept of a Linux container is fairly straightforward. It's based on C groups technology. It is not a virtual machine. It is nothing more than another process running within your Linux operating system, but it's a highly secured, sequestered, locked down Linux process that has limited resources. It can only use so much CPU and only so much memory. And that became a problem for Java. When we started putting it in the Linux container, by default, it would blow up. And depending on which version of the Java virtual machine you have right now, it still blows up by default, depending on what version of Java 8 you have. So I think if you go back to Java 8, I've lost the number, 153 and older, right? You will actually still see it blow up by default. It has been corrected over time. We backported fixes and things of that nature to make it blow up less, or less often at least, and have some default settings so that it actually is smarter about the Linux container. But the Linux container proved to be a big challenge for Java. And it was really a problem when you start to scale out across a Kubernetes cluster, an OpenShift cluster. Because in a Kubernetes cluster, you're going to have dozens of these pods, not just one or two, or one or two containers, if you will. We call those pods in Kubernetes land. You might have 5 of them, 50 of them, 500 of them, and then they start blowing up all across the board. Now, the good news is in Kubernetes, when this does blow up, it automatically restarts. So the big win is if you have a bad Java programming team, they might actually have their various thread pools, if you will, where they've eaten all the threads in a thread pool or all the connections in a connection pool, right? You didn't use try catch finally correctly, so you didn't put the thread back in the pool. Well, the system locks up and things like that. Well, Kubernetes will automatically restart it, or if it dies because it runs out of memory due to C groups and being constrained in the Linux container, it'll automatically restart it. So sometimes these problems just go away because Kubernetes and OpenShift will just restart that process, but you'd rather not have it just die. You'd rather actually be more stable than that, okay? So I want to take you back to 1999, all right? So I want to make sure I don't move along too fast here because this is actually really fun. This is very important that you guys understand this next point. So if you were actually going off to email or Facebook and you weren't paying attention, come back here to old YouTube land and kind of check this out. In 1999, this is super important for all you Europeans. You need to understand that the US won the FIFA World Cup, okay? This is critical. 1999, US wins the FIFA World Cup. And you probably think I'm lying to you right now. At this moment, you're actually typing on your keyboard, looking at Google to see what's true or not true. Like, am I making this up? For all my Brazilians who are listening right now, I know you got some Brazilians here. Yes, the US wins the World Cup, not Brazil, not Spain, not Portugal, not Italy, not France. The US wins the World Cup, okay? Now, how did that happen? What happened because we won the Women's World Cup. And I've used this joke a few times with a lot of audiences or this particular thing, but I want you to check your bias, okay? Because at some point, you probably thought, there's not even possible, because you assume only men can play the game. And I actually used to coach soccer for girls. I actually had a soccer program for 700 girls where I put them on teams, I actually coached soccer for girls for 14 years. So that was a big part of my life for a long period of time. And this is a seminal moment in the world of the US history, because when you coach a bunch of young ladies, they notice this moment as an example. So I make that point, though, really to talk about 1999. And in 1999, if you go way back, right, to 1999, and I know most of you are too young, you weren't around in 1999, but if you had been and you wanted to build Hello World and deploy it to the internet with Java technology, you had to have one of these Sun Spark app server boxes, you had to have a BA WebLogic, you had to have a database server as well, because you always did multi-tier, right? You had the app server in one set of boxes, database on a different set of boxes. Your database license was very expensive. We all used Oracle back then. And of course, you didn't have to pay for your IDE. So think about that for a moment. We paid $10,000 a developer, somewhere between $5,000 to $10,000 a developer, just so they could have access to development tools back then. So things were very different back in 1999. And think about how they are now. All right, we've kind of paradigm shifted from that 1999 world. It no longer cost us close to $500,000 to get started with a basic Java application. Open source has happened, right? And that's fundamentally changed that ecosystem. Now, another thing that's changed in this new world that we're living in is this concept of the cloud. The cloud basically says, don't expend $500,000 just to get started. The cloud says, go find you an instance type for 80 cents a minute, or sorry, an hour, or $2 an hour, or $10 a month, or whatever it might be, and launch it. light it up, get it started. This also means, though, you're constantly restarting these things, okay? So this is a new world we're living in where things are more ephemeral. In the old days, when we spent $500,000 to get started, we wanted those servers to stay up online always, all the time. They cost too damn much. It cost too much to even restart them, right? We had to have a person babysit them full time. In this new world, we try to automate everything, and restarts are common, right? We're constantly restarting these virtual machines, constantly restarting these pods and Linux containers. And because we're living in a new ephemeral world, right, that where things can actually move and change. Now, another thing also that has changed, and I love doing these history lessons that have changed really in our overall world, right? It's not just that Java was born so long ago. You can see 1996 over there, right? But, you know, HTTP has been around quite some time. Even Red Hat Linux was born back in 2000, Agile Manifesto 2001. But the point of this chart right here is to basically say, we've been on this journey, okay? Since before Java was born, or right after Java was born, we've been on a journey to change the way we build software. And early on with things like Agile and things like DevOps, right, we basically start breaking up the problem into smaller units. We broke up the long waterfall process into smaller, agile, smaller steps, a smaller process. We broke up the nature of how your app is handed off to operations with this concept of automated pipelines and things of that nature. And we start changing the way the workflow worked. Now, in addition to the process, the workflow itself that managed the process. And we also started breaking up the concept of the app into different smaller discrete units. The app went from a 6-month deployable EAR file to a 6-day deployable jar file, right? So that's what's happened over time. And some people might call this microservices as one of these points where in our evolutionary cycle where microservices has enabled us to deploy ever faster, deploy more often, and this means more restarts, right? You're constantly starting and stopping these things because you're deploying all the time. Also, we had the concept of Netflix OSS that changed the way we think about how we do distributed computing. We had Docker born there in 2013, Spring Boot born in 2013. Basically, we had Kubernetes born in 2014. And of course, like I said, Red Hat got into this game in 2015. We actually launched 1,026 containers live on stage. So in 2015, I mentioned this earlier, we gave birth to this concept of OpenShift, which was Kubernetes on your premises, Kubernetes in your data center. And that has been a key focus for us. Kubernetes, basically, OpenShift runs on every public cloud as well as your data center. But we decided to show the world that this was a new way of thinking about applications. You basically would build an application and scale it rapidly across these things called pods. And every one of these little tiles you'll see here in this diagram represent a pod and the pod lifecycle. So basically, we brought up 1,026 application servers live on stage in 2.5 minutes with the audience sitting there watching. And then we gave them a chance to use their phone to basically dial in a little image and put that little image, you know, they draw the image on their phone and uploads the image actually into the little app server and then would serve it from that little tile that you see there. So this may sound kind of crazy. Why would we launch 1,026 servers on stage? And somebody else thinking right now, oh, 1,024, not 1,026. I appreciate that. We did 1,026 because our designer said it looked better on the screen, just so you guys know. And you can click the YouTube video down there and actually go check this thing out. But the idea was we want to show that you could scale rapidly. Now, here's the thing that really caught my attention back in 2015. All right, you notice it says the 2015 JBoss Red Hat keynote demo, and it was one that I was very much involved with. We could not do this with Java. We had to do it with Node.js. Java itself was way too slow to launch 1,026 versions of them in 2.5 minutes. We had to do it with Node.js. And that has been part of the story that I mentioned earlier. Customers have been telling us since 2015, we want to do that crazy Kubernetes thing, but Java is too fat and slow. So we've been thinking about all these problems for quite some time, and that has led us down a different path here at Red Hat. And it caused us to give birth to a whole new technology and basically think about the way we deliver Java technology to the masses. So you might also have heard about this thing called Amazon Lambda, right? Amazon Lambda became super popular with the serverless technology over at Amazon Web Services. And again, the same thing. People are like, well, can I use Java for that? Can I use Java or Spring Boot for that? And then you start seeing comments like this, and the link is here on the Reddit thread. Well, you know, Spring Boot was never designed for that. And as a matter of fact, don't even use Java for that. Java is too slow. So forget Spring on top of Java. Don't even use Java as an example. So we kept hearing this feedback. Okay. Well, that is where we introduced this concept of Quarkus. That was the why we did Quarkus. We kept hearing feedback from all parties. Java's too fat, too slow. for microservices, too fat, too slow for serverless, too fat, too slow for Kubernetes. Fine if you're running long-running virtual machines, but these containers, these pods, they're much too ephemeral. They're constantly, they're being rescheduled. They're being scaled up and down, right? They're going from 50 pods to 0 pods and back again, things like that. And that is where you want Node.js, or that's where you want Go, but not Java. And so this actually bothered us a lot here at Red Hat. We've been thinking about this problem for a long time, and we have just figured out a good answer. So now Java is super small and super fast, right? That was really our focus. So what is the fuss about Quarkus? And I know it has a very funny name. So Quarkus, if you look at that word, actually has a dual meaning, if you will, or actually there's 2 words in that one word. Quark, which is a subatomic particle, right? So if you're familiar with particle physics and things like that, it's a subatomic particle, quark, and us is the best part of software, us. So we wanted to figure out a way to not only make Java super small, super fast, but how do we make Java fun to write code in again? And unfortunately, I don't have my full demo environment working, but I will show you a little bit of demonstration of how this works. But we had to also make Java as awesome to use as Node.js, not just as fast and small, but usability had to improve dramatically, because every Node.js person you showed Java to was like, why would I touch that old clunky thing? And we were able to also address that point. And I'll show you what that means in a little bit. Okay, so Java super fast, super small. So it's up to 10 times faster, 100 times smaller. And that, of course, your mileage will vary, depends on what you have there, but you will find it's faster, smaller, and more importantly, more fun to use than any other component or Java technology that you had before this point. Okay, so there's going to be all these different things we've done to it, right? Lower memory footprint, usage, faster startup time, optimized for short-lived processes, meaning if you really have that serverless style architecture where things dynamically scale up and down, really, really good for that particular use case, but also fine for long-running use cases as well, like a long-running microservice, or even a monolithic application for that matter, but really focused on the Kubernetes infrastructure, Kubernetes ecosystem, and how things run in pods. That was a key aspect of it. Now, we really focused on this developer joy, developer love. How much do we do for the developer? And that's what I meant when I said we wanted to basically show that, we can be better than Node.js. Okay, so the key feature there is this thing called live reload. Basically, as you type code, you type, edit, you hit save, and you hit refresh. So you edit, save, refresh, edit, save, refresh. So as you basically are typing in code, edit, save, refresh, edit, save, refresh. Now, you might be thinking, well, that sounds normal. Maybe. It's not normal for most Java people. Actually, for most Java people, what I just said is, what are you talking about? That doesn't even make sense. With Java, right, you edit, you save, you run Maven install, and you go get coffee, and you come back later to see if it finished. All right, that's the normal Java way of doing business, right? Edit, save, Maven, package, go get coffee, come back. Well, that's not the way we work in the Quarkus world. In the Quarkus world, it works like Node.js. You edit, you save, you refresh your browser and see what changed. That's the new model, okay? It also supports both an imperative and reactive programming model. I might be able to flip through some examples of that. Again, a lot of my demos are not running on this laptop at this point in time, but we'll show you some things. It's optimized for serverless. I'll give you an example of that and show you what that means. And of course, microservices. It can do the FatJar executable. It can also do a native executable. So if you want to go to the ultimate fast and small, then even down to native executable is possible with Quarkus, using the technology called GraalVM as an example. Okay, and it's really focused on those API style use cases. So your web app APIs, but also supporting things like Kafka streaming and other technologies that you're used to using within a Java ecosystem. Okay, so here we go. Now, here's one slide that's actually kind of important. If you're not familiar with the Linux ecosystem, and of course, those of us here at Red Hat come from this Linux world, right? There's all this work that's been done in the Linux ecosystem over the last several years. Things like jails was added a long time ago. And of course, SE Linux was born. And then we came up with this thing called C groups, where we could basically sequester or change the security parameters associated with a process. And then Linux container concept came to be. And then Docker really made it super easy to use, right? It gave you this thing called a Docker file and the Docker command line, Docker build, Docker run, and you could easily build Linux containers. And then of course, Kubernetes was born in 2014, as we mentioned earlier. That was really when things took off. Okay, so the whole concept of the Linux container changed the way we think about how Java runs at this point in time. But what I want to do at this point, we've been talking long enough, I think. I want to actually show you some things. Okay, so let's just get out of here and let's see what I can break on this machine. So we're still screen sharing. I want to go into, let's go to Quarkus.io. Okay, Quarkus.io, just to come here. And you can kind of see this is the website. So Quarkus.io is the website. Again, that quark, subatomic particle, us, the best part of software. That's what you want to check out there. There's a bunch of things you can get started with here, but check out the guides. So the guides, or if you click on get started there, the guides are very powerful. You can then see exactly all the different things you can do: dependency injection, how to manage logging, how to deal with resiliency, the JSON Web Token and RBAC, WebSockets, all the things you might be thinking of for your average application. How do I integrate this technology? How do I use this technology like Kafka or AMQP? Using Kafka Streams APIs, security with JPA, JDBC, LDAP, all those kinds of things, including business processes and business rules from the Cogito subproject. So Cogito gives us things like a BPMN2 model, so business process modeling notation, a lot of things here, right? So all the stuff that you should come check out, including your traditional microservices things like tracing and metric capturing, fault tolerance, health checking, things of that nature. And then also there's numerous aspects built into this Quarkus technology. So you have your JAX-RS style technology, but you also have your Spring technologies, right? So your Spring MVC, Spring Web, I should say, Spring DI, Spring Data JPA, Spring Security. So depending on the programming model you're in love with, it's probably already here, okay? And so you can just basically start building an application. Let me go ahead and just kind of show you that, okay, just to give you a feel for that. I'm going to go to code.quarkus.io there, all right? And I'm going to basically just give it some real simple parameters here. I'm going to say com.bursutter. I'm going to give it, that's my package name, okay? And I'm going to give it this little, let's call it Jnation artifact. So I give it the Jnation artifact ID, the build tool is Maven. I'll just keep it that way. You can also have Gradle here if you'd like to, but I'm more of a Maven person, if you will. I'm going to generate the application. That's going to download the zip file. I'm going to go over here to my command line now, okay? And I'm going to say move that thing, downloads, and that was called Jnation. Move it over here. So there's the jnation.zip. I'm going to unzip it. All right, let's CD over to it. And let me run my little tree command here. So basically, you get a bunch of things out of the box, right? So you have this default project template here. You can see there's the POM XML. There's a Docker files, both the Docker for native build and Docker for JVM build. Those become more important here in a minute. There's the Java file that you would need to basically kind of just get started. It's a JAX-RS endpoint. You can see there's a little web page in there. There's a properties file because all the properties are basically moved to one single file now. And then of course some tests, right? So you basically have something kind of ready to go out of the box. I'm going to bring up my Visual Studio Code. So code space dot here. I use Visual Studio Code as my primary editor at this point, mostly because I'm more of an editor-oriented person. I don't typically like the heavyweight IDEs. I tend to like the lightweight editors, always have been that, so not full-on VIM and Emacs. That's not quite my game, but I've been known to use VI a little bit. But that, I'm not that lightweight. I try to get a little bit more heavyweight than that. But if you look here, just to kind of make this point, where's that? They moved the buttons around here on me. Oh, so if I click on Java here, look at Java, language support for Java. The reason I'm using the Java here, though, you can kind of see it's the language support Java for Visual Studio Code was done by Red Hat. So a lot of people don't recognize that Red Hat actually does a lot in the ecosystem. And one of the things we did was help Microsoft with getting Java capabilities in Visual Studio Code. So I make that point, you can see there's close to 6 million people who have downloaded and used it. So it's a very popular tool at this point. Okay, but let me come over here and I'm going to bring up my terminal. And let's see if this works for me. I haven't nearly had enough time to check everything. So Maven, compile, Quarkus, dev. Okay, so the first thing you do when you get your new project downloaded and started your project template is you basically put it in this thing called dev mode. And let me come back and look at this command here. So Maven compile Quarkus :dev. All right, that basically puts it in dev mode. All right, that means you now can interactively work with it. So if I come back to my browser over here, let's go over here to localhost 8080. There's that web page that comes up. And I think the default one is just hello. Yeah, there's hello. Okay, so there's a default hello endpoint right there. I'll make that a little bit bigger. But let me switch back over here. You can kind of see where it says path hello. And this is standard JAX-RS syntax here. If I want to now make it say bonjour, I can edit, save, flip over, and refresh. Okay, edit, save, refresh. Let me try that again. So not just and I actually undid my change there. It's kind of funny, I hit the wrong button. So let's go to hola, okay? All right, and edit, save, refresh. Edit, save, refresh. Are we in the right file? Let me make sure I'm in the right file. I think I closed something. Dun, 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 dun. And yeah, okay, so there we go. Let's get the right one. Hola again. And here we go. And refresh. So there we go. Hola. I know that's not the right hola, right? I don't know how to put in the accent. Okay, we'll just do it this way. Aloha. All right, so I'm originally from Hawaii, so let's put in aloha there. So while this might not seem, we're just kind of hello world here, you might be thinking, okay, that's not that spectacular. But here's the idea. You just basically make changes in your editor, you hit save, you refresh. Now, if you're a Node.js person, you're like, that's the way Node works. Exactly, all right? So not only did we have to be faster and smaller than Node.js, we also had to be easier to use, cooler to use, and as fun to use as Node.js. That was a key focus for us. So now I can basically do my Node.js-like thing, but with Java syntax instead. Syntax that I'm used to using, like the JAX-RS technology as an example. Or if I wanted to use the Spring annotations to do something very similar, I could do something like that as well. Now, I just said aloha here. Let me actually go double check my test. Because there are tests here. Let's make sure we get that right. And actually, let's see here. Let's actually go run the test. And let's see. Okay, your test is running. There we go. And so what's kind of neat is the test will run. I have this video. We're going to do the video real quick. There we go. The test will run and it'll tell you it's failed, but it runs at the same time the live reload server is also running, right? So you can run your test at the same time you're running the live reload server. And if I come over here now and basically put in the aloha that I have here, okay, and then hit refresh or hit run test again, we should see that issue go away because we'll now be in a nice happy place from a testing standpoint. And all that is kind of part of this environment, right? So testing as first-class citizen, live reload to make changes. And you kind of see there's a little check mark there that basically says we passed our test. But if I want to add a new class, if I want to come here and add the Burr class, Burr.java, and hit return there, there's Burr.class. I can come back in and say add path again. Okay, and put in the Burr here. And let's get the import statement right. There we go. And I can say add get, and then I can say public string do stuff. And okay, return Burr. All right. Well, can't even spell my own name. Let's see here. Yeah. And okay. Save and refresh. Let's go over here. Oh, we got an error. Oh, because I left off the semicolon. You guys didn't catch me in time. Okay. But that's another nice thing though. You basically get the error messages right here inside the browser. So if you're connecting to a database and you got your connection string wrong, or there's other things that are going on there, you'll see those errors here too. Let me fix this. Let me get the semicolon in place, hit save and refresh. And of course, this was the Burr endpoint anyway. Let's go there, aloha Burr. Okay. Normally I would go on and actually hook up a database and everything else, but my database engine is not running properly on this new laptop. I got to basically fix that up. But anything you can think of from a normal programming standpoint is available to you here. Now I want to show you something else that's actually critical about this. If you're building your environment here, and actually let's do this. Let's actually come back over here. Let's do this. Okay. I'm gonna stop that live reload server. I'm gonna go back to my command line, and let's do a Maven package. Let's see if I can do this real fast. Maven package. All right. So I'm gonna come over here to my Maven command line, run Maven package like you normally would. That's actually going to do something that's kind of interesting all by itself. Something that's a little bit unique about Quarkus versus other solutions that live in this space. It's going to give me a target directory. You notice there's a target directory that also has this thing called a runner. Okay, so that is the thing you run. But there's also another directory called lib that's super important. So let me switch over here and go look at lib. Okay, notice this is where our dependencies are. So basically, instead of making a fat jar, we made a smaller jar. So the runner here is just 21 megabytes, it looks like. Let's see here. I think I can fix that. Is it this one? All right. Oh, sorry, it's 200K. So better if I actually put it in human readable form there. So 200K. So the runner is also very small because a fair bit of what you need, the dependencies are actually in this lib folder. Now this is why this is important. We separated the dependencies from the main fat jar, so the fat jar wasn't so fat. The thing that changes more often is your business logic, not your dependencies, right? Your business logic changes constantly. Your dependencies change very infrequently, and you want these in two different Docker layers. So that's why we did it that way. So, but let me try this real fast. Java-jar, and I'll come back to this directory, Java-jar, target, and Jnation, snapshot runner. Let's go ahead and run that real fast. All right, so there it's up. So curl localhost 8080 and burr. Right, there you go. So it says aloha burr there. So notice basically it started in 0.774 seconds. Started super fast. And so that, again, we focused on making this ultra lightweight and ultra fast. So there's that little application starting in just a very short period of time. Let me try to run it again. There's a lot going on this computer right now. So my CPU is actually pretty well used with the Zoom sharing and everything else. But you can kind of see now it's 0.702 seconds. So that's pretty fast. Okay, so that's pretty fast and lightweight on its own. But let me show you one other thing while we're here. Okay, I want to go over here into this Docker file. And notice there's two Docker files here. One called Dockerfile JVM. And this is kind of where you'll notice some interesting things. All right, see the copy target lib folder there? So the lib folder has to come with the fact jar. All right, so it's going to grab the runner jar and the lib folder, and both those things become layers within your Docker file, within your Docker image. And that becomes important because, again, the lib changes a lot less frequently, right? It doesn't change that often, while your runner is going to change every time. So again, it gives you a faster Docker build. And also when you're deploying across a Kubernetes cluster, those layers get cached. So if you have the bottommost layer cached, then you don't have to worry about copying it from machine to machine to machine in a Kubernetes cluster, where you might have 15 nodes, 20 nodes, 100 nodes, and all those things have to cache that image, as an example. Okay, but there's your Docker file for the JVM mode. But let's look at the Docker file for native. Okay, so there's also native, and it's a little bit different. See how it just says run the application? So copy the runner, no jar file. So to go back and look at the JVM one, see it says runner.jar there? Well, if we look at native, there is no .jar there because it's a native executable. Okay, it's a native executable. So let's see if we can make that work for you. Let me see here. I'm going to go to my history and let's try mvn. Yeah, let's do that. Okay. So what I'm running is another Maven command, a clean package. Okay, but it's doing this pnative, and it's basically saying I want a Quarkus native container build equal true. If you leave this off, you're going to get whatever your native operating system is. So if I'm running on a Mac like I'm running right now, then pnative gives me a Mac executable. However, what I want is a Linux native executable, and that's what this last command is doing. It's actually running it inside a Docker container. Let's see if I say Docker PS, right? You can kind of see there's the Docker image running, or Docker container running, that's doing my compilation now. So instead of having the tools locally installed, I actually was in the process of trying to install the tools locally. So the tool in this case is Grail VM, Java 11 there, but it didn't want to install on this new Mac today. All right, so it was actually giving me some problems. I got to go figure out why. It has to do with the nice security parameters and security capabilities that Mac OS has now. It basically tries to stop downloads from running, and it wouldn't let that one run. And I got to go fight my way through that one. But you still have this ability to run it as a Docker container, right? So in other words, we're running the same tooling, but now as a Docker container, and it'll produce a Linux executable for me, as opposed to a Mac executable, which is what this would have given me. Okay, now this does take a little bit of time. Now, here's why this takes time. What's happening at this moment is every dependency and every line of code that you have inside your application is being analyzed. And what's happening is we are streamlining that so that only the dependencies and only the code you care about, only the active call paths are in the final executable. So to put this in context, if you think of Hibernate, a lot of people probably use Hibernate as a large library. Some people actually feel Hibernate is actually too big and don't like Hibernate as much. But one of the challenges Hibernate has always had is it basically is an ORM for all these different database managers. In other words, I can talk to Postgres or MySQL or Oracle. I can talk to all these different kinds of things. But here's the fun part about that. If I'm using the Hibernate library just to talk to Oracle, then I have all this Postgres stuff I don't need. And if I'm using the Hibernate library to talk to Postgres and I don't have any Oracle, I have all this Oracle baggage that I don't need. So what happens is if the thing is not being invoked, if the call path is not being executed, then that dead code elimination is happening. So some people call this tree shaking, some people call it dead code elimination. Essentially, it's a build time level analysis to figure out what you're using and what you're not using, and making sure that the final product is just what you're using. Now, it looks like it's finished up for me here. It did take some time, but it takes time based on the fact that it's really shaving everything down super small. Okay, and let's go look at that target directory again. There's the runner jar. Let's go over here, let's kind of check that out. Let's put ls in. Okay, let's see the runner jar. So 30 megs. So 30 megs is everything you need. And in other words, you don't need a JVM anymore. It is the entire thing. Okay, it is everything. I haven't tried this in a while. Let's try that. Yeah, it's not going to run for me because it's not a Mac executable. It's a Linux executable. Let's see here. I think sometimes you can get it to show up this way. Okay, it's a Linux executable. See the Linux executable? It's not a Mac executable, so it won't run for me. So what I want to do now, though, is, we have the Linux executable. Let's also run that with Docker. So we use Docker to build the executable. Now let's use Docker to build the Docker image. So Docker build -t. I'll just call this thing, let's just call it Jnation /hello, because that's basically what it is, and -f. And remember, we had those Docker files I showed you earlier. So source main Docker, let's go with the Docker file native and dot. If I did that correctly, it's going to produce for me the Docker image. So there it goes. There's the Docker image. And we got one out there now called Jnation hello, Docker images. Okay, rep Jnation. Yeah, there it is. So now we say Docker run -it -p. We want to map 8080. Helps if you put the P in there, Burr. I switched keyboards real quick right before I started, so that also makes this a little more fun. 8080, and if I did that right, Jnation, hello, and let's see if I did that right. Okay, and let's see, curl localhost 8080, and run Burr. Okay, so there it is, Aloha Burr. So that is in fact the one that is running that we just created, and it's running as a Docker image. Now notice something that actually happened here. Okay. It started, that Java app started in 0.016 seconds, okay? 0.16 seconds, insanely fast, because it's insanely small. Now, this is the native version that was running on Linux, but this is now something that if I decide to scale out across my Kubernetes cluster, if I have 10 different nodes where I need to run 10 different pods, I can run those very easily, very quickly, and scale them out rapidly. Now, I want to show you something else, though, that kind of hopefully really makes the point. So this is the grand finale. If you again, you went back to Facebook and you're updating your status, basically updating your status going, why am I listening to this guy named Burr? I understand that, right? If you're over on social media or you're just reading email because your boss has been emailing you, come back and check this out for 1 second, okay? So this ability to start things super fast is super critical in, again, the Kubernetes context. So I happen to get one of my Kubernetes clusters working over here, okay? And what I'm going to show you is a simple example. We can go into more detail with it in a moment, but let me go ahead and start up. I'm going to basically run some load. Okay, right here I have no pods running in this namespace. So there's no pods running in the namespace called side by side. You can see there's no resources found. I'm going to run a little curl command against the Node.js instance. Let me do the same for Quarkus, and let me do the same for Spring Boot. Okay. So here they come. So here's the Node.js one right there in the middle, container creating, going through its container lifecycle, the pod lifecycle. And then, of course, the Quarkus one is right there, and then the Spring Boot one right there. So it's only been executing now for about 18 seconds. But look, Quarkus just beat Node.js off the starting line. Quarkus is already up. We're still waiting on Node.js. Still waiting on Node.js. Still waiting on Node.js. Come on, Node.js. You will eventually get there, I'm sure. Okay, come on. Oh, and Node.js seems to be really struggling today. Okay, normally it's faster than this. So come on, Node, you can make it. Spring Boot. Oh, Spring Boot even beat Node.js today. Man, all right, there's my Node.js. So this is partly, I bet the reason that actually occurred that way is because I have scaled up my worker nodes on my Kubernetes cluster, and I suspect the scheduler put the Node.js one on a worker node that didn't have the image, and that's why it took so long. But what you will see is, in general, Quarkus runs faster than Node.js. So not only do you get the live reload development experience, and you get a chance to basically work like a Node.js developer in Java, but it also, at runtime in production, is faster than Node.js. And of course, it's faster than Spring Boot and traditional JVM technologies, because here's a key thing to understand. That native executable is not bootstrapping a Java virtual machine, right? And the Java virtual machine is not then looking on the file system and in the class path for all the jars that it's supposed to use, serializing or loading those jars from disk into memory, and then parsing those jars, looking for annotations on the classes that are used, and then building a meta model and a framework that basically says, okay, now we can run the thing you want us to run. All that is bypassed. When I said earlier that we do the dead code elimination, we also basically are eliminating that entire startup lifecycle associated with a normal JVM application that we invented for application servers years ago. So years ago, we had to have an app server that could load an EAR file, which might have WAR files and jar files inside it, serialize and open up all those files, pull them all into memory, look around for annotations across all the classes that we see there, and then of course build that meta model that builds the class loader, builds the meta model, and then of course executes and runs the framework. It was really always the frameworks that were so expensive in a Java virtual machine world, not the actual JVM itself, and certainly not the Java programming language. So if you can actually fix the framework load time and the framework instantiation time, you actually end up with something vastly faster. Now let me also show you this right here. Okay, so we saw Quarkus up and running, and actually I'm going to stop the curl. I'm using Knative here, which basically is a serverless technology that allows you to auto scale up and auto scale down. So I'm going to stop the curl, which basically means it can auto scale down now. But let me actually look at my browser here, and let's see here. There we go. I had this window already up, but basically I'm running it within OpenShift. OpenShift is Red Hat's version of Kubernetes, right? That's what we sell to you on your premises as an example. I mentioned this, we gave birth to this in 2015. Here are these little applications, right? You can kind of see based on the little blue ring that it's up and happy. That's what the blue ring represents. And we'll move that over here. But we have another console that's built right in, and that is the Grafana console and Prometheus data. And you kind of see what's happening here, okay? You kind of see what's happening. And if you look at the memory usage, so Quarkus is using 36 megabytes, Node.js 51 megabytes, Spring Boot 128 megabytes. Okay, so not only is it faster, it's smaller, and that saves you real money in the cloud. When you have constrained resources like these pods are, right, that saves you real money. When you can basically say, oh, this package runs smaller, and not only smaller but faster in this Kubernetes world, then that actually will save you a ton of money, and you kind of see that happening right here. Now, here's what's kind of cool. If I speak long enough, oh, I did. You can see it scaling down now. So there it is. It's basically now ripping those pods down. They're going away. And of course, the scheduler is saying, okay, there's no more work to do. Knative said no one's using those things, and they went away. Okay, so let me actually come back here and let's bring it back up again. Let me try my Node.js one more time. I don't want to be unfair to it. And my Quarkus one more time, Spring Boot one more time. Okay, so bring those guys up. So there they are. They're being scheduled out there, container creating. All right, Node.js got up first this time. Quarkus right there with it though. And here, let's go. We're kind of, come on, Spring Boot, you'll get there. So again, it depends on which node it scheduled it on. So you will see a little delay there with container creating, which actually means it's doing a Docker pull. And in many cases, that worker node. If I come over here and say Q control get events, then it becomes much more obvious what's happening here in this namespace, side by side. Side by side, that is what this is, okay? You'll see the Docker pulling and pulled there in these event listing, okay, among other things, okay? But that's up. And again, if we come by, look at our memory usage again, just kind of monitor it and see what happens there. All right, and hit refresh. But you can kind of bounce this thing up and down and then kind of check things out. All right, so that's just the way you would look at it. And I'm looking at the CPU request, CPU limits. Doing pretty well from the CPU standpoint. You can see it's 1/10 of a CPU versus half a CPU. And so Spring Boot, 134 megs RAM in this case. And then my Quarkus running in that 30 meg range, Node.js in that 50 meg range. Okay, but your mileage will vary. You can kind of play with this on your own. You can kind of give this a try. But the whole point of this is that you can basically make Java fast and small. Java super fun to work with. Again, you edit, save, refresh. And let's hit this. There we go. There's a little thing over my screen I can't click correctly. Edit, save, refresh. And you have all the benefits of using Node.js, fast, small, awesome to work with, but it's Java and the Java ecosystem you're working with. Now, one thing I'll make a quick notation on, if you come over here to the Quarkus website, go to quarkus.io, the number one question is, well, what has been made fast and small from the Java ecosystem? So we call these things extensions, right? So you can add extensions to your environment. If you have the Quarkus tools, there's a Quarkus tool for Visual Studio Code that add extensions. But essentially, these extensions go into your POM XML like normal things, but these things have been optimized to be fast and small. As I mentioned earlier, frameworks tend to be the biggest culprits which make us fat and slow in the Java ecosystem. The framework is doing all the file scanning. The framework is doing all the metadata scanning. The framework is building the meta model and taking all that time at runtime. And so we've gone in and we've optimized things like Hibernate as an example, right? To basically be fast and small. We've gone in and optimized things like Infinispan. And if you're interested in Kafka, Kafka streaming, Neo4j, MongoDB, Amazon DynamoDB, right? So different forms of security. A lot of your Java E syntax and microprofile syntax, so microprofile implementation, things like your Spring DI, Spring Web, right? So a lot of the things they're used to using are already here and have already been optimized for this use case. I know we're running at the top, we're running close to the very time limit here. So let me pause for a moment and see if Roberto, if there are any questions or anything you want to throw at me kind of on the fly.
Hey, Burr. Yeah, I mean, awesome presentation as always. It's quite hard to keep up your speed. You're always so great with that. Yeah, we do have a couple of questions here for you. So let me grab a couple. So this is coming from Luis Vaz. So he's asking, can we import non-Quarkus libs with Quarkus?
Yes. So I mentioned right here that we have all these extensions. If it's not an extension, meaning it's not been optimized, then it may not compile to native like you saw me do here. You may just simply import it in your POM XML. Okay, so where did that thing go? Over here. If I go to my, POM XML, I just want to open this thing up in the right place. And where's my POM XML? Okay, it is a POM XML. And if you leave yourself in a normal Java world, JVM world, then if it runs in a JVM, it runs in a JVM. It's a simple answer. But it's not optimized for going fully native. It's not optimized for being fast and small. So I like to think of it like this. If it's not optimized, it's kind of like eating donuts. I love donuts. You probably love donuts, right, Roberto?
Of course.
Yeah. So donuts are awesome, but it's not optimized for fast and small.
Yeah, who doesn't love no donuts, right? Yeah. And plus, let me just add one more thing. Not only about that, but if it's not a Quarkus lib, most likely it's not going to work with hot reload as well.
Good point. I haven't tested enough of those to see if the live reload would have an issue with some of the older libraries that are out there.
Well, it depends. Some work, some don't. But at least to make sure it works, you need to be from the Quarkus universe, right? Okay. So another question coming from Binath. He's asking, since Quarkus is compiling everything up front, is it using JIT?
So you use the JIT, and if you're in JVM mode, you're using the JIT, right? So in other words, that is still happening. If you're using Grail VM and compiling down to native, then no. Okay, that's done in advance. It's done before the runtime environment.
Yeah, and then we have a couple of the questions here. One from Wesley. He's asking, so Quarkus native build takes some time. Should we be concerned about it when we have a bigger production code? What do you think about that?
It does take time, and you do see the time increase as you have bigger and bigger code bases. This was optimized for the serverless and microservices use case, though, so you shouldn't have the million-line project necessarily in a single code base. But you will see that build time does grow as the code base does grow.
Yeah. Then we have a couple of other questions here. So this is coming from Sofian. So what type of garbage collector Substrat VM native image uses?
Yeah, so I forget the name of what Grail VM calls as their garbage collector, but Grail VM does have a garbage collector built in. It is I'm just kind of seeing what it says here. And maybe you know, Roberto.
I don't remember the name as well.
Yeah, so there is a garbage collector built into Grail VM, and that's what's being used for it. But it's not all the various garbage collectors that are available on the JVM side. So if you actually have an application that it really leverages the garbage collector, meaning you're constantly creating tiny little objects all over the place and then abandoning them, orphaning them, then yeah, it could very well be that your application runs better on a JVM mode as opposed to this native mode.
Yeah, I think we're done from questions for now. Not sure if you have anything else that you want us to show us.
When I think we're right at the top time frame too. So one thing I'll just point out to you guys, okay, do check out the website. You will see that there's we have the different benchmarks that show it's faster, smaller, things like that. The link to the presentation is bit.ly, right? Quarkus Java. That'll get you to Quarkus, this slide deck, so you have access to the slide deck. Because I know you really want to come back and see my awesome Brandy Chastain imagery here, right? Because you want to promote women's soccer as well, right? That's what you'll want that. But at the same time, you want to come check out these other things that are here, like Cogito, which is business rules and business processes that have been made super small, super fast for this new world. If you're interested in reactive programming, there's some information about reactive programming. One really thing I love about the reactive programming is incoming and outgoing. It's super fun to use that. And you can use that with like a Kafka-based backbone as an example there. So just some more content that's available to you here that you might want to check out and can be a lot of fun for you to look at. I have links to examples and things of that nature. So get access to the slide deck. I can see people already started joining. Actually, I can see their icons showing up here now. So
Yeah,
it is
that's
a
wonderful.
live deck. Do that. Follow me on Twitter. Feel free to ask me future questions on Twitter or send me an email. I'm just burr@redhat.com. That'll find me.
Wonderful. I'll just give you one last question that we just got here in last notice. So earlier today, so actually it was Elder. He mentioned that RHEL-VM is not native build is not recommended for long-term lifecycle usage or application usage. What do you say? What do you have to say about that?
I think so. That has come up many times, and it has to do with the garbage collector again. So we mentioned the fact that there's the garbage collectors within a RHEL-VM native image, or the garbage collectors one, is not as sophisticated as the one in the JVM. So again, so you just have to think about how much garbage you're creating and how much has to get collected. And it really will probably depend on your framework more than your code. Business logic typically does not create a ton of garbage, meaning objects that are no longer being used and eventually have to get collected. So that's really what you would have to look at. So get your profiler out, check out what's running in your heap, and that'll probably give you more information about should you try the native and its lesser garbage collector versus the JVM mode and its stronger garbage collector for those long running processes, definitely those multi-month processes, probably more on the JVM side.
Okay, wonderful. I think we're pretty much done over here. So thank you again, Burr, for this wonderful presentation. It's really a pleasure to have you here all the time. So hope that you stay safe, and hopefully we'll see each other again pretty soon.
In the real, not just
in the
online.
real.
In the
Yes,
real.
in the real.
Well, thank you so much for having me, and hopefully people enjoyed the presentation. Again, feel free to reach out to me on Twitter or email, and I'll get more of my demos running. We'll have some more stuff to show you at some point.
Wonderful. Cool. Thank you very much.
Thank you.
Yeah.
Bye now.
Bye-bye.
Hello.
Olá, bem-vindos a Lisboa.
Bem-vindos a Lisboa. Willkommen.
Hi. Hi, everyone. Thank you again for joining us for Jnation Online 2020. This is our, I believe, 10th session of the day, so we're getting a little bit tired, but we are really grateful for all the audience that's been here for us since the beginning, and of course, everyone else that joined in the meanwhile. So for this session, I'm going to have two speakers. Going to have Robert and Ray. Hey, Robert. Hey, Ray. How are you guys doing?
Yeah, doing great. How are you?
I'm okay. Thank you so much. I mean, I've been asking all of these to all the speakers, but I mean, it's being really unfortunate that you guys couldn't came to Portugal to the presentation here. But hopefully we can bring you next year if things get better.
Let's hope so.
Yeah.
Absolutely.
Well, Ray has been here last year. Actually, no, not 2 years ago. So he knows how it goes.
It's awesome.
Yeah. So anyway, Robert and Ray, I've seen this presentation before. I really enjoy it because they I'm not going to spoil it, so you're going to see it, but they're going to do a very entertaining session, and they're going to talk about Maven, right? So without any further delay, let me give the word to Robert and Ray. So please feel free to go.
Okay. So yeah, this is gonna be really interesting. Partially because I'm in New York and Robert is in the Netherlands,
yes.
and we're presenting to Portugal. So we'll see how internet works today. And I'm a developer advocate for Google Cloud Platform, and I like to bring some of our technology to developers all over the world. And you might be asking, well, what does Google Cloud has to do with, all of these dependency problems? Just a very quick overview of why I'm here. Partially it's because we do have many client libraries for people to use to access our services. And in the past, some of these client libraries have a lot of dependency conflicts that our users are having hard time to use two different client libraries together. A lot of these things have been solved over the past couple of years, and I've been part of the team solving it. And what I do usually is to just ping Robert online and say, hey, Robert, help me out. So today's presentation, most of it is just going to be me asking questions, but we're going to reconstruct all the issues that I have faced in the past and how we documented all the changes. And hopefully today is going to be useful for you as well. You can find me on Twitter at Sanadism. And very lucky that Robert is also here. So happy that he's here because I get to ask him all the questions.
Yes. So my name is Robert Scholte. I became a Java champion last year. Very proud of that. And most people know me as the lead of the Apache Maven project. But I also did some work for the project Jigsaw, so the whole Java modular system stuff. So I provided some specifications, asked for changes, and so on. So, but that now is the project has been completed. So now we're back in business for Maven itself. And of course, it's like Ray already said, it happens sometimes that we're having issues, and then he calls me, and we have this Nice puzzle. So this session will be about a couple of puzzles and how to solve them. So let's start.
Yeah. All right. Yeah, and all of these puzzles were real puzzles that I have to figure out as well. And together, I asked Robert to help me out. So we were going to see all the issues that you probably face as well. So let's go ahead and take a look at the first example here. The first example here is a very simple example where I'm using a translation API library from Google Cloud, and I'm simply just translating from one language to another, in this case from Mandarin to English. And I'm using Truth, which is a library that has assertions. Right? It's one of the many libraries that has assertions. So in this case, we're using Truth. Okay. And as you can see, this test is very simple, very small. And same thing with the dependencies. If I go to my pom.xml, I only have two things here. We have the dependency on Truth and a dependency on the translation API itself. And that's it.
Well, that's it. So the first thing that I notice is you're saying that Truth is an assertion framework, right?
Correct.
Correct. So you will only need it during the test.
Yeah, right? Yeah. In my case, yeah, definitely only the test.
Okay. So why doesn't it have the test scope?
Ooh, well, that's a good question. I definitely forgot to do that, and I think that the scoping is one of the most important thing that everyone has to even to start thinking about even before running into dependency issue. Especially if you are creating libraries, make sure that you scope everything properly so it doesn't bleed through to the other users of your library as well. So in this case, Robert, do you say that we should put this in test scope then? Let's do that.
Yes.
Yeah. So that Truth is only used during test, but not all the other scopes as well. But you can see there are actually many different scopes here. If you don't put anything, what is the default?
Right. The default is compile. And compile means that it will be used during compilation, but it will also be available at runtime.
Yep. And so if a user depends on your library, this will be a transitive dependency as well. So that could be one of the issues. But even before we run into any issues, the first thing to do is to make sure that you don't allow dependencies to become transitive dependencies when they are not necessary for your users. Right. That's number one thing to do.
Excellent.
So okay. So let's fix the scope thing and let's run this. Right. It's only two dependencies. Everything compiles in Java. If it compiles, it runs. Right. So let's go ahead and run it. And I'm going to use the run here and just do a simple run. And, ooh, interesting. So of course this doesn't work. And that this is the error that we're seeing, which is the no such method error found. And I think this is where we see a lot of the dependency issues manifesting themselves as symptoms. These are symptoms of something has happened in your dependency tree so that the classes may not exist or that there are some version conflicts. And the errors manifest themselves as no such method error, no such field error, no class def found. We usually ask the people in the room how many people have seen this before. I think everyone who uses Java may have seen this in one way or another. And they are errors because they are irrecoverable. They're not exceptions. They are actually errors because the JVM, nobody knows what to do in this case anymore. Okay. So how do we actually find out what's wrong here?
So, well, this is a sign that something was using a different version of a class. So what I expect is that some code was compiled against this method, and for some reason now there's a different version of this preconditions class on the class path.
Okay. Yep. And based on this package name, we may need to be able to figure out, well, which artifact does this actually contain this class, right? Because that will help us to narrow down the issue even further. How do I actually do that?
Well, of course, in every IDE, you have the support to discover where it's coming from.
Okay. And here we can see that, okay, so there is, this is actually coming from Guava. So if I come to the IDE and see the classes, you can see that this is coming from Guava. Guava is very, very well known and adopted in many, many different places. But because of it, dependency conflicts also happen with Guava quite frequently, in addition to other issues with the way that Guava has dealt with the versioning in the past. We're going to go through some of that later. Okay, so, but we know this is Guava. But how do I know why this is happening, right? Why did this actually cause an issue? And for that, I'm going to go to the terminal. One of the things that I usually do, oh no, what happened to my IntelliJ? Uh-oh.
Oh boy.
Wait a second. This is by the way, this is live, and I think my IntelliJ and my Chrome just fused together into one.
Oh, really?
Yeah, I don't know if you see this, but this is just, I think they literally just fused together. And here's my Chrome. Oh, here we go. So here's my IntelliJ again. Whew, that was that was a
there you
little
go.
scary. This is the first time I've ever seen this. So if I go to my application here, and one of the things I usually do is to see the dependency tree, right? Because I want to see what dependency is actually being included. So I'm going to say Maven dependency tree, and okay, there's actually quite a lot. There's quite a lot of things in here for just 2 libraries. But I don't see anything out of the ordinary here, right? For example, if I do a grep for Guava, because this is what people do, right? I'm looking for Guava configs. I only see one. Like there's only one version here.
So what you see right here is the resolved tree, as we call it. So these are all the versions of conflicts are already resolved by Maven. So in this case, what we are looking for are the original versions. So what you can do is add -D verbose, or verbose is true. It's exactly the same.
Okay.
Yeah, and this will give you more information.
Wow, look at that. So this is really interesting because previously everything was really clean, but now we're seeing all of these additional information that Robert was mentioning. So for example, here we have Guava, but it was omitted for conflict with 28.0 version. So what that means is that even though it was trying to use Guava 19, but it was omitted because there was another version of Guava in this tree. If I go back to my presentation here, what happened is that we have now 2 versions of Guava. Now, how do I actually figure out who are actually pulling in all of these different versions, right? So previously I did the grep with the Guava. And if I do it this way, right, I can see that there are definitely different versions of Guava, but this tree looks really weird now. This tree looks like a Guava is including Guava, which is including more Guava, and that's including another Guava. That doesn't make any sense.
No, absolutely not. Now, this is, of course, because of the usage of grep.
Okay.
And Maven has an option to give you the proper tree. And you can do that with the -D includes. And then you can specify the group ID and or the artifact ID.
Okay. So if I really want to see Guava usages here, like to see who are transitively importing Guava here, I'm just going to use include. And the nice thing about include is that it keeps the contextual information on where it actually came from. So in this case, I can clearly see that this Guava artifact was included by protobuf, which in turn was included by GAX, and then the translate API, and so on and so forth. So this was very, very clear. So that was one of the best tricks I learned from Robert to troubleshoot one of these issues. And but we can clearly see now we have 2 versions of Guava. Actually, there are many different versions of Guava. We have 26, 28, and 19. So what happened here is that we need to kind of pick only one to use, right? Because there are multiple versions of Guava, and we can only have one. And this is where all the diamond dependency problems actually come into existence. But why can we only choose one?
Right, this has to, for this you need to understand a little bit how the class path works. So the class path works, it's in the end a list of jar files. And when Java is looking for a specific class, it goes from the first jar to the next until it hits the specific class for the first time. So if there are duplicate classes, it will ignore all the other ones. So it will only pick up the first. So in that case, it doesn't make sense to have multiple versions of Guava on the class path. So that's the reason why there's only one.
Got it. And so how does Maven pick only one then? Because there are many different ways to kind of figure out, well, which one do we include, and how does Maven actually do this?
Right. So what Maven does, we say that the nearest dependency wins. So if you specify dependency in your POM file, we call it the direct dependency, and let's say that's level 1. But that dependency can also have dependencies, of course, and that's level 2. And you can go quite deep. And Maven will go through the whole tree and will find the nearest dependency, and that version will win.
Right. However, that version may or may not work with all of the other artifacts that's trying to use the same dependency, but with a different version, right? And that's where these conflicts exist. But I think one of the most frequently asked question here is, why doesn't Maven just pick the newest one? Because the newest one is, usually the best one, right? Or maybe not.
It depends. So Maven doesn't really understand Semver, so the versioning system. And so what Semver says is that if you increase the major version number, you are allowed to break the API, right? And that's kind of weird because what we are saying is that all your code should be backwards compatible. Otherwise, it won't work. So the highest version is not always the best version. It can break backwards compatibility or whatever. So the best way to ensure that you are using a specific version is to define it in your own POM file.
Right. And I think that the other thing for me was that as a library maintainer, it's actually the best practice to truly understand what versions are you truly depending on, and that you're exporting it to the end user. If Maven was to choose a version for you, then you need to understand all of that logic, and the logic can be even more complicated. To me, I actually like the simple approach, which is the nearest one win, because I can always overwrite the nearest version. I have full control over it.
Exactly.
I personally like it quite a bit. Yeah. Cool. So, I just revealed the answer. As what we did in rehearsal. But the question to this is, well, some of these examples that we're going to show, right? There's no compilation issue. Everything compiles fine. You can do all the stuff here, but it manifests itself during the runtime, right? If you're lucky, you find it during the test. But if you're unlucky, or if you don't write test, then you're going to see this when you run the app. And if you're even more unlucky, you're going to see this in production environments. And the problem here is how do you actually reconcile some of these issues and remedy it so you can reduce many of these risks? So in our particular case, how do we actually reduce our risk here to make sure that we don't run into one of these issues?
Right. Ideally, you want to have all your libraries use exactly the same version of a dependency. In this case, you're only specifying two versions of two dependencies, so that might be doable. But in general, it is very hard to have exactly the same Guava version throughout the whole dependency tree. So this is one approach, and the other one is to say, okay, we are going to look for the highest version, as you were saying, or the latest. And for that, we have a plugin, and it's called the Maven Enforcer plugin. And with the Maven Enforcer plugin, you can enforce really things. So if you are thinking of reasons why the builds should break, you should always have a look at the Maven Enforcer plugin. And it comes with a huge set of predefined rules, but you can also write your own rules. Well, let's start with this one. Okay. So this one is the dependency convergence, and this is the rule that says that every version should be exactly the same for a specific dependency.
Yeah, and the Enforcer plugin is actually really nice. And according to a recent survey by Andres Amire on Twitter, right, there's very few people who actually knew the existence of the Enforcer plugin, but they can actually do a lot of the static analysis or your dependency analysis before you even need to compile your application, right? So this is really neat. So I just added the Enforcer plugin to enforce dependency convergence. What that means is then all of the versions of all my dependencies and transitive dependencies has to agree. And if I are now to do Maven verify, what this will do is to also run the Enforcer plugin, and it quickly tells me that, wait a second, all of these libraries, all of these artifacts, they have different versions that Maven ultimately would have to resolve. And any one of these things could have caused a dependency conflict during your runtime. Right? So like here, we got API common 1.8.1, and there are other versions in there too. JUnit they're disagreeing, right? And ultimately, or truth is disagreeing as well. So ultimately, all of these conflicts will cause issues, or maybe causing issues. Yeah. And what was the other one that you mentioned? The upper bound, right?
Upper bound.
So requires upper bound. I think that's the That is the way to specify the rule,
Yeah.
I think.
So this one relies on backwards compatibility.
Right. Yeah. So this one makes sure that you have the newest version of an artifact being used. But in our case, this also didn't work because the newest version actually was also breaking other dependencies too. Right. So I think this goes back to Robert's point where, if you even try to use the newest version of everything, but if the newest version is not backwards compatible, then you're still going to see issues because you really just have to reconcile these library versions yourself in that case. But at least we can catch some of these issues early.
Exactly.
Okay. Yeah, so let's move on to see what else we got. Now that we are running the upper bound or convergence plugin, so Maven is catching all of these issues. But now, how do we resolve these issues? How do we get rid of these duplicate dependencies or the different versions that we have?
So there are actually two solutions. So the first one is by using exclusions. Every dependency has also the option to say exclude my transitive dependencies, or the ones that are being defined by group ID and artifact. So this is an example, and here you say, okay, I will use truth, but I want to exclude the specific version of Guava that is being used by truth.
Yep. Okay. And we can also do that with other things too. And as you resolve your tree to get rid of this enforcer arrow, what you're going to find is you're going to add more and more exclusions so that you end up with just one set of dependencies with no duplicates whatsoever. And then you have a very clean tree in that case. So for exclusions, we literally can get rid of some of the transitive dependencies so that Maven only has one to choose. So we're doing the resolution for Maven manually.
So there's one danger here. Suppose that we say, okay, our example one is not going to use translate anymore. So we are going to clean up that dependency. Truth is still needs Guava. So that's one of the reasons why I prefer not to use exclusions. But instead, I would use dependency management.
Dependency management. That's interesting. What is that? Because I think that's also another really useful feature that is not widely adopted by all the libraries out there today. So how does that work, and how do we use it in our case here?
So dependency management is, in the end, a lookup table where you can specify some global definitions. So the dependencies that you specify here are not yet used by the project. It's just a lookup table.
Yeah, so one of the common thing mistake was to confuse the dependency management section with the dependencies section, right? They're very different in the two, even though dependency management contains dependencies, but it doesn't actually pull in the artifact into your application if it's only declared here, correct?
Only the ones that are specified as dependency are the ones that end up on the class path.
Right. And so why does this help in terms of our situation to reconcile the versions of, say, Guava in this case?
So based on this, what Maven will do is, if it sees a specific dependency, it will also verify if there's some specification in the dependency management as well. And in this case, it will use this, it will pick up this version.
I see. So anywhere in my dependency tree now, in this project, that has the group ID of com.google.guava with the artifact ID of Guava, they will all be overwritten with the version of 28.1 in this case. I see. So we can also verify this very quickly. So if I were to go back here and go to example, let's see, what did I change it? 3 with depth management. Oh, sorry, 3.
Example 3.
3B.
Minus dash. All right.
Yeah. And if I see the dependency tree again, and then let's do dverbose, and also let's use a new trick here with the includes, which is, we can include just google.guava, guava. Then what we're going to see is that every single version of Guava, even in the transitive tree here, their version O has been managed up. So in this case, even for this library, their transitive dependency now becomes Guava 28.1. because we specified it in the dependency management section. And with the dverbose, you can clearly see that this version has been managed up from a previous version as well. Okay. So that's really cool. And you did mention that this is a lookup table. So this actually does not resolve the dependency itself, right? So you can actually put in anything that you want. Is that right?
Anything, yes.
So I can say this is Robert's awesome library, and this will still work.
Yes, maybe we'll accept it. So there's
Yes,
also
this will accept it. Yeah.
There's also a danger in this, because the version, you could add snapshots there.
Ooh, so here you can add snapshot, and that is not good for anyone.
No, so you can release this, and Maven will say, okay, this project depends only released versions, but in dependency management it has a snapshot. So
I see.
I would also say never add a snapshot to dependency management.
Never add snapshot to dependency management. That's a very good advice as well. Yeah. So with dependency management, what you can use it for is to be able to manage the versions either for your direct dependency or even your transitive dependency, so that their versions can agree. And now Maven would not need to choose any versions whatsoever, and you should be okay even with the enforcer rules. Now you can actually have dependency convergence everywhere. Okay. Now for the upper bound rules, though, it's very important to remember what we showed earlier, which is that the newer version may actually break the older version. So in some cases, the upper bound may actually not work. But if it does work, it's when the higher version are backwards compatible. And for that reason, we actually have documented a number of rules that's really, or best practices rules, that's really important for client library developers. So this is called the GLBP, the Google Best Practices for Java Libraries. And there are many rules here, and these are all of our learnings through resolving many of these issues that we have had in the past. And so two rules here is GLBP 7 and 10, which is saying that make the breaking transition easy. So always make your API backwards compatible for as long as you can. But also GLBP 10, which is to maintain that API stability for as long as possible as well. This way, people can upgrade to the newer version of library without fearing it to be broken. And for that reason, Guava 21 and up, they are all backwards compatible now. Guava has been following Semver for a long time, but however, it's like Guava 10, 11, 12, where they're always breaking backwards compatibility. That's why the version keeps on incrementing, right? But starting from Guava 21, now we have backwards compatibility because of our work that we've been documenting in these best practices. Okay, cool. Now, if the upper version does break the lower version, right? So for example, Guava again is used everywhere. I know that Hadoop uses Guava a lot, and Hadoop uses a very old version of Guava. And sometimes our users bring a newer version of Guava, then they cannot work together. What do I do in that case?
So in this case, the Guava version is picked up from Hadoop instead of your own library or your project. Wow. Well,
yeah. That's hard. That's what happens
very
every
hard.
day.
Yes. So
yeah.
If you're not in control, then the last solution you can do is using the Maven Shape plugin in combination with relocation. So this is actually a very interesting trick. What you can do is you can say, okay, I want to specify a pattern. Let's say the Guava package, and you are going to relocate it to a different package, for instance, or .shaded.guava or whatever. And what this will do is, after compilation, it will go through the bytecode and it will replace all the references to Guava with this new shaded package name. And because of that, there will be no collision anymore with your code and Guava and the Guava that's being used by Hadoop.
Right. Yep. And this is by far one of the most effective way to really, just avoid all of those conflicting libraries, especially in Hadoop. However, also this might, embed some of the libraries directly into your application as well, which will, potentially increase the size of your app. But also potentially that if you need to upgrade any of these dependencies, you also have to reshade. So you have to keep your application up to date and rebuilding it to make sure that they are shading the newest version of these libraries.
So
But
it's not that
overall, I
easy.
think it's a really good solution.
Yes,
Yeah.
yes. So it's not that easy as just saying a newer version of dependency in your POM file. You have to do a little bit more.
Right. What about class loaders? Because that's another trick that a lot of people use, right? Because ultimately what happens is that in the class path or in the single class loader, there are duplicate classes where one of them is being picked up or the wrong version is being picked up. What if I do need to have different versions of something?
Well, it all depends a bit on the kind of application you're working on. So let's take Maven, for example. It has a huge number of plugins. Everybody can write its own plugins, and it works pretty well together. And not everybody is using exactly the same version for Commons Lang or whatever. And that's because Maven uses class loaders. Every plugin has its own class loader, and because of that, all their classes are isolated from the other plugins and from Maven itself. And based on that, it's very cool to isolate all your classes and to not have these class collisions.
Right. But I think what you mentioned earlier was really important, which is it depends on your application as well, right?
Absolutely.
So if you're writing a library, a class loader may not make any sense because you don't want to class load your own library differently. However, if you're writing a server or a some system with a plugin, right? Imagine like Jetty or Tomcat that may actually run multiple war files or year files, but you may deploy multiple applications into the same application server in the same JVM, but they are able to load these classes differently because of the different class loader that they have, right? So be careful with that one as well. Okay, cool. Now OSGI, the last one I want to mention, that's really just an extension on how to make the class loading easier. But to be honest, I don't really know who uses OSGI anymore. So apparently it's a good solution, but I just haven't seen this being adopted a lot. Okay, cool. So let's see what's next. The other best practice here is that GA libraries should not depend on non-GA APIs. So in some of our libraries, we do specify like unstable API or beta API or internal API. Just don't use those because they are meant to change very frequently as well. And also that when you do upgrade the versions, especially if you have breaking changes, what you also want to make sure is that you may want to relocate the package name or the artifact ID as well. Now, for this one, this is really interesting. Robert, if you're still there.
Mm-hmm.
Yeah, good.
Yes.
Yeah, I think you mentioned quite a few examples for this practice as well, right?
Exactly. So here, what you see is Commons Lang is my favorite example. So for Commons Lang 2 and 3, they had to change some new things because, for instance, they were using Java 7, and it comes with new features in the language. And what they did is they introduced a new artifact ID, but they also introduced a new package. And because of that, it is possible to have Commons Lang 1, Commons Lang 2, and Commons Lang 3 living next to each other because there's no collision because of their unique package names.
Yep. And I maintain a library called JDeferred, and I was being advised to do exactly the same thing. And so for this library, we have version 1, which is under JDeferred, and version 2, which is under JDeferred 2. And people can also use both of the version at the same time as well. So that's really useful.
Yes, it really depends on what kind of application you're working on. So if you're working on libraries that are very, very popular, this is a good practice. If you're working on an application, which is in the end not a dependency for something else, there's no need to change your package or your artifact.
Right. Yeah. So let's see the next example, 3E. This is exciting because we're moving on to the next question for Robert. Robert is like a detective trying to figure out what's wrong with the Maven resolution for me. So let's see what happens here. So I'm going to show another example here, which really just sends up a pub-sub message. So pub-subs are message publish and subscribe service, and this only publishes one message out. Again, this is one of the older APIs and older issues that we had to resolve. And in my pom.xml, we can see that I'm having the dependency here. I'm also pulling Firebase, again, the older version of that. And I'm following the best practices here, right? So I have my enforcer rule, I'm requiring upper bounds. I want to use the newest version of everything. And then we have the dependency management section here to help us to see what's, to help us resolve all the versions to the right versions. So now let's go ahead and try this out. So I'm going to go to example 3E. And the name kind of give away the little hint here, right? So if I do Maven verify again, so we're going to see there's no enforcer issue, but we got yet another issue here. What is going on? And look at that, it's Guava again. I thought I resolved this previously.
That's interesting, right? And this probably means that we're again using a different version from the class file, a different one than expected.
Yeah, but I have my upper bound. I got my Guava managed, right? Just like what we talked about earlier in this case. And we can even go and see the dependency tree as well. So let me go ahead and do Guava here, Guava. So I'm going to say a Maven dependency tree verbose includes Guava, right? Exactly what we did before. And we should be able to see that all of the versions actually agree, right? 28.1, 28.1, right? All of them are being overwritten. So I don't see anything else wrong here.
Okay. Could it be that the class is duplicated somehow?
You mean in another artifact?
Yeah, in another jar.
In another jar. So so if there's another jar, another Maven artifact that has exactly the same classes that happens to coexist with the one I already have, then again, because they fold into the same class path, only one of them will be picked up, and it could be the wrong version. Okay, so that's interesting. How do we actually find this out? So we kind of know this is Guava. So I think the trick here is just to remove the artifact ID, and let's just use the group ID instead. Yeah, let's see what happens. And let's see here. Again, but then you can see like this dependency tree is very long. One of the best practice, of course, is for library maintainers to reduce this as much as possible, because this really becomes really hard to see what's going on. Do you see anything that jumps out at you, Robert?
Not yet. Can
you if you're reading every line. All right, you go from the bottom, I go from the top.
Oh, yes. Maybe we should, I think you did the verbose as well, right?
I did, yeah.
Yeah, so maybe we should remove that one. Oh, you already found it.
Yeah, yeah. So in that case, let's remove verbose and see if it's easier to read as well, because that might actually be better in this case. Because now we can actually see very clearly. There's actually a Guava here, but there's a Guava JTK5. What happened here?
Well, I think in the past, people were making different versions of a specific jar file, and they were using different artifact IDs.
Right.
So at that time, it looked like it made sense, but right now we're just having issues with it.
Yeah, because when they are at the same artifact ID, then Maven knows that they are the same thing, and so they will try to resolve and pick only one version, right? However, if there are different artifact ID, in this case, Guava and Guava JDK5, Maven does not know that they are exactly the same thing, and so they'll put both of them onto the class path.
Right.
Yep. And we know it wouldn't work, so that's not good either. So and this again will only happen during the runtime, and we need to resolve it during the compilation time. And Robert, any recommendations on what to do to make this simple when we are building the application?
Right. So it looks like we solved it within a minute, but it took us a little bit more time. But what you can do is you can have this enforcer rule, because again, what we want to enforce is we don't want to have duplicate classes. And this one, as you might see, it is not maintained by the Apache Maven project. This one is maintained by Mojo House. It used to be Code House Mojo, but this also shows you that it is possible to write your own enforcer rules, and you can add this to your project. So what happened is here you see the dependency, and this dependency contains the extra rules you want to add to your enforcer plugin.
Yep. So let me add it to the application too, right? Because this one definitely we found it early, fast during the talk, because we knew exactly what was happening. But in real life, this one took a while to kind of figure out because the dependency tree was so deep in our real cases. So let's go ahead and add this plugin here and see what you actually get out of it. So here we added the new plugin, and let me do a Maven verify again. The key here is to always try to avoid the dependency conflicts during the runtime. You want to detect it up and front and early during the build time. So with this plugin, we can see all of these classes are being duplicated. All of them. All of them. Oh, well, it's still going. Wait, hold up. How much more time do we have?
Almost.
Wait.
Oh.
There we go.
There we are.
This is the thing I'm interested in,
Yes.
which is the 2 jar files or the 2 artifacts that actually causes the issue.
And in this case, we're lucky that they're in the same group ID. But it can happen that if you use the Maven Shape plugin without any configuration, it will create a fat jar, including all the dependencies. And if Guava would be one of those dependencies, it would be in that jar as well.
Right. Yeah, I actually have seen this happening in one of our other SDKs where they did shade, but they didn't do relocation. So there is actually potentially issue with some of the API that's being shaded that since has newer version, and it becomes really hard to reconcile at that time. So yeah, and for that reason, we also have a rule for this also, which is that 2 artifacts do not have overlapping classes. This is so important, and this is a JLBP rule number 5 that you should avoid. But I know, Robert, you mentioned something else that was really important too, especially with the module system.
Right. So with Java 9, we have the Java platform modular system, and it introduces the module path next to the class path. And the module path is the same as the class path, but it comes with extra rules. And one of those rules is that packages should be unique per jar. So you cannot have the same package in different jars. And this is what we called the split package. And this is one of the main reasons why a lot of people, a lot of Java projects are struggling to switch to the modular system. But the cool thing is that your code won't even compile if you have a split package issue. So the things we were seeing right now, it won't happen with the modular system.
Right. So just having Guava and Guava JDK5, like that would have never happened in the module system in the first place. Then. Yeah, that's good. Yeah. So maybe that's a good reason to adopt the module system. I just haven't seen this used. Yeah. And also that Guava JDK5 is from very old version of Guava. And so some of the libraries didn't keep their dependencies up to date. If they did, they will find that JDK5 variation is gone, in which case it would have used the right version. So we also have a rule here to say keep your dependency up to date. Now everyone's using GitHub. I think that there are really good automated ways and bots that can actually keep your dependencies up to date. I use one myself, and that's been really helpful for me too.
Yeah.
Okay. Let's see example 3C. What is 3C here? Ooh, this one's fun. This one's really fun. Again, the thing kind of give away, but well, you're going to see why this is the case. So this is yet another publish subscribe client with a different version. You can see the API actually has changed a little bit. But then if I go to the POM, let's see here if I can compile this real quick. See the example 3C. Yeah, and let's do a Maven verify again. Again, I have the best practices here. We got the enforcer plugins, we got dependency management section, and the enforcer rule just caught something for me. So this is the require upper bound enforcer rule, and told me that, hey, look, you got 2 versions of gRPC stub, and the older version is being used. So you should probably use the newer version here, which is 1.10.1. So now I go back and think about how do I actually do it. We can use exclusions or we can use dependency management. So I'm going to use dependency management to bring up the version to 1.10.1. Okay. So now the enforcer rule should pass. I know I'm using the newer version of something. But if I run the test again, Robert, it's happened again. What is going on here? I'm following everything that you said so far, but this is still happening.
Well, so it's quite clear, right? So the class is missing.
So, yeah, but why?
Why?
And also, it's actually not Guava for the first time, so that's good.
No. So what you could do is you could try to figure out in which version you would expect this class file. So there is this feature in Maven Central you might not know, but you can look up the jars that contain a specific class.
Okay, so I can go to Maven Central.
Right.
And if I just search for Guava or gRPC, I usually just get the artifacts.
Exactly. But you
what
won't
is the new trick?
You won't see the classes. So if you you saw the advanced options probably below there, and it gives you a little bit of things you can add to your search thing. And this is the one we're looking for, a full class name.
Okay.
Right. So if we do FC followed by the method, now we get a list of all the jar files that contain a specific class.
Oh, that is interesting. And over here on the top, it looks like some artifact that's being published actually contain exactly the same class. And if these two things were to be together, then you're definitely going to get a dependency conflict as well. And I think this is what happens when potentially when shit is happening, but without the actual relocation.
Right.
Yeah. Okay, so I got all the gRPC stuff here, and you know, I can see all the versions. I don't really see anything different here.
Okay. Well, let's go back to the dependency tree.
Okay. So dependency tree. And the verbose or no verbose in this case?
No verbose, but I think we can reduce it to the group ID for io.grpc.
Okay. There we go. All right. So what's happening here? Oh, look at that.
This is interesting.
So we did have a conflict here with stub, right? And so we upgraded it to the newest version. However, everything else is still using the older version, which is 1.0.1. And from my understanding of this situation, and by the way, this took a long time to troubleshoot as well. Anytime these things happen, it takes a long time to go through the dependency tree to figure out what's going on. And in this particular reason, the gRPC libraries, like all of these different modules, they're actually tightly coupled together. What that means is that you cannot use different versions of these modules. They all have to agree. And this is what we call the problem of version misalignment. That's why this example is called misalignment. What we need to do is to align all of these versions, right?
Right.
So what are the options to align them? Because we learn about exclusions, we learn about dependency management. One of the options is that I can dependency manage every single one of these libraries and update their version to 1.10 individually in my own palm.
Right. So again, you want something to enforce, right? Actually.
Yeah, we want something that will enforce all the versions for all of these libraries.
Exactly. So you might wonder if there is a Maven enforcer rule for it.
Is there one?
Yes, there is one.
What? Really? Which one? This is new. I did not know about this one before.
No. It's called same versions, and that's where you can specify that specific dependency with the same group ID have to be exactly the same version.
Oh, interesting. Now we did not talk about this in the past, but this is definitely new for me too, and this is great. Look at that.
Yes. However, this is just giving you a warning that your versions are not in sync with each other. So this is actually a little bit too late. This is not the real solution, right?
I see. Yeah, but it is still good to catch this, right? It's always good to see the warning up front. Yep.
Yes. So what we can do is we can make use of a BOM file. And a BOM file is it's called a bill of material. And I think it's introduced like 10 years ago already. But right now we're working on it to make it more public to everybody, that they should use it. So in the BOM file, it is actually, if we are going to open one, you will see that it is a long list of all the dependencies that should be aligned with each other.
Okay, so here's the gRPC BOM.
Exactly.
Yep.
And here you see dependency management, not dependencies, but dependency management. And here you see all the dependencies, and they're all having exactly the same version.
So this is like having a dependency management section in my own file, except that this is a different artifact here,
This is
which I can
externalized.
basically import somehow.
Right. So what you could do is you could copy paste this whole block inside your own POM file, but that's of course kind of ugly.
Right.
So there's what you can do is you can copy this. So just the group ID, artifact ID, version, and the type, which needs to be POM.
Okay.
And you also have to specify the scope.
Uh-huh.
And scope has to be import.
I see.
From imported.
If you don't have the import, then it will import the dependencies instead, right? And this is why you need the import scope. So it reads the dependency management section for you. Yeah.
Without the import scope, it will look for dependencies. And with import scope, it looks for dependency management.
Mm-hmm. So now I'm importing the BOM that actually has the versions all aligned for all of their modules. And now if I run this tree again, I can see that through the dependency management section in the BOM, we overrode all of the gRPC library versions, and they are all aligning at the same time now. So that is the easy way to do this, in addition to the reinforcer rule, right?
Right.
That's cool. So just to recap, what happened there is that these gRPC versions, they are tightly coupled. They actually need to use the same versions, but they are not, and that's where this internal API actually broke. By using the BOM, we can override all of these versions and translated versions in one shot. And this is why, again, we have this rule now for GLBP, or one of the best practices is that if you are creating a multi-module project, please produce a BOM, because it will make the user's life a lot easier when they are trying to consume your library. However, the BOM can override any dependencies in this case. So, I think that it's best to say that only include the modules within your multi-module project in the BOM. But if I have, say, Guava that I'm using as a translated dependency, should I include that in the BOM so that you can make it work when you're using the library?
No, you will make it a lot harder for people to change the version of Guava in general, because the order suddenly matters. So no, you should only specify the modules that are part of the multi-module project.
Right. Yeah. So if you're producing a BOM for your multi-module library, do not include your dependencies, but only have your multi-module projects. That's the easiest way. Cool. Now, gRPC also use another method, which is by using a version range, but it's using strict over version range. What that means is that if the version happens to be misaligned, the strict version range will kick in, and Maven will tell you that the versions are misaligned and you need to use a different version. But version ranges should not be used in general, right?
No.
Other than this case. Yeah.
Hey, Robert and Ray.
Yeah.
We need to start thinking of wrapping up because we're running out of time.
Yeah, it's the last slide here. The final thing that if all things fails, then you can use something called the linkage checker. This again is an enforcer rule that will be able to do static analysis on your application and will actually traverse all the codes and make sure that every single code is reachable. And this again is a reinforcer rule, and you can apply this to your project. This is an open source project created by Google Cloud Platform, by the team who are dealing with all of these issues as well. So with that said, I'm gonna skip all the bonus here and just say, here's a list of things that you should be looking for. Enforcer rules, there are quite a few that you can use, and you need to manage your translated dependencies as well by using the BOM, the exclusions, dependency management, and stuff like that. With that, I'm going to stop for now and say the reason why I love to do Maven Talk with Robert is because one thing that I learned is that Maven only has a handful of committers, right? But it's used by just about everyone.
Exactly.
Yeah.
So we're having like 5 to 10 active volunteers. So there's no company behind Maven. So we're always looking for contributions and maybe even new committers if we recognize them as understanding how Maven works. So here's a link to go to some open issues, and these should be the easy to pick up issues.
Yeah, definitely. I think it's very important for the community to participate and contribute wherever they can, and help to improve the project as well. Like Robert is one of the few people that I know that works on Maven. I probably know small handful of them, but that's really it. But I know everybody uses Maven in the Java ecosystem, so please contribute. And last note is that you can find all the rules or the best practices online, which is at jobp.dev. Please give it a try and understand it, and reach out to us if you have any questions. Okay.
Wonderful.
Cool.
Yeah, wonderful. I mean, awesome presentation as always, Robert and Ray. Yes, so thank you very much for being here with us today. And we do have a couple of questions from the audience, but unfortunately we run out of time. So I ask the audience to reach out for Robert and Ray on Twitter, or even I know that Ray and Robert are on the Slack, so they can answer them over there.
Yes.
So that will be fine. So thank you so much for joining, and hopefully we will be able to have you here in Portugal next year.
Oh, that would be great. Thank
Yeah.
you.
Yeah.
Looking forward to it.
Okay.
Okay.
I'll let you go now, guys. Bye-bye.
All right. Thank you. Bye.
Hi, everyone. Welcome again to another session of Jnation Online 2020. This is our 11th session of the day, and team here is starting to get a little bit tired, but we're pushing through, and hopefully we'll get in one piece by the end of this. For this session, I'm very happy to have here with me Stephen Chin and last minute edition surprise, Johan. Hey, Steve and Johan, how are you guys doing?
Hey, Roberto. Thanks very much for having us out in Portugal again.
Not exactly.
This is a lot easier. This is a lot easier than driving a motorcycle to Portugal, but not nearly as much fun.
Yeah, I mean, you like a very quick story. You did the very first session of Jnation because you did the opening keynote on the first edition.
Mm-hmm.
Yeah, so
Yeah,
that was great.
it's great to be back. And if you remember, the first time I came to Portugal was on one of my
motorcycle
European
tour.
tours.
Yeah, I remember.
And I was coming from Sevilla in the morning. I drove into Lisbon to speak, and then I drove back and spent the night in Madrid before getting to Devox, France the following day.
I remember.
So that was
yes.
crazy.
Yeah.
But not as crazy as you guys doing. How many sessions today are you going to do total?
I'm gonna do 14.
Yeah, that's crazy.
I mean, I mean, if it was like physical, it would be crazy. But I mean, I'm sitting all day, so it's fine. Anyway, let's just not waste any more time. I know that you guys have an awesome session about JavaFX, and I'm pretty happy that both of you are here. So without further delay, please, Steve and Johan, feel free to start.
Cool. Thanks, Roberto. So we're very glad to be speaking to this great audience at the Jnation event. And while it's not the same as being there in person, we all kind of are facing a new reality. And I don't know how you guys felt about it when this whole pandemic hit and kind of everything closed up. But I somehow imagined that I would look a little bit more like this during the apocalypse, kind of toting my post-apocalyptic gear, having my trusty friends beside me. But I think it turns out that none of us actually ended up like this, unless of course you're doing the riots right now, which are sweeping the world. Maybe then you're toting. Well, hopefully you're not toting a gun. But this is actually what my situation looks more like, and probably for a lot of you guys as well. So lots of monitors, lots of screen time, lots of sitting, although I do have my treadmill desk, which I try to do at least 2 to 3 hours a day, so I'm not sitting all day. And a completely overdone AV setup so I can do presentations like this. And I think we're kind of fortunate in the tech industry that we can be productive, that we have opportunities for employment, that we can get our work done from the relative comfort of home, and hopefully things will get back to normal and we can all be hanging out at Jnation and conferences like this in person and doing cool stuff together. But let's talk a little bit about the history of JavaFX and where it's come from, because Johan and I both have been following and helping out with JavaFX from the really early days. And we're really excited to see it making a comeback and becoming the standard for rich client development. So you remember the good old days of F3, Johan?
Yeah, that was when Java 1 was still in Moscone. Yeah.
Yeah. I mean, it kind of came back to Moscone, but then it wasn't Java 1 anymore, technically. So, okay. Anyway, let's not go there. So if you remember back to these days, Christopher Oliver launched the form follows function, which was dubbed F3 for Cbian. It was acquired by Sun, and the initial release of JavaFX was actually based on a Java 2D toolkit called Piccolo 2D, which is actually an open source project. I was contributing to that at the time. And eventually they both rewrote the graphics stack and also rewrote a compiler technology to compile the JavaFX script language. And this is kind of when we both got involved in the scene. So Johan and I were both co-authors on the original JavaFX book with Jim Weaver. We did a lot of early projects and development with JavaFX, and we're involved with the team that built it. And 2011, they removed the JavaFX script language, which I think for a lot of us in the JavaFX community was traumatic, but it was probably for the best because it opened up the number of people who could use JavaFX as a technology. So now JavaFX was just pure Java APIs. You can use any JVM language to write JavaFX code, and it's very accessible. So anybody can do JavaFX code now, just as an API. And it was even bundled with the JDK in Java SE7 Update 6, and officially in Java 8. They did the full JDK integration. Unfortunately, Oracle made the decision in 2018 to remove JavaFX from the JDK. So this was a very sad day for all of us. What did you do on this very sad and traumatic day, Johan?
Well, I try to look at the opportunities that were starting from that day, because this really allowed the community to step in and to take advantage of the power of the Java ecosystem, and also the power of build systems like Maven and Gradle to fill the gap that was created.
Yeah, so like Johan said, you can't keep a good technology down. So like any great 80s movie hero, like this guy.
I'll be back.
JavaFX was a technology which wouldn't be simply removed and left behind. It was fully open sourced. There was large community support for it, and a certain company, Gluon, actually started releasing builds of JavaFX for JavaFX 11, 12, 13, and now 14, all of which you can download from their website. They support patches. They do full-time support of Scene Builder. They also have a great GUI builder for building applications, and have support for JavaFX on mobile, which we're going to show. So in case somewhere you weren't following Java client technology, probably the most interesting thing which has happened in Java client technology recently is the ability to run applications cross-platform on different devices with exactly the same code base, which is pretty amazing, especially since you can take advantage of high performance ahead of time compilers, a common graphics toolkit, and then build with mobile integration and mobile features like accelerometers and other stuff, which is only available on mobile. So we're gonna talk a little bit about that. This presentation, which we're showing you, is of course being recorded for the Jnation folks, and we're going to also, well, actually the slides are already posted at this link. You can go to either the bit.ly link or the QR code, or follow the link from the show notes page on the JFrog website. Also, for folks who stop by the page, which will have the slides and the video posted as well, so we'll post a link to the Jnation video when they release it. You also have an opportunity to get one of 2 Nintendo Switches. So if you like a lot of us have kids at home which you're trying to entertain during the pandemic, I can tell you that Animal Crossing on Nintendo Switch is probably the best quality coding time that you're going to get if you need to just keep your kids occupied for quite a while. It's online and it's great. They can just spend hours doing that and not disturbing you while you're trying to get work done. So I think the best way to get started with JavaFX technology is actually Scene Builder. And let's do an ad hoc demo of Scene Builder and show you guys some Scene Builder greatness. So I'm gonna share my window. How do you guys seeing the new share? Other than the fact that the text is really tiny for now until I get it smaller.
It's just playing, like being like crazy. Is that you?
What did you say, Roberto?
The stream. You might want to increase it a little bit if you can.
Yeah. I'll make it bigger once I get this dialogue. Okay. All right. There, now that should be more visible, right?
Yeah, way better. Wonderful.
Okay, so Scene Builder is the best way to get started with JavaFX development. And the reason is you can use it to build real applications. So unlike other GUI builders, it generates and uses a standard markup language, FXML, which is supported by JavaFX. So you're never generating or directly editing code. And it has all of the different controls which you can use in the language easily organized. So on the left here, you can see this is all the containers which are available. We have a list of different controls which you can put into your project, and it's nice, easy drag and drop, so you can just drop things right in. Different mobile widgets you can use, which are part of the Gluon libraries, and shapes, charts, 3D, kind of everything you can do. So it's a good way to see all the different components. When you actually drag something in here, it'll show up in this document view here, so you can see the layout and you can organize your components. And on the right here is an inspector where you can inspect and set properties for different things. So here's one of the sample projects from the book. Okay, you can see last time I was presenting for the New York Java SIG. Let's put Jnation. And basically it's really easy to drop new components in, to play with the fonts, to play with the settings. That's a horrible color. We'll choose something a little nicer for you guys. You can add special effects like drop shadows and take advantage of different features of the language. So it gives you a quick way to experiment and learn the different capabilities of the JavaFX platform with an easy drag and drop GUI. And then also you have a preview where you can immediately run it and see exactly what it will look like. Hold on, let me. Oh, so you guys probably weren't seeing what I was showing. Okay, so it opened in a separate window. So let me back up quite a little bit. So this is a sample project. Here I added a text component for Jnation, and on the right here you can see all the properties. So when you edit something here, it will edit dynamically. And you can also get a really quick preview of this. So if you go and you do preview, show preview in window, it will pop up a window with the results. And just a sec, let me find it in the massive list of windows I have open. Oh, maybe it's already shared. Let me see. Oh yeah, it's already shared. Okay, and here you can see the child window it opened up, which is an actual JavaFX application that shows you the running results. And this is a live window. If you add a component like let's say I add a text field in this, which has actual edit capabilities. Let's make the font a little bit bigger so it's visible. And then same thing, run in the window. You can see it's an actual edit field you can type into. So all this is running live in a JavaFX application. So this makes it really easy to edit and do your first project. And I'd highly recommend this as an initial way for folks to get started with JavaFX, learn the capabilities, and explore the platform. Okay, so let's go over some use cases for how different folks are using JavaFX technology, and then we'll also show some mobile examples as one of the last use cases. So I'm gonna pass it over to you, Johan, in a bit. So one of these is the Mint Training and Resource Management, which is an example of a company which has a fairly complex JavaFX user interface. So this one is for flight control management. you can see the flight crews, you can see shift schedules, you can see like different airplanes and things which are going. Unfortunately, they're probably not as busy for airline training as they normally would be, given the current pandemic. But like this sort of complex view with Gantt charts, with tables, with trees would be fairly complex to build as a web UI and probably also slow and not as responsive as you'd like. So this is a great example of an application which benefits from being on the client side and using a technology like JavaFX. There's also a bunch of mobile applications. So the DevOps conference, which also is a little challenged running events right now, but their mobile application, if you've ever been to one of their events or if you've used it on your phone, is actually entirely written in JavaFX. It was kind of branched off a project we did for Java 1 year to do a mobile version of the Java 1 scheduler, which Gluon and Johan did. They rebuilt it for DevOps to provide full conference capabilities, and it's a great example of a rich UI. And you would never know that you're running a JavaFX application unless somebody told you that this application was written in JavaFX, because from a end user standpoint, they download it from the App Store, they install it, it gives you responsive, near native like performance. So really, from the end user standpoint, it's just like another application on the platform. And final example is one which the folks at NASA were nice enough to let us use in our book and in this presentation, which is the Deep Space Trajectory Explorer. So Diane from NASA helped us get this image, and it shows their work to use a JavaFX user interface with complex 3D libraries in order to visualize trajectories in space and then do visualizations, which otherwise would be very hard to do without the sort of scientific libraries which they're using, which are written in Java. So this allows them to directly leverage the Java libraries which they use in a client form to visualize and show kind of an advanced user interface for purposes. And this is exciting, especially with stuff like the SpaceX launch this weekend and some of the stuff which is starting to happen again around our space exploration. And speaking of space, you have a space demo to show us, right, Johan?
Yeah, maybe. So this is a game that Gerrit Grunwald wrote, and it's probably hard to explain. So I rehearsed for this presentation today by playing the game and trying to get a high score. So let me see if I can bring this up.
That's a nice way to practice a presentation.
Yeah, my kids were jealous with me when I told them that I have to do that for work.
Hey, I'm playing. No, I'm not playing. I'm just practicing the presentation.
You set high expectations for your score here, Johan. I'm expecting to see the finest performance.
Yeah, well, it's live demos are always hard, so don't expect a high score. So what you have to do here is to make sure that those stones and so are not killing you. And so how much time do we have?
That was a good demonstration of what happens when the stone hits you. Thanks, Johan.
Yeah, so there's a shield that you can use, and that will prevent you from being hit. And so actually the animations that you're seeing here are, I think, well, pretty impressive. Unfortunately, my sound is not working, because otherwise it's even cooler. I think you get an extra life if you touch one of those circles. But the one of the interesting things about this is that, so this is now working on my desktop, but if I don't share that screen anymore, and can you hopefully see my this iPhone or low resolution?
Yeah, we can see it.
Okay, so well, the problem is that I can't see it now, but let's try it. So this one has the SpaceFX game there as well, and I made sure that it isn't started. So I will click on the button to start it, and you see it starts immediately. And the reason why it starts immediately is because we're using the GraalVM AOT compiler. So it's this is JavaFX compiled to native code, and you see it's the same game here, where I can play and shoot and try to get a high score as well. See, at least I don't have 0 anymore, but it's a bit hard to play and demonstrate at the same moment. So I'm gonna die soon.
Yeah, don't worry, you've already died.
Yeah, so there we go. But in any case, this is the same code, 100% the same code as the desktop application. And if you go back to the slides, it's also the same code that works on embedded. So on the right-hand side of the slide, you see the unnamed window. Yeah, I have to fix that. That's on a Raspberry Pi. So that game is running on the Pi as well. So we want to make sure that everyone can play games everywhere. So if you would do this not in Java, it probably means that you need to create an application for desktop, for Windows, for Mac, for Linux, then one for iOS, then one for Android, and then one for the Raspberry Pi, for example. But if you do it in Java, like Gerrit Grunwald did, so I really have to give him all credits for this, because I mean, I have no graphical skills, and he has.
I've seen what your UIs look like, Johan. You can spare us.
Yeah, well, I'm not even allowed to choose colors, as most people know for very good reasons. But Gerrit made a fantastic demo, and that runs on all kinds of devices. So that is one thing that you can do with JavaFX. The reason that it works so fast also on mobile is not only because it's AOT compiled by the GraalVM compiler, but also because it is using hardware acceleration. JavaFX on desktop, on mobile, and on embedded is using the GPU, if there's a GPU available. So that's one of the major differences, I think, between JavaFX and the previous Java client user interfaces. JavaFX is really a modern platform that uses the modern capabilities of the devices with these GPUs. So, and that is leveraged on all devices. And that is, of course, platform dependent, but the JavaFX implementation shields the developer away from this. You just write Java code with Java APIs, and the hard work is done by the Java platform underneath it. So that works fine for games, but also for well, mobile business applications, for example, which is demonstrated on the next slide. So this is, for example, an application in Belgium where people can visit cultural events, and they get rewarded if they visit such an event. They have a card, an NFC card, and we leverage the NFC card reader capabilities of the iOS and Android devices, so that you can access this device-specific functionality in a Java way. So the API is to access this NFC card reader on iOS and on Android typically are different, but because we have a Java API on top of it, it's still the same code everywhere. So that is how the advantages of the Java platform are being leveraged on mobile devices. Wide runs run anywhere, and make it happen on all kinds of devices.
Cool. So not only can you make games, but you can actually do real cool stuff like business applications. And I think this is the is this the same project where you had those physical readers you were building in the Belgium office when I was out there one time?
Yeah, that's funny that you remember that, but yes, indeed. So there's also an application on a Raspberry Pi that's accessing the same backend. So, and that's also one of the what I think one of the biggest advantages of using JavaFX on mobile and on embedded. You can use the same code as the components that you use on the server, and that includes all the security APIs. Java was built with security as one of the cornerstones. And if you want a real secure application, you can really benefit from using those Java security APIs that are built in the JDK. So the PKI APIs and so are part of the Java SE distribution. And those APIs are available on mobile and embedded as well. And today, security and privacy is increasingly important when you create mobile and embedded applications. And leveraging these components really gives you an advantage over some less secure languages.
Cool. And the other great reason to visit Leuven is some of the finest lunch sandwiches in Belgium.
Okay.
Yeah, and the people are great.
I thought you were talking about the beer, but okay.
Yeah, the beer is okay, but the lunch sandwiches, that's the highlight. Okay, so let's talk a little bit about one of the most recent features, which was introduced into the JavaFX stack, which is some of the 3D support. And we'll show some examples of how you can quickly build and create your own 3D applications using simple JavaFX code. So if you've ever tried to do 3D and complicated stuff with libraries like OpenGL or other low-level libraries, you know they could be fairly complicated. But one of the nice things they did with JavaFX is they created a very simple, pure Java API for creating meshes, geometries, and shapes. So the basic primitives are you have boxes and cylinders and spheres. So those are the predefined shapes. You can also use a triangle mesh or a mesh view to import more complicated shapes if you want to import them from an existing 3D model or something you've exported from a 3D program. Once you have some simple shapes, then to provide a little bit more depth to them, you can add texture maps. So you map a texture onto a shape using a UV map, which defines the projection. So here's an example of a 2D image of the world with a UV map that defines how it gets mapped onto a sphere. And this takes a Mercator projection and creates a perfect globe out of it. And besides putting textures on top of 3D models, you can also use light sources to illuminate the scene and provide light. So there's a default light source if you provide no active light. And then you can define your own light sources. So like everything else, I think this is all shown best in code. So let me find a suitable demo. Let's start with our favorite, the sphere cylinder box demo. Okay, so this is really simple code, which probably any of you could write. It's a simple JavaFX application. It creates a sphere with a radius of 50, a cylinder, again radius of 50 and a height of 80, and then a box. Where's the box? So yeah, box is 40, 50, 60. Adds these to the scene, sets some rotation on the scene, and then displays the scene. So very, very simple. Let's go ahead and run this. Okay, so here you can see the result of running it, and it's very straightforward, right? You just have the three objects in the scene, they rotate a little bit, the default light illuminates it. So very, very straightforward. But obviously we want to do something a little bit nicer with this. So let me pop up another example. Let's do the Earth sphere one. Pop, pop, pop. Okay, so here's another project which shows the example of the Earth sphere. This is the image, which is going to be UV mapped onto the globe. Here's the code, so it's pretty straightforward, right? It loads the image, creates a new Phong material, sets the diffuse map of the material on the Phong, then creates the sphere with a radius of 400, puts this in a group, translates it, and then adds it to the scene. And the only thing complicated we're doing here is a mouse handler, but this is also a great example of one of the features of JavaFX. So it's adjusting the angle here with the these two properties here, anchor angle X and anchor angle Y. And this is using a feature in JavaFX where you can set properties and then you can have those be observed. So we create a binding on the rotation of the sphere to this angle property. And whenever you update the property, it will automatically update the rotation of the sphere without having to set it. And then as you drag it, it's just going to simply update the angle and it should rotate automatically. So let's go ahead and run this. Okay, so here you can see the results of running it. The Earth sphere, it's projected the flat Mercator projection onto the globe nicely. If we click and drag, now it will rotate it nicely as well. And you know, very, very simple to using the primitives to create fairly complex scenes and shapes. And then let's also show a lighting example because I think that kind of closes out the basics of what you need to do. Light demo. Yeah, let's do this one. Okay, so final 3D example. This is a simple light example with 3 properties, one for a red light, one for a blue light, and XYZ on each of those. So 6 properties. And what this will do is it will allow us to control the light with some sliders. So again, we're using binding to bind these properties to our red light property. And then we're going to add some sliders, which are also bound to the red light property. And then when we move the slider, it will change the position of the light automatically. And this is a good way to see how point lights affect what the scene looks like. Okay, so here's the application, and you can see the slider. So when you move the slider, you're moving the respective lights. So this is the red light. Now I'm gonna hopefully get it on just one face. Okay, now the red light's on the right face. The blue light is on the top face. Right, so you can see that with the point light, whatever side of the sphere it faces is going to be illuminated. If we overlap it now, where we get both of them on the same face, let me see if I can get this working. Okay, so now they're both on the same face, which the red and the blue make a nice purple hue. And this gives you an idea how you can kind of blend colors together. And I think if we get it up there. Now the entire sphere is purple because we've illuminating all 3 sides. So quick example of binding lights, what you can do with this. And while we're on the subject of 3D, another thing you can do is besides using the built-in libraries, you can also use some other third-party libraries like FXYZ. Give me a second, let me pop this up. Okay, so this is a example of a third-party library, which allows you to do complicated shapes like spring meshes. I think this is a library which the folks at NASA use. You can specify things like the radius, the wire radius, the pitch, the length, and do more complicated 3D shapes than you can otherwise do with the core libraries, all from code. So here's an example of this. Come on, you can do it, IntelliJ. Where'd my window go? Oh, there it is. Okay, it was hidden behind something. Okay, and here's the output of that running the application. So it shows you the Spring Mesh, which is entirely defined in code. You could change the parameters and directly modify what's getting created. Okay, so here's some information about that final project FXYZ. And I think something important which we want to stress is some of the best practices if you're doing modern client development. We cover all these in detail in the book, but kind of the three main things which I think have changed in how you do client developments in the modern era are, first, how you package your platform. So traditionally, folks have been very concerned about the size of your application. But even in the case of mobile, the size of your typical mobile application has dramatically increased. So a lot of the applications on your phone are over a gigabyte now because storage is cheap. Folks want a rich experience, and generally, folks are less concerned about the size of the application since you're doing more with them. And I think the same trend is true of definitely desktop applications and other deployments. So one of the historical considerations was how you could shrink the size of your application, but the lightest weight Java application, a fat jar, is highly disrecommended. The problem with this is when folks get a jar file with just random class files, they're very unlikely to be able to effectively package and run it themselves. So you're much better shipping the JDK version of dependencies with your application, which they require. With modularity in Java 9, this becomes much easier and smaller to do. JLink allows you to do this for fully modular apps, and with the release of Java 14, JPackage is now the recommended way of doing it. This was the JPackager, which was part of JavaFX. They added it back into the JDK, re-released it as JPackage, and this is the best way to package up your JavaFX or general client applications if you need to do desktop deployments. And there's a bunch of other great options. So Johan mentioned that the Glue on Mobile uses Graal to build native applications, and this decreases the startup time of your application because it does ahead of time compilation, and also reduces the size of your application. And also the folks at Karakun released a project called Open Web Start. And Open Web Start is a reboot of the WebStart project, which has been open sourced and is fully supported by the community. So I think a general trend is the community has done a great job at taking the assets which Sun and now Oracle have open sourced, supporting them, improving them, and making them great for individual or business use. And you can see more about this on the Karakun page about Open Web Start. Okay, and I think Johan was going to tell us a little bit about the process for creating static images using Glue on Substrate. So go ahead, Johan.
Yeah, so this is not only the recommended way for mobile, but it is the way that it also works on desktop and embedded devices. So before we had static images, it was always a requirement that the user of a Java application had the JDK installed or a JRE installed on his computer. And that had to be updated every now and then or very often. And many end users were upset because of this. So what we do with Glue on Substrate is removing the need to have to have a Java pre-installed on your system. So Glue on Substrate is a tool that it's an open source. You can find it at GitHub. That takes your Java application with JavaFX user interface as input, and it will examine the dependencies in the Maven pom.xml or the build.gradle, and then it will compile all code ahead of time using the GraalVM native image AOT compiler, and it will link the resulting Java So the Java bytecode is translated to native code, and that native code is then linked with the Java static libraries that come straight from OpenJDK. So this is the very latest Java API implementation. And it will also link in the JavaFX native libraries that are needed for the hardware acceleration. And if you do mobile development, it will also link in a bunch of mobile-specific libraries. And the result is a static image. It is an executable that runs on desktop, mobile, or embedded. So by doing this, as a Java developer, you can create native applications like any native application. So it's not the case anymore that you need to send a jar file or something that's bundled with a VM to the end user, because the VM is not even part of the executable. It is linked in together with the executable code. So only the pieces that are really needed are part of the end application. And this makes applications much faster to start, because you don't have to compile the Java bytecode to native code when it's at the platform. And also the memory is typically much smaller. So this is something that static images that's gaining popularity. Recently, Oracle announced Project Leiden, which is going to standardize how to create native images, more or less. And this is actually something that started in the mobile world, because you cannot send libraries to mobile devices. You really need to send total applications. But it is very useful on desktop and on embedded too. So the concept of app stores is gaining popularity. So with tools like Glue on Substrate and GraalVM native image in general, you can easily convert your Java application into a complete native executable that does not require the end user to download anything else anymore.
Yep. No, I think this is some of the greatest technology for Java developers, and especially for Java client developers, because it makes it so easy and lightweight to deploy your applications. Okay, so we talked a little bit about mobile earlier, but kind of the reason why you might want to target mobile first. A is because actually the amount of traffic from mobile dominates the amount of desktop traffic. So often it's easier to start with a mobile application because it's a simpler UI. You can build it quickly. You can use exactly the same code base. And using the technologies Johan showed earlier, you can now run your application on OpenJDK 11, 12, 13, 14, right across different platforms. So have the same code base for iOS, Android, and for embedded devices. Take advantage of modern build systems like Gradle or run on Maven, and then have full IDE support as well. So they have great plugins for IntelliJ Eclipse and NetBeans to get started really quickly with building your first mobile application. So really easy to get started with. I think it's probably a best practice to look at this first and then begin with mobile applications. And you can take advantage of the ahead of time compilation and Graal substrate support that Johan talked about for optimizing your application for startup times. And the third best practice is building for the cloud. So I think traditionally folks who build client applications often have used local databases, or they've done things which were more database centric or more desktop centric, but really a best practice, and this is showcased by ETO Board, which is a agile tool used for team management across distributed teams with touchscreens, is you want to build a backend that is entirely cloud-based, is secure, allows you to communicate with different clients, and gives you the same sort of features as you would from a web application when you're interacting with it. And this was really the way for client technologies to be seamless, whether it's on the desktop, whether you're in the browser with a technology like Open Web Start, or whether you're on a mobile device. And as an example of this, one of the examples in the book is a weather application. And what this does, and Roberto mentioned that you should ask questions in the chat. We are looking at the chat. We'll answer questions as we go along, even though we're running short on time. But the first thing to post in the Slack chat is somebody has to post a city, and the first city will be the one we'll use for the example here. So this is a really simple application which allows you to do backend REST queries to a weather service entirely using Java code. So it talks to this. Oh, Roberto Mins. Coimbra. Okay, so that'll be our city of choice. Thank you. So this is going to a service, open weather map. We are going to put in Roberto's hometown, where he served some really great food at a local restaurant for us last time we were at the inaugural Jnation event. It uses a standard REST API to go out and make the request. It displays in a JavaFX user interface. And I think this is a simple example that showcases how easy it is to build applications in JavaFX to use backend REST services, and to get exceptions on your demos. Hold on, let me show you the exception. Okay, so this is unrecognized field gust. Okay, let me do some on-the-fly debugging for you guys, and you can see the JSON APIs as well. Okay, so in the winds class, we have an unrecognized field. Now, we probably should have done this in the book, but you can just ignore unrecognized properties in JSON. So we're going to modify it and say we don't care about that particular property, and then we'll rerun it. So occasionally the APIs change, but as Java developers, we can just hack the code, and then we can see that in Coimbra, it's 20 degrees Celsius, 78 degrees humidity, a little bit overcast. Does that sound about right there?
Yeah, so let me actually do something for you here. So let me remove that one. Let me remove my screen, and now you can actually see from my window.
Oh, nice.
Outside. So what do you think?
Yeah,
Is that
slightly
about right?
overcast. Yeah, it looks about right. I like the tricycle, although is that tricycle at the edge of a cliff?
No, it's my balcony.
Is there glass?
Yeah, that's
There's
glass.
glass there, hopefully.
Yeah, that's
Okay.
glass there.
All
Yes,
right.
yes.
Looked a little dangerous. Okay, so that's awesome. So yeah, so the application's working. It's giving us back some data. I'm gonna slip to the JavaFX expert slide here, Johan, and reshare just a sec.
Yeah, we need to start wrapping up. Sorry about that.
Yeah, we're there. Okay, so I just want to thank. I shared the wrong thing. I just want to thank all of the experts in the JavaFX community who made this possible. So Johan, who made a last-minute cameo appearance and is the world expert in JavaFX, he's actually the one committing most of the patches and doing a lot of the work behind the scenes. Jose helped with the slides for this talk. Gail, Paul, Jim, Eugene, Sven, the names
Tony.
go on. Like we what? Tony. Yeah. Tony, William, Bruno, Wei Chi, and
Jonathan.
Jonathan are all members of the community which contributed to this book which we wrote and have been helping with the JavaFX community for years. You can contribute back by joining the JFX project on GitHub. Some of the project leads are Kevin and Johan. It's all 100% open source. And you get started at openjfx.io and find a bunch of the mobile examples at this URL. All the slides are available at this link. So just go to this link and you can check out the slides. As we mentioned, you'll get one of 2 Nintendo Switch Lites if you also sign up for the raffle on that site. And thank you very much for attending the talk. Do we want to take any questions? Did we get any questions in chat, Roberto?
Yeah, I asked for questions, but I actually didn't got any. But we got out of time anyway, so sorry about
Okay,
that. We need to wrap up.
let me leave you guys with a personal offer for those who join join the stream. So for all the Jnation folks who joined, this is the Swamp Up conference for JFrog, and normally there's a $20 ticket for registration fees. We have a little friends and family discount, and the way it works is using that we're still going to donate to the charity, but you get the ticket for free. So if you're interested, just hit me up on Twitter, Steve on Java, on Twitter with a direct message, and I'll be happy to give you a discount code for the conference, and you can come join some more great technical sessions and also contribute to a charity. We will contribute to a charity on your behalf. So thanks very much for having us, Roberto. This has been great, and also it's been fun co-presenting Johan. We should do this more often.
Yeah, it was nice getting invited to play games online.
Yeah. Hey, Steve and Johan, it was really great to have you both here. Unfortunately, that we could not make it here in Portugal. Hopefully, let's see if the situation improves and we can do it something next year. And hopefully, we can at least.
I'm really glad that you guys were able to convert this to a virtual event on short notice. So that was, I know, a lot of hard work on your part, and just shows the passion of the local community. The guys in the green room were awesome. I remember them from when we were out there. And,
oh, wonderful!
You have a great team, so keep things going there.
Thank you very much. I mean, it's really, really nice to hear those nice words. And I mean, I think it was the last we could do for everyone sitting at home. At least they have something to see, right?
Yep.
Wonderful. So I'm not gonna take you more time. So thank you again for joining, and hopefully we can see each other in person in some other place when things get better.
Yep, absolutely. Thanks a lot.
Thank you. Bye-bye.
Bye.
Welcome back, everyone. And welcome back, Ray. Yes, Ray is here again. How are you doing?
I'm doing fine, thank you. Yeah, glad to be back here for the second session.
Second session of the day, one in Maven and one in microservices and Kubernetes.
Right.
And you also were present in Jnation 2018 with the Docker session as well. Are you not getting
Right.
tired of us?
No way, it's been great. You are all
That's
awesome.
great.
So
Can
thanks
we
for
book
having
you?
me here.
Can we book you for 2021 then?
I would love to come. Yes, absolutely.
we expect to have you here, but next time, hopefully, on site again on those marvelous rooms of the Convento. So we are close to the closing keynote. We only have a race session, and then we have Rafael Benavides here on Almedina, and then we close up with Venkat on the closing keynote. So we are reaching the end of Jnation Online, but for now, let's stay with Ray. And so, Ray, whenever you're ready,
Okay,
go ahead.
thank you. Yeah. So thanks everyone for joining the session, and I know it's probably late in some of the countries, so thanks for staying up. And if you just got up, thanks for joining us. My name is Ray. I'm a developer advocate for Google Cloud, and I love to bring some of our technology to developers all over the world, especially for Java developers. I've been a Java developer for a long time, almost more than 15 years now. And I'm a Java champion. And I also started the project with the engineering team here called Spring Cloud GCP. If you ever want to try Google Cloud with Spring Boot, let me know because this project may actually be very useful for you. If you got questions, you can find me on Twitter, which is @Satanism. And aside from technology, I love to travel. Of course, traveling is very difficult nowadays, but I really enjoy traveling. I love to see the world. And this photo on the right is very special to me. And you can see it's in the middle of the desert. Long story short, I was backpacking in Asia for about 4 months, and I came across this city in northern China where they didn't have any hostels for backpackers to stay. I was a backpacker. And so they only had expensive hotels. So I asked around and see if there are any places where I can stay cheaply. And two different people, completely unrelated, told me that if you take a bus to this middle of the nowhere city and you transfer to a car to the entrance of the desert, and then you walk in the desert for 4 hours in southwest direction, then you will find an oasis and you can stay in the oasis for free. And I heard the word free, and I asked, which bus do I take? I don't know if anyone here walk in the desert alone by yourself for 4 hours in one direction. It is not the same as walking on the beach, right? Everyone's probably walk on the beach, but this is not the same. Okay. And basically, when somebody tells you to walk in the desert in one direction for 4 hours, you hold on to your compass and you walk. It doesn't matter what's in front of you. You go up and down these sand dunes you can see, and the sand is really soft. So every step that you take, you're going to sink a little bit, and you have to pull your foot out to take the next step. And you go up and down these sand dunes, and you have your pack. You got water. It was hot. It was dry. It reminded me of writing a J2EE application back in the day. Okay, I was on vacation. I'm like, why am I doing this again? This feels like work, but much harder. Okay. However, the end is beautiful. This is the real photo that I took from the oasis. It was absolutely wonderful. I'm very happy that I took that hike for 4 hours in the desert. But this is where we all want to get to as engineers and developers. We want to get to this production, to this beautiful place where we see users using our systems, where we see value being created. However, the road to production is not always easy. And so this is what I do. And today I hope to share with you some of the things I learned from doing a project to production last year using microservices in Kubernetes. And I want to share some of my learnings with you all so that you can get to this beautiful place yourself, hopefully much quicker without having to go through the desert yourself. Okay, so I cannot name the project, unfortunately, because it's an internal project. What I can say, though, is that it is a project that's it's being developed by using Spring Boot, using microservices patterns, and deployed into Kubernetes with all the technology that we hear so much about, but we are able to bring this into production and it's ready to serve the real systems, right? And the infrastructure looks like something like this. This is pretty much close to everything that we put on here. There's of course a little bit more in the production system, but long story short, we have a Kubernetes cluster that's running on Google Cloud. It's a private cluster. What that means is that it only has private IPs because it's part of the ways to secure your network perimeter. And we are only routing traffic requests through our load balancer. So there is the Google Cloud load balancer in the front. And for the non-prod environments, because non-prod is for testing and for our internal tests and UAT tests, and these are not open to the public. We don't want anyone to just find the IP address and get in. And so for the non-prod environment, we also proxy it with something called the identity-aware proxy. So what it's going to do is to automatically require authentication. So we didn't really need to add additional OAuth or any security functionality to secure our services in the way that you would expect. But just by adding this IAP proxy, now all of the services are secured automatically through the endpoint. Okay, and then inside of this architecture, we also have all the microservices running in a namespace in Kubernetes, which is on the right-hand side. We're talking to SQL databases, and we also isolated our networking. So we're running a VPC, a virtual private computing network, and we control all of the egress that goes out of this network through NAT. And we're also using Istio to manage our service-to-service communication. Right, as you can see, this is pretty involved. And finally, we have monitoring tools and distributed tracing tools that we added to our environment as well. Okay. Now, the reason why we also have some of these things, like Prometheus, Grafana, and distributed tracing dashboards, even though Google Cloud has the same functionality, some of these services are actually running in a different environment that is done on GCP. And so we also need to make sure that our application can work in a hybrid environment. And that is really interesting for me because the same application needs to work both in GCP in a fully managed environment and also in a non-GCP environment where we do need to use some open source software that we need to manage. Okay, so that is the picture of this entire architecture for the project. It took several months to complete, of course. And one of the first things that when I joined the team, what I learned is that it's really easy in the cloud for us to create resources. Like you can click on the console, you can click on the UI, you can click everywhere to create this entire environment yourself. Okay, and that provisioning doesn't take too long, right? If you know the console, you can just navigate it. You can create the cluster in about 2 minutes. You can create all the networking in like a minute, right? It's very easy to do. However, what happened is now we need to recreate this environment from dev to QA. What happened next? Well, now people do not remember what they clicked on anymore, right? So there's a really important shift. This is so important that we shift from a ClickUp environment or type of provisioning to a GitHub provisioning. So that in the past, when we create all of this environment, is clicking around and also running a bunch of scripts. But at the end of the day, no one remembers how to recreate it anymore. And it's very important to document your environment as code or as configuration. And then you can recreate this entire environment via GitHub. And that's what we have done. So the first thing that I got there that I asked the team to do is to actually create infrastructure as code. And we are using Terraform behind the scenes so that we terraformed everything that we ever needed. So that goes to the Kubernetes cluster itself, all of the external dependencies like SQL databases or static IPs and VPC, any external resources that we need. We go so far into creating the SSL certificates and also laying down the basic infrastructure. So that at the end of the day, what you see is a picture like that, where everything in this environment is terraformed. Very, very important. And we open up just a namespace here that is ready for the application to deploy to. So when your application is ready to be running, you just have to deploy it into this namespace. And the Terraform script is able to create everything else for you. Okay. And now we can replicate this environment very easily from QA to to prod or to dev and so on and so forth. Okay. Now, unfortunately, this is not a Terraform talk, right? So there's a lot of best practices to use Terraform. I'll just tell you a few things that we learned to do to use Terraform properly, right? So first of all is that you want to have all of your Terraform files organized by the environments that you want to create, right? It's very important that you're able to go to one directory that you know this is the dev environment, and you can just run tf apply, and you can share modules between these environments so that it's the same database that's being created, but the difference will be the size of the database or the number of CPUs, so that you can codify some of these into modules and you can reuse it in different environments. The other thing, of course, is that initially the team was running TF apply in their own computer, but they didn't really share the state of the cluster of the provisioning with anyone, right? So remember, if you run Terraform locally without a backend, then whatever that you Terraform, whatever that end state is recorded on your computer only. So in this case, it's very important for you to actually share that state via a backend. And you can do this with different type of databases or different backend. We choose to use Google Cloud Storage so that we can just share the state across all of the team members behind the scenes. Okay, so let's talk about the things that we want to deploy inside. Okay, but before able to deploy, we have to create these applications, right? So we're using Spring Boot, for example, and we're adopting all these technology. But one of the things that really help me understand the difference between dev and production environment is by going through, the actual exercise of, developing and also going to production. Because I think in the Kubernetes environments, a lot of people are saying that, hey, look, if you just create everything to be the same as production, everything will just work, right? Well, yes. However, the local development experience is not the same as the production experience, right? Because production is really, really hard. In production, we have to figure out all the security rules, all the networking rules, right? Anything else we need to lay into Kubernetes to harden the security constructs of Kubernetes, that all has to be done. However, in local development, if you just got started out of nothing, you will spend months to just create that production environment for your development before you even start developing anything, right? So it's very important to remember that, yes, it's a dream to have a development environment exactly like production, but I don't think we'll ever get there, because in local development environments, what we want is to focus on the developer productivity. We want to be able to iterate fast, and you want to not having to worry with all of the production setups, because the more that you add into your local environment, the more you have to troubleshoot. Okay, and we're going to get into some of these issues later, but just remember they're not the same. But what you want to focus on in local development is how fast you can iterate and design your application. And I want to emphasize on design. It's all about your application. It has nothing to do with Kubernetes. If we talk about designing your application properly, designing your services properly, then it should be able to run anywhere, right? Kubernetes is just one of the many different deployment targets. In the past, we deploy into a PaaS. Prior to that, we deploy into other places. And now it's about Kubernetes. And tomorrow, who knows what this is going to be? So what is important is designing your app. And one of the most important things to follow the 12-factor app, because I think that is the thing that has been tested and battle tested for so long, and is still the thing that's persisting even now. And I'm going to assume that it's going to persist in the future as well, because all of the factors are very fundamental in terms of designing your application well. And let's just take a look at the 12 factors real quick, right? There are 12 different requirements here, but everyone here should have at least one factor. Even if you have not heard about 12 factor, or you don't think you have 12 factor, everyone should have at least one factor, which is checking your code. If you're not checking your code, you got checking your code like today, right after the talk. But everyone should have at least one factor, right? But if you look at all of the 12-factor rules here, configuration, don't store your configuration in your application, but or hard code it in your application or hard code it in your files, but externalize it, making in var, or somehow being able to get it from an external environment. That's really important. Being able to scale your application via stateless processes, that's pretty much microservices. Being able to bind to different port, that's pretty important, right? And so on and so forth. And logs, like all of these things are tested through time, and Kubernetes just to happen to have all the facilities that supports the 12-factor application really, really well. So start from there. That's number one. The second thing about developing microservices, with or without Kubernetes, is that you do need to test your services with other services too. And for that, you may need to consider multiple layers of tests. I've been through this a couple of times already to produce production microservices just recently, just as recent as like yesterday. I'm working on another project right now. And what is important is that we don't want to test everything in Kubernetes. That is not a test. That is the end state. What we need to test is the microservices themselves and the ability to interact with another service. And also being able to test everything else that we might otherwise expect from the container, right? So for example, if I want to test another service, my interaction with another service, I will start off with a mock, right, to make sure that the interaction is there. And then I will move on to the integration test where I may use contracts or wire mock, where I actually mock the actual call, and then I get the actual response back to make sure that the networking and everything else is there. And then I can test resiliency. I can test the retries. It always starts from the test. And in many cases where our application needs to talk to a database, right? In Kubernetes, you would think, well, let's just start a container, a deployment for a database, and let's just test in Kubernetes. But that will ask you to go into that Kubernetes environment again. What I do like to do myself is nowadays, which is to write an integration test that uses test containers. This is so good and so very much useful. So I do have an example here that uses test containers. Here I have a very simple Spring Boot app as an example where I am using a PostgreSQL database behind the scenes. It has nothing but an entity and a repository. And if I were to run this application right now, right, if I say Spring Boot run, this will fail. And this will fail because I don't have a Postgres database running. At least I don't think I do. Yep, I don't have it running, and it's going to fail, right? And now we have to go and install the database and all of that. Of course, it's getting a lot easier if you run Docker. So you can say Docker run, Docker run. And you can run a Postgres database behind the scenes. But unit test or an integration test, you want these tests to be repeatable. So what is really important in a microservice is to have these self-encapsulating tests that you can validate its accuracy and correctness. So if I were to depend on a database, what's really important is for me to start the database consistently and reproduce the data that I actually want to test against, and then test it, and then shut down the database, and then recreate a database for the next test. And the easiest way to do this is by using test containers. So it's a really, really cool project. I've been using it for a while now. And so what you can do is to just include test containers as your test dependency. They do come with some utility test container components you can use. And then in your app or in your unit test, or in my case, it will be an integration test, you can just say, hey, I want to start a Postgres container when I start the test, right? So this hooks into the lifecycle. So you do need to annotate your test properly. And you can say, I want the container to use Postgres version 12. And here's the parameters I want to set. And then you can add additional calls into a script or something else that sets up the database for you, or you can use Spring Boot to bootstrap it for you. And then you can override the data source configuration to point to that specific test container. And so that when you run your test, remember, my application doesn't start, but my test will start, because when you run the test, you will actually automatically start the test container behind the scenes, and it will start my Postgres container in my Docker daemon. And I continue to wait for it to run the test with the new configuration, and the test passes. This by far has been very, very helpful for me, either testing with external resource, or sometimes you can even spin up external services or external service stubs or mocks that you can use. So for example, in the cloud, rather than depending on the real cloud services, I can spin up emulators with this so that I can emulate my interaction with the cloud, right? And this will help you with the fidelity for the local development environment, which is what I do recommend. Always start from the test, make sure your test can work and can run, and then every other following steps will be significantly easier. Okay. What I also learned is from Sergey Egorov, who wrote who wrote test containers, many of it. Is also has a blog here that talks about how you can actually tie this into your application. So with Spring Boot, you can actually start your application that also starts the container. So you can completely bypass potentially Kubernetes or even Docker Compose, and you can just start your application that will start all the containers for you, which is super, super useful. Okay. So that's about your application and your services. Now, when we're talking about Kubernetes and microservices specifically, another thing that people always ask is, well, there are two things. One is, how granular should my service be? And the other one is, should I use a monorepo versus multi-repo? So I'm going to talk about monorepo versus multi-repo first. This is like the defining question on what people, because we're writing code, right? So we have to decide where to check in the code, because that's the first factor in the 12-factor app. So we got to check it in, but do we do monorepo or multi-repo? And to some people, this is a philosophical question of whether you're creating a distributed monolith or distributed service. Because if you're creating monorepo, then even though you're creating multiple services, but they are still compiled and created at the same time, they're versioned at the same lifecycle. So potentially you could be creating a monolith that just happen to be running over a network. Or are you truly building a distributed services, right? That's really the difference. However, I think that through my learnings in this project, right, and many others, is that it really depends on many other factors, right? This is the philosophical ideal comparison, right, that we want to create distributed services, but the reality doesn't always match it. Why? Because there are so many pros and cons to either approach, and it depends truly on your current team structure, your current organization, and your current capabilities. Why? Because there are many, many things that's a lot easier in monorepo. In monorepo, you just need one repository, and so you can actually do your dependency management really, really easily. You can build with a single CI/CD pipeline. That's super easy to do. If you update one of the common libraries, you just rebuild the whole project and everything's up to date. Super easy to do. So initial velocity of a monorepo is very fast, right? You can get started really quickly. However, we do know the long-term downside, which is that as your code base grows bigger and bigger, larger and larger, it's going to slow down the build. And we do observe this very quickly, right? But that is the downside of it. With a multi-repo, you can build each individual project much faster. However, initially to set this up, now you have to consider many, many things. You gotta figure out the naming convention for your repository. If you have common libraries, how do you actually make sure that other repository gets the latest version of your common library? Now you need ways or bots in GitHub that helps you to automate some of these dependency versions. CI/CD pipeline. Now, rather than CI/CD pipelining just one repository, you need to do it for multiple repositories. What if you get the CI/CD pipeline incorrectly the first time? Now you have to go back and fix every other ones, right? So there's always these pros and cons that you have to decide. So one of the things that we have done in this project, which I learned from one of the TLs in the project, is that he writes everything down into a document. And we discuss the pros and cons of all of their approaches. This is just one example of this, right? Monorepo versus multi-repo. What is good, what is bad, and what do we decide on based on our current situation? We actually chose to go with monorepo, okay, which is surprising, but it is the reality. Why? Because the team was familiar mostly with monorepo. The team was very small. We started off with like a couple of people. There's no way for us to manage multiple repository at that time, and they needed to move fast. So we don't have time and the effort to actually improve the multi-repo experience. So we gotta move. So we have to make a choice, right? And we don't have all the existing dependency or artifact management infrastructure. Like, so for example, for Maven artifacts, where would you publish that? Like, do you need to use Nexus or do you want to use Artifactory? And now you have to set all of those things up and manage them. We didn't have time for that, and so we chose monorepo. Right? So it's always a comparison, pros and cons against the reality. But the important thing is to write it down somewhere. However, as we're doing this, we're always anticipating that multi-repo still is the future, right? So even though we went in with the monorepo style, but everything that we do in the monorepo is still anticipating the multi-repo approach, right? So what that means is that we are able to design the repository. Again, I'm going to go back to design, which is really important. We design the repository in such a way that even though we started off with a monorepo, we can still split it later. Okay, it's completely splittable, and we are able to split a few services out, in the past, and we can split all of them out if we want to. Okay, and that is about designing and anticipating for the future. Same thing with the service granularity, right? Do you start with very fine-grained services, or do you start from a bigger service, right? And in some cases, a monolith service, which is completely fine. You do have to compare the pros and cons of the approach based on your current situation, and maybe it makes sense to make a monolithic service to start with, which is fine. However, even if you have done that, you need to anticipate the change so that in the future, you definitely need and will break down those services into finer grained deployment units as opposed to a single unit, right? So you have to design it well to anticipate this change. So, for example, in the build structure for our monorepo, we make sure that every service is broken out right individually, and their dependencies are done not via the file path, but via the actual artifacts. So that we're using Gradle to do that. So, for example, we can apply some common Gradle file, which we know we can extract even if we have a multi-repo service. But also for all of the dependencies, like these dependencies that depends on the project, they can easily be extracted and refactored to depend on the actual Maven artifact, right? So that when we extract it from the monorepo, like you don't have to change a lot in your application at all, right? It's because every line here is about the dependency that you would otherwise just change the where they live, really. Okay. So here's the learnings for this particular section, which is that consider the risk outside of the technical choices. That's really important for me. Yes, it will be nice if everything is just a multi-repo and we can create multi-repo with a click and everything is just there. But the reality is that doesn't happen overnight, right? And so we have to consider all the issues outside of this technical choice and and move forward. However, always anticipate the change because your choices today may not be the best choice tomorrow, right? Which is reality. But you do need to anticipate that change and design things well. And my biggest takeaway was to always document the pros and cons and design decisions of why. Now, for the service-to-service communication, again, this has nothing to do with Kubernetes in general, right? Because Kubernetes to me is the deployment platform. So in this case, even for service-to-service communication, we talk about, well, we need to decide on, what protocol do we use, right? Do we use gRPC or do you REST? gRPC is nice because it's binary protocol. Everything has a protobuf definition, so you can define your payload up in front. For REST, it's really loosely coupled in a way, and everyone can go wild with the REST, payload and the schema, right? But you also have to have discipline, so maybe you will end up using Open API, and you do need to have the schema for your payload anyways. Right? And we chose gRPC mostly because the people understand gRPC. It is an internal project, so people have been using gRPC or Stubby internally for a long time, and so for them, this was a natural choice. However, there are always downsides, which we did list, but they are okay with the downsides of using gRPC versus REST, and they make that choice. But the proto, it was really useful, of course, because the schema was really easy to write. It's very concise, unlike some of the schemas in the past, like WSDOs and even Open API schema, they can get really complicated sometimes. But gRPC is very straightforward in this case. And then with gRPC, we can then export it to other languages too. So even though our backend is in Java, our frontend is in TypeScript, and so they are able to convert these definitions from the proto file here, and then we can convert it into the front end so that the front end can also make the same call with the same payload. And now everything becomes type safe, and it's really, really nice. Okay. Now with the protofiles or with schemas, again, there's always a choice of whether do you store the protofiles with individual services or do you store the schemas globally in a single location, right? And I think that again, it's the same idea of whether you're being, choosing monorepo versus multi-repo. There are pros and cons for all of them. And I think we ultimately chose to store, actually, it is actually a good choice to store all of these definitions with the service because your service defines the contract with that is willing to expose. So it makes total sense to document the contract along with the service itself, as opposed to document the contract in a global location somewhere else, right? So this is what we chose to do. So underneath each individual services, we have the proto file, which is the service contract and the payload definition that we are able to share with other services. And you can actually build the proto file into a jar. So now it becomes an artifact. And then your other applications who are trying to consume your service, you have access to the definition file itself. And what this will do is to actually take that definition and it will regenerate the client library for you. Okay, so you don't have to ever write your own clients anymore. You don't have to stub out your POJOs. This will just be all automated for you behind the scenes, which is again very convenient. And the way that we wrote this again is that, even though right now this is using Gradle's expression to get the file from my project, but it's also very possible to replace this so that it gets the file from the Maven Central or Maven repository instead. Okay. Now with gRPC, we also needed to expose the services up to the browser, right? Because the browser is making all the user interactions, and they need to call back to the services that we have. Now, the thing is that most of the browsers don't speak gRPC, even though they support HTTP2, but they don't actually support everything that's required by gRPC. Okay, so what is necessary is some transcoding in between. And the transcoding is mostly well known as gRPC-web or gRPC web. You can find the spec for that. And for us, we are using something called gRPC transcoding with Envoy. So in the Envoy proxy, the web proxy, it has built-in capability to actually translate the gRPC web, the regular HTTP1 payload, into gRPC call to the backend. We went even further by using something called Istio. Okay, now what is Istio? And what does that do? This also was very interesting for me because we made the choice to use it. The idea here is that Istio supports many of the capabilities that you need to manage your microservices to service communication. Okay, if you think about Kubernetes as a deployment target, Istio is a way for you to manage your service to service communication. So you can have routing rules to say, if a call made to /API/v1/auth service routed to this service for version 1, right? If the call came into a different URL, you can route it to somewhere else. So you can add these routing rules. But what's more important is that you can also add retry rules, right? So even though we're using Spring, we're not actually using the Spring Cloud OSS stack. We're not using, Hystrix. We're not using Thing, or we're not using Ribbon to do any of the load balancing and retries. We're just cutting down all of those things from our application, and we depend on Istio to do all the retry for us. And we also depend on it to do the circuit breaking and distributed tracing and monitoring. So we offload a lot of these concerns just to Istio out of the bat. And the way that it works is by, if you don't know Istio, this is how it works. Essentially that it deploys your application with a sidecar pattern. And so what happens then is that your microservice runs alongside of the Istio proxy, which happens to be Envoy. And when you make a call out to another service, your request is intercepted by the proxy. And the proxy will then determine which backend to send to, because the proxy actually has a list of the backend you can load balance to. And you can also configure it to load balance differently. Okay, and the proxy will then forward the request to the target destination. And the target destination also intercepts the request via the proxy and determines whether you are able to make this call or not, because Istio has security rules. So you can secure your services and you can tighten it down to say, only microservice A can call microservice B. And then once the proxy understands you can actually make the call, then it forwards the request to the actual service. But what is really interesting is that throughout this entire process, Istio actually can know, for example, how long did this request take? It can know all the topology of who is calling what, and you can know the performance metrics, and also that we can enforce these policies and security rules. But what is the most important is that what we needed, because we're running in untrusted environment, right? We're not just running in Google Cloud, we're running other places. So in these other untrusted environment, we wanted to have mutual TLS. So Istio can actually give you that capability as well, so that when I make a call out from service A to service B, that communication is automatically secured via mutual TLS, and so we don't have to worry about this. Now, that is the primary reason why we chose to use Istio. Okay, and then we can add all of these routing rules to it. So, for example, we can map, this particular prefix to a specific service. We can do canaries, and we can do blue-green deployments. We can even do traffic splitting with ECO too. So there's a lot of good things that comes out of this. And also the transcoding. So we, rather than configuring the proxies ourselves, we just tell Istio that this is a gRPC web port, and it will do the transcoding for you automatically behind the scenes. However, now all that being said, this is all in production. For local development, we don't use it at all. For local development, we want the environment to be as simple as possible so that we can iterate much, much faster. And so for the local development environment, we don't use Istio at all. We assume a few contracts that we will have in Istio, but other than that, we don't install this at all. And this is important because, the more that you lay into your development environment, like if you were to use Istio, now everybody has to learn about Istio. That's number one. Number two is it is actually not that easy to learn. There are so many things that goes on behind the scenes, which, if you have a team of 10, like a lot of people might be stuck, right? And if you do run into issues, you're gonna troubleshoot Istio as opposed to troubleshooting your application. And you might argue that, yeah, that's actually not bad because you do want to fix those issues up front and early, but that's fine. But you do that in the dev or in the testing environment, which you can find this out as well. Okay, focus on the code in the dev environment. For containers, the building the actual containers for these microservices, there are a lot of things to consider. Like I have a whole 1 hour talk around this, right? It gets very, very involved to understand how to actually create a container that is production ready. For example, how to make it small, how to layer it properly, how not to run as root, right? How do you create a small image and in the versioning, all of these things. But nowadays, I just say, I learned this from my friend, Matt Rabel, who works at a company called Okta. He always say, friends don't let friends write security or write authentication, right? Because authentication is, it's always the same, it's repetitive, and it's error prone. So what I'm going to copy him, and I'm going to say something different. I'm going to say, friend don't let friends write Docker files. Why? Because Docker files can also be complicated to write, it's repetitive, and it's also error prone. So whenever you can, automate the process. So nowadays, I just say, just jib it. If you haven't heard about jib, you can try this out. It's really just a plugin for your application, for your Java application. All you need to do is to add a plugin here. Yeah, there's the plugin. And you can say, I want to use jib to build my container. I want to build it to this container coordinate. I want to use this base image. And I want to not run as root. And that's really it. And there's no Docker file involved. In fact, there's a Docker file here. I will just go ahead and delete it because I don't need it at all, right? And then what I can do then is to say maven jib, let me see here, jib build, yeah. So I can say compile and maven jib build. I'm going to skip the test for now, skip test. And what this will do is to actually compile the code, create a container for me, and go straight to my container registry. There's no Docker file whatsoever. And that is super, super neat, okay? I know that in Spring Boot 2.3, you can also use the build pack with Spring Boot. Again, you don't need to write a Docker file. Just use the automated tool for you to do it. For Java applications specifically, you do need to be aware of the JDK version. People say just containerize it and it will work. That's not true if you containerize with the wrong version of the JDK. So for the older applications, make sure you containerize with the newer version of the JDK so that they become container aware. Okay. And also in terms of memory usages in the containers, sometimes you do need to know how much memory is being used. For that, you can use, in Cloud Foundry Build Pack, they have a memory calculator. You can actually use that to estimate how much memory you actually need to allocate for your container. And that has been pretty useful for me. And finally, if you do need to know exactly how much memory you are using in your microservice, in your container, so that you don't go over the limit, then you can unlock certain capabilities in the JVM itself so that you can actually print what they call the native memory tracking summaries. So you can see the breakdown between the native memory usages versus the heap usage. Again, something that's useful for your application before you go into production. Now, finally, right, after you design your application, after you design your repository, after you design your service-to-service communication, and now we can deploy the app. This is why I keep Kubernetes to the last, right? Finally, we get to talk about Kubernetes. Now, for the local development, we do want the developers to have some kind of fidelity to learn about Kubernetes. Okay, this is by choice, right? If you develop everything without Kubernetes, that is also perfectly fine because you just have to package it up in this container and somebody else can deploy it. But it's also fun, and for this team, they wanted to learn about Kubernetes, and so we evaluated the different ways to use this, right? So the team actually started out with Docker Compose. That's not Kubernetes, but they start off with Docker Compose to run multiple containers. But now, because it is too much different from Kubernetes, from the environment they are actually going to be running on, so we decided to run Kubernetes locally. Okay, and it's a decision between, do you run a remote cluster or do you run a local cluster? There's pros and cons for each. We decided to go with local Kubernetes cluster because it's much easier for us to set it up individually, and everyone can experiment on their own cluster if they need to. And there are a couple of choices here. One of my favorite is this called K3s. So if you haven't used K3s before, it for me was one of the simplest way to get started on Kubernetes in a Linux environment. If you have Linux, just go to this page, and then you can say curl if you trust it, right? Just run this script, and in about 30 seconds, you get your Kubernetes cluster up and running. So for example, if I do the same thing in my Linux environment, I already ran it, and I can say kubectl get pods. No, I think I need to do a sudo here, sudo. Yeah, and I have my Kubernetes cluster up and running. This only took about 30 seconds when I installed it earlier, just before the talk. Okay. The other one is called kind. So let me see here. I do have sudo docker ps. Kind is another Kubernetes cluster environment that you can run on your machine, especially if you are using Linux. Yes, but kind stands for Kubernetes in Docker. So basically, as long as you have a Docker daemon, you can use kind. So you can probably do kind create cluster. Oh, kind. I think I have it here, right? And what this is doing is actually starting Kubernetes in my Docker daemon itself. So this is another way to really quickly start a Kubernetes cluster locally. And now you can deploy and test your application in your local Kubernetes environment. Okay. And this is also useful if you're running like a full end-to-end integration test where you do want to have Kubernetes to be running, but this is part of your CI/CD pipeline. Then you can use kind to start a temporary cluster for you and deploy everything into it. And then at the end of this test or at the end of this pipeline, you can shut down the entire cluster in just one command line. Okay, and that's super useful too. And then we have tools for our local development. So for example, here in my example here, I am using something called, I'm using IntelliJ IDE, but I'm also using something called the Cloud Code plugin, which is right here, Cloud Code. Yep. So here's Cloud Code. And for Cloud Code, we can actually add Kubernetes capabilities into your application as well, so that we can actually run your application in Kubernetes if you want to have that type of fidelity. Well, what does that mean? Well, first of all, we do need to create something called a scaffold.yaml file. Scaffold is really just a way for you to automatically detect changes in your application, okay, and then rebuild your container, and then redeploy your application into your Kubernetes environment, whether it's local or remote, so that it gives you a feel of or fidelity of local development, but it's actually running in a remote cluster potentially. Okay, and with the IDE, what we can also do is to say develop on Kubernetes. And if I click on the run here, what this will do is to actually code scaffold, and based on this configuration, it's going to monitor my application changes in the source code, and it will actually go ahead and use Jib, for example, to create my container. I think I may need to run this from somewhere else. But it will use Jib to create the container, and then ultimately what this will do is to deploy everything into my Kubernetes cluster. And then finally, if I were to make any changes in my Kubernetes YAML files, it will automatically redeploy the stuff for me. So this is a really easy way for the team to experiment with different settings and configurations and just redeploy it and see if this is the behavior that they're looking for. Okay. Again, this is only done after you have done all the testing too, right? So testing is always first, but then after you think that your application is pretty much ready to go, you can use this capability to really easily, get that deployed into a Kubernetes cluster. On the right-hand side, you can also see a bunch of clusters here too. Like here, you can see a bunch of different clusters that you can choose to use, and everything can be integrated as part of the IDE. Okay. Now, let me move on just a little bit more. If you want to create your YAML files, there's an easy way, right? You don't want to create the YAML file manually, so you can use the command line like kubectl create to create the baseline of the YAML file, and then you can edit it later. Another really cool tool is called Decorate. We're not using it, but I found it to be really, really interesting. I might use it in the future in a production environment, right? I tried it out in non-prod, but I probably consider it. What Decorate can do is to automatically understand and examine your application. Like this is a Spring Boot app. Okay. Are you using Actuator? Yes. What port is on? Port 8080. Okay. And Decorate will automatically create the Kubernetes YAML file for you with the health check endpoints behind the scenes. It points to the actuator that you're actually using. Okay. So Decorate is certainly a tool to look at. Just like we don't want you to write Docker files. You can also avoid writing YAML files if you can. Okay. We talked about scaffold just now. With the rest of the time, I just want to say one last thing, which is about really important contract in Kubernetes with your microservice, which is the liveness probe and the readiness probe. Okay, so when your application is running in Kubernetes, Kubernetes needs to know whether your application is alive, because if it's not, it will try to kill it when you restart it. And the second thing it needs to know is if it's ready to serve traffic. Why? Because if you're not ready to serve traffic, it's meaningless to add it to the load balancer. Okay, so Kubernetes will check two things for you. One is whether your application is alive, and what you put in the liveness probe, you can respond this via HTTP. So if you respond 200 success, then you're alive. If you don't respond in time, then you're dead, and it will try to restart it for you. What is really important here is that a lot of times I see people putting health checks as the liveness probe, because health checks against the downstream health, like if your database is up. My question to everyone is, if your database is down, does a restart of your application help to bring the database back up? If the question is no, then do not put that third-party component in the health check for the liveness probe. This is very important, because if you do it this way incorrectly, then what you might get is a cascading failure. Imagine if another service who depends on you puts you in their liveness check and you failed, and now they're going to fail, and now your entire system is going to fail. Okay, so for liveness check, just keep it simple, just respond 200. For the readiness probe, this is where you can say, is my application ready to serve? Is the connection all established? Do I have all the cache loaded? Is my application ready? If it is, then we turn on the readiness probe, and now the Kubernetes will reconfigure the load balancer, and then all the requests will come through. Okay, and this is finally how you actually deal with graceful shutdowns. Okay, by tuning and understanding these lifecycle hooks that Kubernetes give you, so that you can actually have a really low downtime as you are deploying new versions of your microservices. If anything, you need to have these two probes. And then the secondary thing will be dealing with a graceful shutdown. And this is the proper procedure to actually have a proper graceful shutdown, which is that Kubernetes will send your application a SIG-term signal. And in Spring Boot application, for example, it handles that automatically. And then you need to fail your readiness probe so that Kubernetes will delist your application from the load balancer. Okay. And then, but this will take time. It takes about 30 seconds or so. There's a configuration you can add. And then once the Kubernetes removes you from the endpoint, you still need to finish serving the in-flight request. You don't want to shut anything down until you finish with all the in-flight transactions. And then you can shut down gracefully. And that is the anatomy of a really sophisticated graceful shutdown. Not every application needs it, but this is the one way of doing this. Okay. That being said, I think I'm pretty much in the end. Yep. So the road to production is hard. And there's a whole lot more that we have to do to just get to the production environment, right? So we have the VPC and NIT and all of these other things. I have a separate talk just to talk about all of these things, more things in detail. But just remember, development is not the same as the production though, because the production road is difficult. And with that, I'll leave you with the last slide, which is all the things that we talk about in the summary of the learnings that you can probably screenshot and have a good takeaway. Okay. So thank you so much for being here, and thanks for having me here for the second session.
Thank you so much, Roy. We are out of time, but I've got a couple of questions here from the guys in the Almedina chat. So Mario Dago asks, why does a monorepo means build everything together? We can have a monorepo with multiple projects and have multiple build pipelines targeting different folders.
Correct. Yes, that's also true as well. Yeah, absolutely. That's definitely true. But if that's true, then it might as well be easy to split it out as well. We definitely considered that option too. And we still chose a monorepo as in, you build one thing, you have a root that builds everything. Yeah. But you're absolutely right. You can also have a monorepo that has the services built independently from each other. Absolutely.
Another question here now from Jose Rosa. He asks, how much overhead does this ECO sidecars add to our services compared to using the Spring tools, for example?
As opposed to using the build like Spring stuff, right?
Yeah.
I actually have not done the research or the test myself. But if you think about it, they're pretty much trying to do the same thing. It's just one is externalized to an external service, and the other one is built in your application. That being said, I know that they have done a lot of tuning in the proxy itself. So it used to be not too good, but with ECO newer and newer versions, it's definitely getting better and better. So I'll be interested to run that test as well. But just remember that proxy is actually written in C. So that proxy is built and battle tested by Lyft, the company here in the US, that they are serving their production traffic. So it is made to be very efficient. Now, of course, without the numbers, it's hard to say how much more efficient it will be. Yep.
Okay, so one last question so we can wrap this up. Mario Dago asks again, any suggestion for scaling up or down the number of instances of a microservice based on the number of requests, response time, etc., other metrics, basically?
Yeah, so the Kubernetes HPA give you the option to use CPU and memory, but that's may not be the best indicator. One of the things I learned also previously was what defines the load for you. Okay, that's very important. What defines the load? For the longest time, I think in my entire career in the past, I think about load balancing as just random load balancing to different instances. And that assumes every request produces the same load. What I learned from the gRPC team is, well, first of all, what defines the load? If the request defines the load for you, then load balancing based on the request makes total sense, right? That being said, if you do want to load balance on the request based on the request latency and also scale out because of it, I think that Kubernetes built-in will be slightly more difficult. What you might want to look into is the newer or the higher level platform like Knative. So with Knative, or even if you look at App Engine and Cloud Run, they all auto scale based on the latency of the request. But that's assuming it's because in their paradigm, the request defines the load. And so you can definitely do it. So for example, it will depend on quite a few things like your max latency or the pending requests as well. Because sometimes the load balancer will queue up the request in the load balancer. So you can see how many more requests is coming in, but it hasn't been handled. So there's the pending request, and there's the pending latency, and there's the actual latency of the request that can indicate slowdowns. And you can auto scale based on all of those. And to do that, you gotta look into something like Knative instead. Yeah.
Okay. So we have one last question. We are running way out of time, but we have George Nikolai here on the YouTube chat that asks, all of those should be done by the developer, and is talking about implementation changes in order to adhere to cloud native 12-factor, or maybe would you split these kinds of decisions and time between the dev team and infrastructure team?
Yeah, I think I wouldn't say that any decision that we made was a split decision from one group or the other. Okay, what that means is that yes, in many companies, there's still the team, just from the organization structure, there are different teams. However, these decisions is important to have common understanding and agreement. So we don't actually, make decisions unilaterally on one team or the other. It's very important that we present the issues and the other team will chime in, right? We do this together and we document it together. That's very important. One thing I do want to say though is that because we are using Kubernetes and containers and Istio, for example, what I found personally that's really interesting is that the development team and the people who are creating the infrastructure, we are now speaking the same languages. Okay, it's like the development team might say, "Oh, I need to have a deployment to there," and the other team would immediately understand that they need a Kubernetes deployment. The other team would say, "We need 3 replicas." That's again the same terminology, or that we need an invar, we need something. So now we're sharing the terminology based on the Kubernetes terminologies, and that's really, really useful. Okay.
Yeah. So we really need to wrap this up. Thank you so much, Ray, for the talk, and thank you so much for the interaction with the guys. You have a lot of people saying thank you for a great session on YouTube chat and so on. And as I said in the start, we hope to see you back at Coimbra next year.
Same here. Yeah,
Definitely not to make fun of our internet, please. A good one.
I'll bring my own hotspot. I'm just kidding.
I'm joking.
But,
Thank you so much, Ray.
If you all have questions, you can find me on Twitter or on Slack. Thanks for having me here.
Thank you very much, Ray.
How do you move from here to there, to that world of cloud-native architecture? I like to talk about DevOps, the concepts of DevOps, the principles, practices, tools, and techniques that you apply, and when you learn DevOps, make a fundamental difference in the way you build software and the way you deliver software faster. Red Hat fundamentally loves Linux, and that's absolutely true, but we also love Kubernetes, and we love Java.
welcome back, everyone. This was a very short break. Sorry about that. We moved a little over time with the last session. So now we have Rafael with us. How are you, Rafael?
I'm fine. What about you, Daniel?
I'm fine. Getting a bit tired. We are on this for like I don't even know, 13 hours already, something like that. So yeah, it's getting tiring, but it's close to an end. So
exactly. Here in Brazil, it's 6 p.m. So it's almost the end of the day as well. But we have people on the East Coast or West Coast of the United States, for example, and Canada watching us as well.
Yeah. Here in Portugal is 10 p.m. already, and we started at 9:30 more or less. So a.m. So yeah, it's been a long day, but a very, very full day with very interesting talks. And you are the last speaker of Almedina Room. So you're actually wrapping up this track. So
let's make it a success.
Yeah, I hope you can deliver. So, Rafael, without further ado, I'm gonna give the floor back to you, and I'm gonna get questions from the guys in Slack and YouTube channel, and I'll relay them to you at the end of the talk.
Perfect.
So, good luck, Rafael. Go ahead.
Okay, so let's start. As I was announced, my name is Rafael Benevides. Actually, nowadays I work at Oracle in the Linux team as a solution architect and a cloud native development advocate. And of course, Java is my main language. So it's really a pleasure to be here at Jnation talking about Java technologies. And of course, before I start, I'd like just to invite you to visit developer.oracle.com and cloudnative.oracle.com to know more about development and cloud native technologies. But let me tell you a story. There was one day that I was here in Brazil with my niece. She was 4 years old at that time. And I was with her and my brother in a zoo. We are seeing all the animals